no option to create your own answer. So it's like you have to answer these 15 security questions. What?
And with the Adobe leak of the password hints,
Yep.
You know, at Paswords16 that year, we were doing, you know, when we had lunch, we were doing crossword puzzle with those. Yeah. And, you know, ever since that episode, you know, security questions shouldn't be used for online security. That's my opinion.
And security are different. I mean, security questions could be different, but some of them, they ask you for favorite things. Favorite things change. Favorite things last year was different than favorite
Jim
things.
has a perfect blog of, you know, collection of stupid security questions. So that's one of them.
Yeah.
So yeah, if you have any, do send them to Jim.
Yes, I do. Send them to me.
Okay.
And there are all these variations in the answers. If you went to Central High School, capital C or lowercase c, Central High or C.
Yeah. I mean, capital.
Okay, it's 10 o'clock, so we're going to start. Before I introduce the two first speakers, I also just want to tell you that the next talk, Making Password Meters Great Again, from Adam Caldwell, is cancelled, and it will be replaced by Michael Spacek, and he will be talking about how websites are storing and disclosing how they store your password. And he's basically crowdsourcing a list of companies that will actually tell you how they store your password. So either you can be on the good list or you can be on the shit list. So that's going to be the 11th. And then I can do the official introduction. Crafting tailored word lists with Wordsmith, Sanjeev, and Tom from Payment Software Company. Please go ahead.
Thank you. Yeah, thanks guys for coming out. There's a lot of cool talks happening in this 10 a.m. time slot. So yeah, we're thankful you guys came to this one, and we're sure that some people had a late night last night. So thanks for making it to this one. Some quick formalities. Tom's the guy with the beard. I'm the Canadian. Don't hold it against me. We're both pen testers with PSC. PSC specializes in PCI assessments as well, and we also do pen testing in non-PCI contexts. Our day-to-day kind of just involves going through large enterprise organizations and going through various network segments trying to find cardholder data. We're also looking for pen testers, so if you know any or if you're interested in pen testing, either come and see Tom and I after, or Joe over here in the front, and we'll be happy to talk to you. So before we jump into a quick primer, what's Wordsmith? Well, it's just basically a tool which can generate dictionaries. The only thing that we're doing differently is that we are generating dictionaries based on US states and specifically geolocation data. Geolocation data can just basically kind of be boiled down to cities, landmarks, zip codes, area codes, towns, and that sort of thing. We'll get into exact sort of data sets that we're collecting, and we'll also go into some statistics a bit later. But we're taking these word lists and we're just going against and cracking against large hash sets, or just hash sets in general, to identify what sort of passwords people have and if they're introducing geo-based passwords into their phrases. So yeah, we're going to go through a quick primer here of just basic authentication process, as well as the difference between passwords and hashes and dictionary tags. We've timed it. It should take about 3 minutes. It's about 8 slides in total. For those of you who already know about password attacks and dictionary attacks and hashes and that sort of thing, there's going to be an image on the next slide here. And if you can tweet us the hash type that's in this image, we have some swag that we're giving away. So we've got like Case Logic backpacks and I think phone speaker amplifiers and a single selfie stick for someone who really wants a selfie stick, I guess. So that's our Twitter handles. I think it's also in your brochures. Or go and check out Wordsmith. I just made the repo public, so you can find it there. And I guess just as a quick show of hands, how many pen testers are in this room? Does anyone do pen testing? Joe? couple of guys over there? Great. So if you've ever done any sort of man-in-the-middle attack on your network, and I guess if you're a blue teamer who's ever done a man-in-the-middle attack on your network, this hash type should look pretty familiar to you. So yeah, here it is. You've got kind of a couple seconds here to take a look at that and send us a tweet here at our Twitter handles, and we're happy to give away some swag after. But for now, we'll head back to the primer, and Tom is going to walk you guys through the primer.
Thanks, Sanjeev. So let's talk about a simple authentication process. This is Bob. in the extent of my Microsoft Paint skills. Despite what Bob's prohibition-style hat might suggest, Bob is a user in a Windows environment. And this is Bob logging into a Windows host with a username of Bob. And this might be locally on a workstation. In order to unlock it, this might be remotely via something like RDP. And we've taken the liberty here to unmask the password field so you can see that Bob's password is Pasword123. On submit, when Bob clicks enter, that input of Pasword123 is put into a one-way hash function. And the output of that is a fixed length character string, which you see represented below. That's what we call a hash. And what's important to note here is that this is a one-way function. We can't reverse this process by putting a hash into the hashing function and retrieving the original clear text password. So after we've hashed the password, we put together Bob's username and password hash, and we send it to the authentication server. This might be locally in a SAM database. If you're joined to a domain, this might be Active Directory domain controllers ntds.dit. This backend database holds, and this is a little bit of an oversimplification, but this backend database holds a listing of all the users and their password hashes. So we're not storing passwords in clear text here. And from there, we basically just do a lookup of Bob's supplied credentials. We find the record for Bob, and we match the supplied password hash with the stored one. If it's correct, we allow the login. If it's incorrect, we'll bump up the failed login count and deny the login. So we can't reverse this hashing process. So how do we convert a hash back to its original string? The answer is there's no direct way. But what we do have are a very particular set of words. Words that make password cracking a nightmare for hashes like these. And particularly we use a dictionary attack. So what are dictionaries? They're simply just large list of words, usually grouped together by some type of theme. So they might come from password breaches like LinkedIn or Yahoo or Adobe. There's also great word lists out on the internet that you can find for free, like RockU or Top10K. There's even some paid ones like Unique. Despite its price tag, Unique is a password list that any pen tester or auditor should have in their toolkit. So in order to carry out a dictionary attack, first we need a few prereqs. First is a solid dictionary or a good word list. Second thing we need to know is the hash type. So in this case with Bob, we're using NT hashes or NTLM. If you're authenticating against a Unix or a Linux type server, it's going to be some variation of MD5 or SHA-1, usually with a salt. The third thing that we need are a list of password hashes. These are usually exfiltrated from compromised systems, maybe like a local Windows workstation or an Active Directory domain controller. And these are what we're doing the lookups against. So the steps for actually carrying out a dictionary attack boil down to this three-step process we call the guess, encrypt, compare cycle. Our guesses are words that we're plucking from the word list, and we iterate through them one by one. From there, we take the input word and we put it into our encryption algorithm, in this case, an NT hashing algorithm, and it gets outputted this fixed length string. Then we take that hash and we do a lookup against our list of obtained password hashes. If they match, then we know we can map that back to the original word that we guessed, and we have our clear text password. And Sanjeev will move on to Wordsmith.
Yeah. So as we mentioned briefly at the beginning of the presentation, Wordsmith is just a word list generation tool for US states and I guess geolocation-based data. So what kind of geodata is in a word list? Well, we've got things like cities and towns. We also have landmarks. So in Nevada, you're going to have Area 51, things like the Hoover Dam, that sort of thing. We've got streets and roads. We have zip codes, sport teams, colleges, common names, and area codes. Now, why geolocation data? Well, it's really interesting. I guess it's kind of a marriage between curiosity and password analytics and just general human behavior. I remember I was testing, I was an internal penetration test for a client in a very small state. And as part of my post-exploitation process, I tend to go from system to system and scrape credentials out of memory, just using Kiwi or Mimikatz or something like that. And that usually enables me to collect a large amount of passwords to then enable me to move into another network segment or access applications which unlock greater depth into that environment. Now, collecting all these passwords, I realized a common trend for several of these users, and that's I couldn't crack these because these are specific geolocation-based passwords that weren't going to exist in any sort of password list that's currently out there. Things like sport team names or colleges or other things that might be related to geolocation. So I thought to myself, well, it'd be pretty neat if someone put together a word list generation tool, and then that kind of transformed to, well, we'll just put together a word list generation tool for geolocation data. And as we'll get into some statistics a bit later, we kind of found out that we've limited some guess, encrypt, compare cycles and been able to actually turn this into something quite useful. So I should probably mention, where's all this data coming from? Well, Wikipedia and the US Census have a ton of this data, and it's readily available to the public. All we've done is we pulled it, scraped it, and put it into nice little phrases and words which appear in word lists. OpenStreetMap is another good source as well. We've also had to put together a collection of data sets for area codes because that was a little harder to parse using our parsing engine, so and required a bit heavier parsing. So we actually have some custom data sets which we made as well. So Tom is going to talk to you about how Wordsmith works, and then we're going to jump into a demo. So yeah, take it away.
Cool. So the GitHub repo is live now. When you do your initial git pull, you'll see these files listed there. On the right, you see the actual Wordsmith Ruby file. There's also next to it the sources.yaml file. It's basically just a simple configuration file for all the internet sources where we're pulling down data. And we broke it out like that to hopefully make it a little easier in a modular design to be open to extension and for easier management of our internet sources. Next to that, you see a data.tar.gz, which is basically just a compressed data archive where we've already pre-scraped all of the data that we're using for Wordsmith and compressed it there. You'll also find a gem file just to make installation a little bit simpler. And there's a README there, which you'll see in the repo, that'll walk you through some of the dependencies and installation. So when you run Wordsmith for the first time, it's going to do a couple checks for some of its files that are needed. If it doesn't see them, it will unpack that data.tar.gz file and explodes it into the current working directory in a subdirectory called data. That data directory is mostly categorized by state, with the exception of some of the custom data that we've had to massage into place. At the top level, you'll see some of the directory for the area codes. Names, which we've pulled from US Census, is first names, last names, baby names. Sports, which are mostly big four sports in each state at this point. And then the states themselves. And below that, you see an example for what kind of files you would find in the California directory. So you see a cities.html there, colleges.html, landmarks, roads, zips. These are words very specific to that state. If you notice the .html extension, these are actual HTML source files that we've pulled down from our internet sources. And the reason we've done it like this is because we've added an update option within Wordsmith. It's a -u flag. So sometime down the road, if you'd like to update your data manually, you specify the update flag, and it'll actually go out to all the sources and update your local data repository for you. To parse this data, we're using gems like Nokogiri and Spider. And we do all these lookups offline, so locally, just for speed performance. So a word list that's been generated by Wordsmith kind of looks like this. And I'm using an example that Sanjeev went through earlier with roads from Nevada, particular Fremont Street. So the word as it comes out of Wordsmith looks like that. It's a capital F. There's a space in there. There's a period at the end. So we added in some just very basic mangling for words. So we can split on spaces and break out Fremont and street into two separate words. We can remove special characters. We can remove spaces. There's also options to convert all of the words to lowercase, if that's your preference. You can also specify a minimum character length. So let's say you've compromised a domain where you know the password policy has a minimum character length of 8. Well, you can specify the the minimum length here, and it will truncate all words that are not at least 8 characters in length. And now Sanjeev will take you through the demo.
I've seen some really bad things happen with live demos in the past, so let's hope this all goes well. All right, so is that text? How's that? Can everyone see that? Maybe go a bit bigger. Cool. Okay. So yeah, as Tom mentioned, these are kind of the initial git pull files. And if we just go ahead and run Wordsmith for the first time, you're going to see that all these files get unpacked. There's also a warning message that you see here where it says cool is not found in path. Now that's because I'm running Wordsmith on my OS X system. I don't have cool installed. But if you're running this on Kali or something, it's going to pick that up in your path variable and you'll be able to use cool. Now, the purpose of cool is because we've integrated support for things like domains and in-files. So for those of you who are unfamiliar with cool, basically if you specify a domain name, let's say client.com or facebook.com, it'll go out to that domain and it'll look for unique words and scrape it from that application. And the default cool settings, I think, stays within the scope of that domain name, and it only goes a certain recursive depth and follows any hyperlinks that take you to any other links on that scope. And it'll pull the client's name, it'll pull other unique words and strip out some of the common words like of, the, any connection verbs, things like this. And you can also have an in-file where you specify various client domain names. And all this is just to better populate this word list. So we've integrated support for cool. However, you don't need to use it because we also have some other options. Now, as we kind of mentioned, from a top-down approach, it all starts from a state. And typically, when I generate a Wordsmith word list, I'll use a -all option. And all is going to give me cities, colleges, landmarks, phone numbers, roads, teams, zip codes, and also names. Names. So names would be like common last names, baby names. You have no idea how many times I see a first name or a baby name as part of a password. Yeah, so I guess let's run through an example. So we'll set the state for California, and we'll look at some common sport teams there. So as you can see, these are all of the sport teams in California, and that's just doing a basic lookup on the HTML files that we've already pre-pulled. Now, these are great, but we can also mangle these and get every single permutation of these words. So as you can see here, we've got Sacramento Kings, Sacramento, and somewhere up here, there'll probably be Kings as well. And there's only one instance because there's probably some other teams here which have Kings in their name, but we also do a sort and unique so you don't get duplicate words and things like this. What's also pretty neat is that we do things like zip codes. So we've got every single zip code in Nevada, or landmarks. So if we set the state to DC, we can look at landmarks and we probably tend to see things like White House or whatever, like the Lafayette Building, things like this. Yeah, and if I guess we set the state to maybe Massachusetts, we can look at some of the colleges that exist there. So these are probably see Harvard or MIT at some point in here. Yeah. So as I mentioned before, these are just some of the options, the singular options that you can set for per state. We can also do multi-state. So for example, CA and Nevada, and grab me all the area codes for those two states. Now this is pretty verbose output. I guess the inverse of that would be quiet output. So let's set the state for California. We're going to grab everything we possibly can, and we're not going to have it as verbose as this. And so you can start seeing some things here of how many landmarks there are, how many zip codes there are, but this isn't really useful because we're not getting any words. So we can go ahead and output this to a file like california.txt, and it'll collect all this data and stick it into a word list for you. But as we kind of mentioned before, these are just the actual words themselves. These aren't the mangled versions. So we can specify the M flag, change that to California mangled. And now you can see that there's a little churning time here for especially the roads, because there's 250,000 roads that we're now going to have to mangle, which now outputs almost double the amount. So like Tom had mentioned earlier, we've split on space, we've concatenated, we've stripped symbols, and things like this. Any other options that anyone wanted to see from this help area, or see if a particular college that someone went to in a state shows up?
Can you compare the number of roads in California versus nationally? I'm wondering how much overlap there is and how much benefit there is to restricting it by state.
Sure. So we also have an option built in here for all, so you can churn through every single state and create a mega word list for everything as well. But so that's, yeah, it's totally an option. As you can see, you'll just start spitting out everything's just an array.
It doesn't sum it then.
Well, yeah, so but that's with the quiet option. If I remove the quiet, we're going to grab, basically, it's just going to keep on churning like that. Yeah. Yeah. So, sorry, is there another question?
I
Yeah.
was gonna say, how do you account for like local or regional businesses? Do you go ahead and specify the -u option and put in the URL?
That's a great option. Yeah, sorry, it's a great, yeah, so,
Repeat the question.
sorry, yeah, he said, how do you account for local businesses? So the -D flag for the cool integration. So let's say you're testing a particular client. The client, there's probably going to be some password variation in there that's a client name 123, and so that cool integration will scrape that client's web application, pick out that client's name, and put it into this word list for you as well. I don't actually have internet connectivity here because we're at BSides, and I don't want to connect to Wi-Fi, so I can't show you the cool integration aspects of it. But yeah, that's basically what our Wordsmith demo is. And what's really interesting are some statistics that we're going to kind of show you guys. And I think you've heard me talk enough, so I'll let Tom kick that off.
Cool. There we go. So we wanted to measure how effective geolocation-based word lists were. So to do this, we did a couple of tests. Some of the prereqs for this test, we first built a hash cracking rig locally in our shop. And we got our hands on some real NT hashes. So we grabbed some hashes from actual real-world internal penetration tests from clients in Massachusetts, it's a little over 400 hashes. Wisconsin, about 2,000, and New York, which is about 500 hashes. The hash cracking rig itself, our weapon of choice for cracking NT hashes is Hashcat. The hardware is fairly modest. It was just an NVIDIA Grid K520. But even with that, we could get about 3 billion guess encrypt compare cycles per second. So we're turning through passwords fairly quickly. And just last week, Sanjeev put a post on his blog for those interested that want to build their own hash cracking rig. And he goes through the process of doing so in Amazon's for doing some advanced work. It's got about 57.
Kind of can be translated into 2011 Active Directory user accounts, which can kind of further be translated into 2011 employees, although that might not necessarily be true because there might be some accounts being shared, so we'll just say 2011 Active Directory user accounts. Now, as Tom had previously mentioned, the top 10K word list is just a collection of the top 10,000 passwords, things like password, love, God. Anyone who's seen Hackers will get that reference. But yeah, we're taking those 10,000 word lists and we're injecting those individual words into the dead hobo rule set, which is 58,000 rules. So these rules can prepend symbols, append numbers, lowercase words, camel case words. So for every single word, you're doing 58,000 different permutations of that word based on this rule set. So yeah, the 10,000 top passwords took about 2 seconds to run against these rules and uncovered 237 of these organizations' passwords, which means that 237 Active Directory user accounts had a password that was in the top 10,000 word list as a root password in their I guess, password string. Yeah, RockU uncovered another 1,094 passwords, which is now at 66% of a cracking success in total of all these hashes. And now our Wisconsin-generated word list took 12 seconds to run and uncovered another 11%. So that's 229 passwords. Now, what should be key here is that this Wisconsin word list is it solely consists of geo-based passwords. So at this point, we've cracked 66% of the passwords, but the additional 229 passwords are all things like cities, sport teams, landmarks, zip codes, and things to that effect. So there's a question over there?
Are they discrete, or would there be duplicates between RockU and Top 10?
There would be duplicates. So this is a collective cracking session. It's called, basically your hash cracking pot would be populated with 66% of these passwords at this point, and so it's a collective addition. So yeah, we uncovered another 11% of passwords that were all geocentric. Now, yeah, so if I remember correctly, Wisconsin, some of the really common passwords like Green Bay, Packers, first names and baby names as well. Massachusetts had a smaller hash set, about 400 Active Directory user accounts. That makes top 10K with the 58,000 rules run about a second and recover 52 passwords, which is about an eighth. And that's really surprising because it just goes to show that some organizations have really weak password complexity rules and enforcements. RockU recovered a staggering 65% in 24 minutes, and with the dead hobo rule set, and our wordsmith generated word list another 56. And again, this is all geo-based word lists, geolocation-based words, which are found after in about 12 seconds. And Massachusetts, I mean, people always use sport teams' names like Red Sox and things like this, but what's really interesting is you'll see a lot of city names as well, like Boston, Boston Marathon, Cambridge, and Harvard, and Fenway for landmarks as well. New York, 552 hashes and 552 Active Directory user accounts. What's really surprising with New York is that 0 were recovered with top 10K, which we can allude to several things here. Either the Active Directory domain controller has a third-party plugin, so this New York organization has imported a list of known compromised passwords or bad passwords into Active Directory through some sort of third-party module, which technically refrains users from creating bad passwords. Or as a non-technical control, they have just great security awareness programs or long and complex password requirements or things like this. That being said, the RockU word list, which takes about 26 minutes to run, uncovered about 220 passwords, and our New York wordsmith generated word list recovered an additional 59. And as you can imagine, some of the popular passwords would be landmarks like Empire, or I think I have some examples here. Yeah, Empire, Broadway. There's also one user in particular who had the state NY abbreviation, and then 5 numbers, which are the zip code, and then a symbol as part of his password. So yeah, Tom's going to kind of summarize that last sort of segment there.
Cool. So some of the conclusions of this. Oh, yep, go ahead.
I was just wondering, did you try the New York data, the New York hashes against the Wisconsin list?
No, we didn't. No.
Because that would be very useful to see whether you're actually getting value from paying attention to geography as opposed to just what's on these lists.
Absolutely.
So you need to do that crosswise.
Sure.
Yeah, so to further extrapolate that, we can also just do all states in general against that New York word list as well. But the real takeaway here was just kind of for that particular state and that guessed encrypt compare cycle. So for one state, it took 22 seconds, but for all states, it might take an hour. Who knows? We haven't actually tried to do that yet. But that's, yeah, great question.
So some of the conclusions from this testing, we got a little bit of confirmation bias here in that we'll get into the psychology of how users choose passwords, but we know that users like to choose passwords that are near and dear to them. They choose passwords off things that they know. The street they grew up on, the name of their child. And that's what we're seeing reflected here in our results. And with that, there's a little bit of a time CPU cycle trade-off in that instead of using a blanket word list and looking for low-hanging fruit, we're spending a little extra time up front to craft a more tailored list. And we're spending less time or less CPU cycles on crunching those less pertinent words. And it's a small sample size here, but with these cases, we cracked at least an additional 11% of passwords in a reasonable amount of time. And I think this speaks a little bit to the relevance of the generated passwords. So next steps for Wordsmith, where we see this going. We're always thinking about data. We have ideas for more. It's difficult to have to actually marry an idea for data and actually find good sources for it. But we like to expand on, say, the sports. We've seen users who love to have their favorite athlete or their favorite player as the base word of a password. Maybe team mascots or names of stadiums. You could include famous people like politicians or actresses or actors. State symbols, things that are very relevant to a state, such as the motto or state song or state flower. And we've gotten recommendations from the community too. Larry Pesci recommended looking at regional food or cuisine or agriculture. From the co-design perspective, it is modular. We like it to be even more so, just to have it open to extension. We think that this framework could be extended to not only include states, but also to include provinces or territories or even other countries. And we could even change the granularity of how we're looking for this. When Sanjeev and I were concepting Wordsmith, we were thinking about what scale do we want to start with? Do we go as macro as continent, or do we drill down to country, state, city, road, address, actual geo coordinates? So maybe a future version could, instead of a user inputting a state, they input an address or a pair of coordinates, say 50 miles, and say, give me all the words that Wordsmith can generate in a 50-mile radius. So Sanjeev and I are both believers in free and open source software. We believe that everyone should have access to all the source code at all time. We also believe that we're not the smartest people in this room. So if you guys have any ideas for data, for features, if you have experience with looking at querying APIs for geocentric type data, we would love to talk to you. Please send us a pull request, submit issues, hit us up on Twitter. The repo is listed there. We'd love to share this with you. So with that, this is contact information. Also, if you replied to Sanjeev's hash challenge earlier via Twitter, feel free to hook up with us. We'll either be at the back room or in the passwords, and just bring some verification that it's actually you on the other side of the tweet. But with that, we thank you for coming out and open the floor to questions.
Yeah, thanks, guys.
Well, I'm pretty sure there are questions for this, and I have questions myself, tons of them actually. But as an example, I just wanted to tell you that in the UK, there is one government organization that keeps on tweeting again and again and again that a safe and a good password that is also easy to remember is made up of 3 easy words. That's what they keep saying all the time, 3 easy words. Now on December 4, 2015, Hashcat put out a tweet saying, important announcement, and there was a hash value. And very shortly afterwards, Solar Designer replied to that tweet saying, the hash, if you can crack it, says Hashcat open source. So that's the way Hashcat announced that Hashcat was going open source. And Solar Designer cracked Hashcat open source. That's a 3-word passphrase with spaces in between words. So Jeremy Gosney, he responded by asking Solar, because Solar said that he cracked this by doing a 10-line focused word list. So 10 words he put into his word list, and then he cracked a 3-word passphrase. And the words that he put in was, Hashcat is open source, will be without a space in between, sourced GPL under license. And he cracked it. So that's pretty, that was like, dude, license.
Yes.
That's pretty good. Now, I'm going to kick off one of my first questions first for this. First of all, have you been looking into the simple fact that there can be, as an example, physical and geographical locations that consists of more than one name, like you have a space in there. So the sea of something, sea of oceans, or whatever you want to call it. Does Wordsmith today actually take that into account, or will you just say that anything with a space is 2 different words?
So no, we take that into account. So if it does have a space, we keep the original string, we split on that space, we concatenate that string as well, so we get the common permutations of that particular word, and it also has that word in the word list as well on its singular level. Okay. Now, we didn't want to do too many permutations because we thought that the Hashcat rules that people would use afterwards would do that for them. So we didn't want to make the word list too inflated or too big, because Hashcat rules would take care of that in the cracking process.
Okay.
And to keep the keys unique, so for instance, when you're inputting a state, like for instance, North Carolina, which has a space in it, or District of Columbia with 2 spaces. Our keys, we sub out spaces for just, we basically URL encoded, just to make sure we keep the keys unique.
Yeah. Okay, so in Europe, when doing Paswords16 there, I have had Sebastian Revaux do 2 talks at different times about generating word lists based on different wikis, including Wikipedia. And his talks are essentially about, you know, how he created the Wikipedia word list and the issues of identifying what's a password, what's a passphrase, what's just random garble in there. And I highly recommend his talk from Cambridge in last year, because he actually also could prove that Han Solo is mentioned in the Bible, which is kind of cool. It just depends on how you actually break up all those spaces and so on, but Han Solo is actually mentioned in the Bible. So, questions? Arnold first.
So, first, thanks for a really good talk.
Oh, thanks.
I just, as much a comment as a question, which is, I think you have really a very powerful tool in having these 3 sets, and I hope you can do some more studies on it. And in particular, there was a discussion earlier about the question of, in one of the earlier talks, about whether blacklist dictionaries in password generation are dangerous, because people, when you reject their password, they just add 1 or 1, 2, 3 to that. And you have a place to actually do an empirical test there with the New York database of saying, okay, go back to that top 10K word list and apply some software that does, you know, various munging to that, and see how many, in fact, users, having been rejected, just did a simple transformation. So I encourage you to do more with it.
Great. Sure. If you want to send us your organization's hashes, that would be great.
Well, you actually asked that question to the guy who invited Diceware, so he does have a word list at least to provide, so to speak.
So to ask kind of a different question, when evaluating an individual word within the context of a dictionary or a hash, is there any metric that can be generated for understanding how likely that is to appear in word lists globally? This is, for example, password, God, I love you, 1, 2, 3, etc. We commonly are told that yes, this appears in many dictionaries, but we don't have a metric or score to tell us how likely it is to appear and how dangerous it is within the context of a password. Is there any way we can generate that? Is there any Bayesian analysis, probabilistic analysis that has been done on corpuses of words that could tell us, given a word, how likely it is that it is going to be cracked by one of these tools?
I don't know.
To my knowledge, in terms of the community, there hasn't been any sort of collective analysis on every single breached word list that's out there, as well as a collection of words to identify, I guess, the singularity or the commonality of a single phrase across all these lists. However, that being said, in our penetration testing reports, we use a tool called PIPAL, P-I-P-A-L. And that shows in terms of percentile, how many users are using this word or this root word in context of all the user accounts or hashes that we have or have recovered. So the only thing I can think of is marrying PIPAL and all those common word lists out there, but that would take a lot of computing power to do that. And it's almost a project in its own, right? But that's a great idea.
Sounds like a great talk.
Yeah, you should do that. Yeah. Questions? Sorry.
Yeah, I was wondering on the hash set that you were working on, did you do any combination of the word lists? Did you combine the word lists that were generated from Wordsmith with the top 10,000 or with RockU?
Yes.
I know that there's like a function in Hashcat for doing that.
Yeah, it's a good
That's separate
question.
from the mangling rules, right?
Yeah, no, we didn't combine word lists. So we were kind of more interested in the chunking aspect. So this is what the top 10K recovered, this is what the RockU recovered, this is what we recovered after that entire pot had been populated. That's a great, yeah, so if we can combine password and White House together, that'd be great. So that's maybe something else that we could have done.
When you started out on doing this, I mean, obviously you do, there's data available, massive amounts of data available for doing the geolocation part of this. But when you started out doing this, was it, did you start making Wordsmith because the data was available and you saw you could easily use them? Or did you actually have a theory, or eventually did you prove that lots of people are actually using geolocations as part of the password? So we need this input. What was the reasoning behind starting it?
So part of it was, as we compromise Active Directory domains, we dump password hashes and we start cracking. One of the things we do after we were churning through the ROCUs and the top 10 Ks is we would kind of generate our own custom word list based off root words that are, for instance, like the company name. And we do some of the common translations for that, converting O's to zeros and A's to @ etc. And also just some of the names of local, like the street that the company is on, or the address where the building resides. And we noticed we started getting hits after hits after hits using that pattern. So then Wordsmith came about as a way to kind of automate and weaponize that process.
Okay.
And as a second part to that as well, we just thought it'd be kind of cool to do this because no one else has really done this before. And going back to like the inception of Wordsmith, the story of that, as I was scraping credentials out of memory, I would see that people have been using these phrases in their passwords. So that was kind of like another catalyst for this tool.
Question for you guys.
You couldn't have asked us in an email later on.
Yeah, I could have asked you in an email later on, yeah, but I'm more interested in getting your feedback for everybody. This will come up in your review. Don't worry about it.
Great. This is Joe. He's our boss.
Yeah.
He paid for us to be out here. Yeah.
During the course of your testing and analysis, other than the one hashcat rule set, did you find any others that were more efficient?
Yeah.
That extended what you were doing on top of the targeted list, and what would those rules be for the rest of us?
Sure. So we used 3 different rules, but we found that those 2 other rule sets existed in this Hobo64 rule set. So we used rule1.rule, which contains 5,000 rules, and we used Hobo64, which contains the top 64 in the dead Hobo rule set. So we do also have metrics on that, which I can post out to Twitter or out to the GitHub repo, but this Hobo rule set just was a collective 58,000 rules that just sort of encompassed all those.
I'd just like to say that it looks incredibly useful, and I'd like to encourage you to make it work in other countries, particularly the UK.
We would love for you to help us do that.
Yeah. So, well, what have you people got against the letter U?
Colonial.
Some advice on how to tweak it for the UK or for another country.
Yeah, that's a really good point. I was in the Netherlands and also in the UK recently doing a pen test, and I kind of showed this to some of the clients I was working with and just told them to check out the talk if they had time. They mentioned the same thing, and that kind of Tom and I were speaking about that, and that's why we kind of extrapolated and made it modular now. So we hope to build on that, and hopefully there could be a UK-based implementation in Wordsmith 2.
I didn't know if this was covered, but mass processing. So if you want to say like, show me all passwords to have capital, they're length 12 and all that stuff, was that covered in this version of the Wordsmith?
So there is a feature
Yeah.
You pull it up if you want.
Yeah.
There is a feature to specify minimum character lengths. There is a feature to convert to all lowercase. By default, it's going to usually come out as capital case. That's how we pull it out of the HTML sources. But you can massage the data to a degree.
So yeah, we set the state here for California. Z is or Z is for the zip codes, and K is for the character length. So going back to password policies, if your organization has a minimum of 7, we could specify 7 here. We all know that zip codes have 5 characters in their string. So if we specify a minimum length of 3, we're still going to get all the zip codes. 4, we're going to get all the zip codes. 5, we're going to get all the zip codes. But if we set it for 6, we're not going to get any. And we're just drilling down on zip codes here. If we went for all, which is every single option available in Wordsmith, and set it for 6, you'll see that we'll churn through everything. Every single road, every single city, landmark, zip code, area code, whatever, that is under that 6-character specification will be removed from the word list.
But if you, sorry. Next one.
Sorry. I was just curious, since you mentioned sports teams, and I've seen a lot of users definitely use sports teams. If you use curl to do like the FIFA website, would that be able to scrub those team names, or would we have to like manually enter them? Because soccer is huge, at least in the Bay Area. So
Absolutely.
Just curious.
Give me 10 minutes after the talk, and I'll answer that question for you, because we'll do it together. We'll type in FIFA.com, and we'll see if it gets some sport names.
Yeah.
Yeah.
One of the things I've been telling many times over and over again at Paswords16 as well is that if you are a student looking for an assignment, something to do, or if you are a security researcher and you, for some magical reason, actually have spare time, please feel free to contact me and I will make your life living hell for the next 10 years with work to do. You know, I have lots of things that I would like to see being researched, and one of the things I'm still looking for is, and that's also the reason for why I asked, you know, why did you initially start doing this? One of the things that I've been interested in doing, and I'm kind of asking around if this could actually be done at all, I would like to see somebody make a tool or some kind of, you know, thing to pretty much put words, the base word of passwords that we can find from leaks, into different categories. So, as an example, house or car is a physical object, while dream or anger is not something physical. So my question is, could we analyze password leaks or password from pen tests and categorize them? And because I'm interested in looking into, you know, what kind of categories of words are people actually using when they create passwords. One of the things I have done is I have analyzed passwords based on gender and facial hair and hair color. I have done that. I have statistics on that. Women with red hair have the best passwords, and guys that looks like Unix gurus have the absolute worst passwords. I have evidence of that. But I'm very curious about that. So if somebody's interested in work to do, you know, give me a call. And with that, I will say that we are going to do a 10-minute break before we'll move on to the next speaker. So again, Kanji and Tom, please.
Thank you. Thanks, guys.
Okay, it's time to get started again. For those that haven't been into the room or been looking at Shed for the last 5 minutes, we have replaced the original talk that we are going to have now with Adam Cordell, and we have replaced that with Michal Spacek from Czech Republic. I'm absolutely sure this is going to be just as good as a talk as the one Adam was planning. This is about disclosing password hashing policies. Michal had been with us before at PaswordsCon up to several times. Yeah, take it away.
Hi everyone, my name is Michael, or you can just call me Michal in Czech if anybody here speaks Czech. Anybody here speaks Czech? Oh yeah, my girlfriend, yeah, that's enough.
Oh, she's here.
Yeah. My talk is about disclosing password hashing policies, and by that I mean, companies who are storing user passwords, they probably should do something to them, something really nice, not something nasty, and they should tell us, or they should tell their users what they do to the password. So I'm going to talk about who has already done that, and how they do that, and stuff like this. So the duct tape here is just, if you don't want to disclose anything, just put it over your mouth. So that's why it's on the first slide. And yeah, let's go. So please raise your hands who have seen sometimes a message like this when you are trying to register. Your password must be 6 to 20 characters. Please raise your hand. Oh my God, it's everyone almost. Cool. Now, one more raising hands. Who has been already wondering why? Please raise your hands who was wondering why they do this. Okay, cool. Me as well, of course. So you're not alone. There are people also wondering why actually companies are, putting password policies like that the password must be maximum 20 characters. So sometimes they are just tweeting, asking the companies why they do that. Like this guy, who I know, he asked TripIt, like, why do they require him to have the password exactly 9 to 64 characters long? So he was wondering why do they do that, and he tweeted at them. So people sometimes do that. Most of the times they just don't get any answer. Companies just don't reply at all. Well, sometimes the reason is that just the companies don't know why they do that. Because what happened to me once when I asked, that the guy who actually set up the rules, he already left the company. So the company didn't know why do they limit the length of the password. And they tried to fetch the information for me, but they failed. So most of the times you just don't get any answer if you ask, which is kind of bad. Sometimes people are wondering, or actually they are afraid that when the company is limiting the length of the passwords, that they are storing it in a plain text in the database. Because if you limit the passwords to, say, 64 characters, they are afraid, the users are afraid, that the company is limiting the length of the password because they are storing the passwords in a database in a column which is 64 characters wide, and they just cannot fit anymore. So sometimes users are afraid that the company is storing passwords in plain text if they limit the length of the passwords. It might be true, and it might not. It actually doesn't reveal anything because sometimes the rules are there for just whatever reason, but it's not the password storage. So, but it might be true, it might not. So, yeah. This is especially true when there is a password breach or database leak. In that very moment, the people are more wondering actually, and they are asking how the company is storing their password. So if they store it in a really bad way or if they store it in a secure way. I have a story from Shotbow servers. Shotbow is a Minecraft servers, or yeah, is a company running Minecraft servers, and they got breached, I think, a few months ago. So they just announced it on their forum, and people started wondering. For example, like this guy, Frost J. he asked what hashing algorithm was used for storing the passwords, because the original announcement said only that the attackers got hold of one-way encrypted passwords, nothing else. So he was wondering what hashing algorithm was used for storing the passwords. He asked on a public forum, and yeah, so he got really interesting answers, like this one from another member of the forum. Yeah, and thanks, Bruce, from Paswordsresearch.com for sending me this, so I can use it in my talk. Yeah, if they told you that, there would be no point in the encryption. And there is a headbang emoji, so yeah. Let's just not go into details here because, hashing and encryption is something different, and Kerckhoffs's principle, and yeah, let's move on. Well, the official answer was this one. It wasn't much better. He said that, don't worry, the passwords were hashed and solid and managed professionally. No idea what does it mean. They didn't specify the algorithm, but they just say it was managed, salted, and hashed professionally. I'll publish my slides, then there is a link if you want to verify it and check that and comment on that maybe. I don't recommend that, but yeah. So luckily there are companies who are actually not afraid to completely disclose their password hashing policies. Yeah, I'll wait with the next slide for you, Per. Yeah, luckily there are companies who are really not afraid to disclose complete details what they are doing to user passwords. Like, for example, Facebook. This is a screen from Alec Muffet's talk from Paswords16 from Norway, which was, the talk was about Facebook password hashing policies and authentication and everything. So this is a slide from his talk, and this is what Facebook does to their passwords. They do a lot of things to the passwords, but they have the reason for that. Seriously, I recommend to watch the talk because he's talking about that like for, I don't know, 40 minutes or something. So yeah, they use several layers of that, but at the core of it, there's a script here and some HMACs here. They have reason for that. So I will not go into details. Seriously, just watch the talk. But this is completely what they do to the user passwords, and they are not afraid to disclose it, and they are not afraid to tell us. There are other companies who are not afraid to tell us what they do to their passwords. For example, like LastPass. They have it also. Yeah, Facebook did that in a talk, so it's not somewhere on their site. It's not on Facebook.com. It's just in a talk by a security guy from Facebook. LastPass, they publish it on their site, and they say that LastPass utilizes the PBKD something, which shows something else to turn your master password into the encryption key. They got more details there as well. This is just a short text copied from the site. So they are also not afraid to disclose how they store user passwords. The same thing goes for 1Password. They are also not afraid to tell us what they do to the user passwords. They have released 60 pages long PDF which completely describes the security design of their 1Password for teams and 1Password for families, which is really nice. And 1Password is also doing a really nice thing. They are sending Jeff to Las Vegas every single year. I don't know why, but thanks. Thanks. Yeah. Okay. So there are also some other nice companies and smaller services which are doing the same thing. They are disclosing how exactly do they store user passwords. And one nice example is Scott Helm's Report URI, report.uri.io, which is a service, which is a really nice service for aggregating content security policy reports and HTTP public key pinning reports. Really nice service for doing that. And he's got this information, this important information, which says, want to know our password hashing policies? Sure, check out our frequently asked questions. So he's got this on a login page and on a sign up page as well, right next to the field where you enter your password. Right there, it's just there, which is really nice. And these companies, Facebook's got a lot of private data. LastPass, well, probably as well. The same thing goes for the service. They got a lot of reports from content security policies. So they are not afraid to disclose how do they store user passwords. There is more companies like this, and I have actually started collecting them. You know, some people collect, you know, empty beer cans and stuff like this. So I collect sites. This is my site. I call it, you know, michalspacik.cz, and you can find there a link to subdomain called Pulse. I have several sites of there. I will just show the site in a few seconds. It's supposed to be a part of the bigger survey of the internet. That's why I call it Pulse, because I got heavily inspired by work from 18F, which is a US government something. And they scan US government websites and they just publish the score, how good the encryption is there and everything. So I want to do something similar, but I'm just a one-man show. This is a one-man show only, so it takes more time. But let's just move on. So this is why it's called Pulse, because they call it Pulse as well. So I got really, really heavily inspired by that. The site looks like this. I think right now I have only 20 companies, because it's not that easy to get official information how companies store passwords. But so if you look at the site, here I have the company which is called Datadog, and a site apedatadog.hq.com, and they have disclosed that they use bcrypt for storing the passwords. So there's more sites like this. Some of them are Czech, because I'm from Czech Republic, so I'm asking the companies directly, and they know that they should tell me, because otherwise I will just make a public PR for them really bad. So yeah, here are the companies and the sites and the algorithms they use. I also came up with the rating system of how good they are. So Datadog is rated B. This company is rated F. Well, we will learn why. So wherever I have more details about the company or about the password hashing policy they use, so I also try to put it on the site. So here I have a Czech company which I was working for in 2014. So we made a talk about what we do to our user passwords, and you can find it also on my site that we use, or the company uses bcrypt, and cost is 10, and they also do some encryption on the hashes, and they have disclosed it on a Twitter and in a talk. Every time I put something into this site, into my site, it must be already a public information. I don't put anything because sometimes you learn how the companies are storing passwords just by doing, let's say, penetration tests. So I don't put it there. It must already be a public information. Somebody already must have disclosed it somewhere, in a talk, on Twitter, on Facebook, or in a docs or somewhere. So every time I just put their disclosure and link to disclosures. I also make the snapshot of the disclosure, so that if they later think that it was not a good thing to disclose, it's still on the internet and it will stay on the internet. So a bit about the rating system I've come up with. The rating system works like this. If you want to score, or if the company wants to score a really nice grade in my rating system, it needs to use slow hashes. That means bcrypt, scrypt, pb key, that thing, or argon2. I call it slow hashes right now, just for the lack of better naming. And if you want to score really perfect grade like A, you also have to disclose that in your docs. Because if you disclose it somewhere in a talk or in a blog post or on a Facebook or on Twitter, it's hidden. Nobody will look for it there, because the blog posts, they just disappear in time. Also, that's true for Twitter and Facebook posts. So if you want to score, if the company wants to score a perfect grade, they just need to tell us, right in the docs, because that's probably where everyone. If you are looking for the information, that's probably where you want to look. At. You will probably not go through the blog or Facebook or Twitter. So that's why some of the companies, even if they use bcrypt, they have grade B, because they just tell us in a talk and not that officially. Then there are other hashes, like SHA-1 to SHA-3 and other hashes, MD5. And if the company uses something like that, MD5 or SHA-1, SHA-2, and they at least salt it and stretch it, and it means they do several iterations of that, they score C. Or if they just salt the hash, they score D. And if they just use plain MD5 or plain SHA-1 or something like that, they score E. Or if they encrypt the passwords, they just don't hash it. Or if they encrypt it, they just score E. It could be worse, and yeah, it could be worse. F is for fail, and that's plain text. There are some companies who are storing plain text as well, unfortunately. So A and B are somehow safe. C, D, E, C could be safe as well, but we are not sure, so these ones are not really nice, and this is not nice at all. So sharing is caring, but some don't care, so they don't share. So is it okay to share or disclose the password hashing policy for the company? Well, I think, yeah, I think it is okay, especially if the company uses bcrypt or scrypt or hashing functions designed to store user passwords. If they don't use functions designed to store user passwords like MD5 or I don't know, SHA-1 or something, it's better for them to fix that, to use something better, and then they can disclose it. Because, yeah, there's no point in not disclosing that. If it's Facebook and LastPass and 1Password disclosing what they do to the passwords, there's no point in hiding that. So some companies are afraid that if they disclose what they do to the user passwords, that they will get hacked, that they will become a target. Well, I have bad news for them. They already are a target. And I'm not talking about Target, the company. Well, so this is a Datadog. I have Datadog on my screenshot somewhere here. I think, yeah, they scored B because they use bcrypt, and they use bcrypt, and they have been using bcrypt even before the data breach they have suffered, like I think a month ago. So they were using bcrypt, and they got hacked as well. So it doesn't really matter how the company is storing the passwords, because companies get hacked, and they will get hacked even if they just use whatever they use. It's worse if they use plain text or MD5 or plain SHA-1 or something like that, but they will still get hacked. There is another company who got hacked even if they were using bcrypt, and that's called Ashley Madison. But I think that the motivation for hacking Ashley Madison was completely different than user passwords. But still, even if they disclose what they use, they get hacked. And even if they don't, I think that Datadog didn't disclose before they get hacked, and they still get hacked. So there are some tricks for the users, how they can actually investigate how the company is storing the user passwords. One of the tricks is here. It's exploiting the PHP's feature of comparing two strings. So it works like this. If you are able to sign up to a site with the passwords 2406 something like that, blah, 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 and then you are able to log into the site with this password, QN or something, then you can be pretty sure that the company is using plain MD5 to store the user passwords, even without the company telling us. Well, so this trick works like this. The hash of 240 something something starts with 0E, and then there are some more letters. The same thing goes for MD5 from QN blah blah blah. The hash is also 0E and something. For PHP, if you take two strings which start with 0E and then something, then PHP compares them as zeros, because it thinks that it's 0 exponent something like that. So they just PHP compares it as zeros. Yeah, exactly. So it's possible to detect the password hashing policy if you are able to sign up with this password and then log in with this one. There are more examples like this. It works also for SHA-1 and for plain text as well. I got them on my GitHub, and you can try that. If it doesn't work, it doesn't mean that the company is not using MD5. They can be doing something else, like, they can just, they can be comparing the strings with 3 equal signs, not just 2. But if it works, then it's MD5, definitely. And I have found one site storing passwords in plain text just using this or similar trick. So even users can do detection themselves. They just don't need the company to disclose that. Yeah. Yeah.
So does that mean that?
I'm afraid, yeah, it needs.
So does that mean that 1 in 256 passwords is subject? Because 1 in 256 hashes would begin with 0E if they're comparing this way. This is pretty bad.
But it depends on how they are comparing that. If they will be comparing that with the 3 equal signs, then this doesn't work. But I think that anyone who uses MD5 is already comparing just with 2 equal signs. Or they can be just, fetching the data from the database in a different way. But if they are using 2 equal signs here, then yeah, exactly.
It's less likely than that because all the other digits need to be, the other characters need to be.
Yeah, exactly. Yes, they need to be. Yeah, it needs to be hexadecimal string. Yeah. Thanks. So yeah, sometimes you can just use it.
The slides will be made available online.
Yeah. Anyone else? Can I go to the next slide right now? Just asking. So even if the people are able to tell what the hash is just by looking at the hash. So if the database leaks, then you just look at the hashes and you're pretty sure that this is not a bcrypt. Who thinks this is a bcrypt hash? Oh, great. So this is MD5. So just by looking at the hash, you will know that this is MD5 or SHA-1 or a bcrypt hash or something like that. So if the company gets hacked, there's no point in not telling us what exactly they were using for storing the user passwords. There is a nice example from Anthony Ferrara, who has done this. He wrote an application, hashguesser.appspot.com, and he tried to prove that security through obscurity doesn't work. He has done that. He gave the users 2 passwords. One is password, the other one is Apple. He gave them 2 salts per the password, and he gave them resulting hash. What the site was missing were the exact algorithms how the hash was calculated. So he just gave the users passwords and the salts and the resulting hash. And he gave the users, I think it was 15 different algorithms like this. And the goal was to come up with the hash of a password foo and salt bar without actually knowing the algorithm. So you had to reverse the algorithm, the hashing algorithm. You had to reverse that and calculate a new hash for a new password, just by looking at the hash and knowing passwords and salts. Well, that's quite interesting. Well, the results were really nice. So there were people, I think it was 15 algorithms in total, and there were 14 people, there were 3 people who have found 14 of the algorithms just by looking at the hashes. Just by looking at the hashes and trying to calculate the passwords and everything. There was one guy, Matthias Glaub, who has actually hacked the app and made the app and made the server leak the algorithms somehow. So he found a misconfiguration, but he was able to generate all the 15 algorithms. So just by looking at the hashes, people are able to reverse that, even if the algorithm is even if the algorithm is different than just plain MD5 or something. Anthony was doing some really weird things to the passwords, like making them reverse and stuff like this. I will just not disclose any details. If you want to try that, just go ahead. So just by looking at the hashes, even if they are not plain MD5 or plain SHA-1, just people are able to reverse that quite easily. If any site is using any open source software, they are actually disclosing by design. They don't need to even tell us because open source software is just open source, so people can look at that and just tell how exactly the site is storing user passwords. Also, open source software makes it quite easy to fix actually security bugs in password storage. I have one example here. This is PrestaShop. They were using plain MD5 to store user passwords. Actually, they were using salt as well, but it was a static salt. It was a salt in a configuration, so the salt was the same for all the user passwords. And somebody told them that, hey, you guys should switch to bcrypt from MD5, so they did that. They did it like this. They were calling password hash, which is a PHP function to calculate the bcrypt hash, and they prepended salt to the user password. The thing is that the salt was 56 characters long, and bcrypt is trimming the passwords at 72 characters. So 72 minus 56, I think it's something around 16 maybe. So they were actually truncating user passwords at 16 characters without even telling the users. This was a security issue. I was able to fix that just by looking at the code and making a pull request, just fixing it in a few minutes. So that's what I like on open source, that you can actually fix simple things, or not that simple, quite important things, like really, really easily. They got more issues here, like they call it bcrypt show 256 for whatever reason, and they just call it encrypt, not hash. But I have fixed that in next revisions, so that's fixed as well. So yeah. So I think that it's okay to disclose how the company is actually storing passwords, because the company doesn't need to be afraid. There are other companies disclosing passwords like Facebook and Twitter as well. And just look at my sites, there are some nice companies. And it's okay to disclose how the company is storing the user passwords, especially if the site uses so-called password hashes, bcrypt, scrypt, pbkey, something, and argon2. And if the site is not using any of these special password hashes, they should just fix that and then disclose. And they should definitely let me know so that I can put them on my site. Because I think that if they appear on my site with a nice grade, that the users will love it more, because they can feel more confident that the company knows what they are doing and stuff like this. Even if the company is using hashes like MD5 and they switch to bcrypt, the users will quite love it, because they were like, oh yeah, you were doing something wrong before, but right now you are doing something nice and you are not afraid to tell us that you screwed up before. So yeah, I've been there and done that as well. So I think it's okay to disclose, especially if the company is using slow password hashes. And yeah, that's it from me, I think. Yeah, there are some questions. Thank you. Oh. Thank you.
Questions, Arnold?
One quick question. In your A and B ratings,
Yeah.
it wasn't so clear from the slide.
Yes,
Are
sorry.
you requiring salt for the A and B ratings?
Sorry, are you requiring?
Are you requiring salt for the A and B ratings?
Yeah, because all the algorithms like bcrypt, scrypt, and the other ones, they already require the salt. So yeah, I am. Yeah. Oh, Jeff.
Okay. Just simple one. Are you familiar with plain text offenders?
Yeah, I am.
Okay,
Yeah, I
I'm
am.
just wondering whether you
Yeah,
kind of cross.
I want to take it to a slightly different direction, because plain text of offenders is more like just a shaming. But I also want to thank the companies for doing a great job. So yeah, I know them. Yeah.
You said it's possible to tell the difference between different hashes, but can you tell the difference between just looking at the hash of something without the password of what's an scrypt, what's a bcrypt, and what's using PBKDF2 or 3? Is it possible to tell those apart?
Most of the times, yeah, because bcrypt usually starts with $sign to something $sign, so that's a bcrypt. The scrypt is slightly longer, and yeah, sometimes it is possible.
Oh, it is?
I think it's most of the times, yeah.
Oh, okay.
probably if it would be encoded to base 64, it could take some more time, but I think that it's possible, yeah.
More questions?
Your Pulse project, is it possible to contribute or is it closed?
Yeah, definitely. It's required to contribute.
Okay, great.
It's mandatory to contribute.
And how do we do that?
Just tweet me or send me an email to a link to public disclosure, because I think
Bill's in his shorts.
Bruce from Password Research already done that. He sent me like 3 links to sites who are actually disclosing there is a password. So yeah, it's mandatory. I cannot do this alone.
Yeah.
Thanks.
You know, this has been an ongoing discussion for many years at PasswordsCon. We are still fighting to make companies to disclose how they are storing your passwords. And my own personal opinion on this is basically that, you know, if they don't want to disclose, you should just, you know, as
expect the worst.
Expect the worst.
Yeah.
It's like either you can be on the good list or I will put you on the shit list. It's that simple.
I will probably rename my project.
Yeah, but I mean, over and over again, for every new leak we see unsalted MD5 still going on. We still see unsalted SHA-1, and we see all kinds of bad implementations. It's like somebody, I'm not going to say who, if it is board of directors or if it is the developers, but somebody is just not watching the news for the past 10, 15 years about all the leaks. It's like, oh, there's a leak. Well, the obvious question anybody on the survey on the board of directors should be asking their own organization is, how do we store our customers' passwords? They don't. They don't ask those questions. They just assume, well, we're not stupid, so this is never going to happen to us. And we need to change that. So again, thank you.
Maybe one remark. I was talking about Ashley Madison, that they are storing passwords in bcrypt, but they have done something really bad to the passwords as well. They were storing them also in MD5, like besides the bcrypt passwords. So if the company scores A or B, because they tell us that they store passwords in bcrypt, they still have a lot of opportunities to screw up. But this is not possible to verify. We just need to trust them. If they tell us that they use bcrypt, we just need to trust them that they use the bcrypt. So it's not really possible to verify it without hacking the company, and I'm not going there. So.
Yeah. And if you're interested in the Ashley Madison case as well, Synosure Prime, which is one of the really good groups doing password cracking for Crack Me If You Can and other password hashing cracking competitions. They did a talk at PasswordsCon at the University of Cambridge in UK last year, where they talk about how Ashley Madison had done pretty much everything wrong in their password implementation. So initially, bcrypt, looks good, and then, you know, kaboom. Okay, so we're going to take a break until 12, and the next speaker up is Bruce Marshall, who will also do a really interesting talk about how you should be proactively handling password breaches from other sites to your benefit, pretty much. So back again at 12. Thank you.
Okay, thank you.
slides yet? Okay, so this upcoming talk now, Proactive Password Leak Processing with Bruce Marshall. I know the schedule says 25 minutes. It's going to be a bit more than that, up to maybe 50 minutes. I don't know, we'll see. And as I said before, you can very easily go without food for several days. So even though there's lunch afterwards, I will highly recommend you to stay here and listen to the entire talk. Because this is going to be a good one as well. Bruce is one of those that have been with us ever since we started doing Paswords16 in Las Vegas 4 years ago. So I will just leave the stage for him. Go ahead, Bruce.
All right, thanks, Per. So yeah, I run the passwordresearch.com website, which I started 10, 15 years ago, not quite 15 years ago, to try to gather some of the research, specifically starting with the academic community. But then I've since added more from events like this, which I would consider non-academic for the most part, and trying to share that information, make it more accessible, and essentially provide an index to people like us who work in the private, industrial, government type fields, so we can benefit from some of that knowledge. And my last couple of presentations, as Per has mentioned, I've presented several different times on security questions, on passphrases like DACE-aware XKCD, style passphrases, and password expiration. And some of those have been driven by data that I've found, like the security questions and password expiration was based on password data that I had and some internet dumps that had security questions and answers. And this is one that's been a little bit different because I started out just hearing about these companies looking at leaks, like Microsoft going out. They announced here a couple months ago they were going to start, and maybe they've already been doing it for a while, but they announced at least that they were going to be looking at password leaks and looking at things like that to try to protect their accounts of their users, their customers. And so as I was collecting this information, I started hearing more and more about it, and I decided that I wanted to kind of try to gather what we know right now that companies are doing and talk about the techniques that they're using and talk about the different alternatives you have if you're considering this or if you're debating whether it's even worth your time. And one of the reasons I wanted to do that now was because in some ways, in some things in the industry, we kind of get broadsided by stuff by either auditors or standards, OWASP or SANS, or somebody comes out with a new guideline on something and then we have to figure out how to do it. So this is kind of my way of helping start that conversation along before we're too far in where 99% of the industry isn't doing anything related to this. So let's get right into it. And like Per said, there was some confusion. I had thought that I had a 55-minute slot, so I have about that much material prepared, but I'm going to try to pare it down to probably closer to 30, 35 minutes, try to be respectful, but we'll see. I have no guarantees.
Have you had breakfast? No. So you can wait. Go on.
Yeah. You just raise your hand and Per will bring you a little cup of juice. And
I'll be looking up yours. There's no way of getting out that way.
Right. So password reuse, if you're not sure what that term means, basically is a person using a password on multiple sites or multiple applications. Typically, in this case, we're primarily interested in the internet, but you could say it in a corporate environment or something like that. And so to try to measure the extent of it, I'm going to give you some stats, and this is where I'll kind of not spend a lot of time. But there's several different ways we can kind of measure that, and there's additional stats that I don't have just because there's more than we really need. But just to give you a rough sense of it, when actually asked what they do, which can be somewhat problematic because people either idealize what they do or they underestimate what they do. Roughly, anywhere from 46 to 60% of people say that they at least use passwords on several sites, or they reuse passwords for different places they go on the internet. We can actually see that too in some research that's looked specifically at password leaks, which password leaks are essentially if a company gets hacked, like if you were in for Michael's last presentation talking about some of the data that gets dumped out. They can compare passwords between the different users that are in both of those dumps, both of those that were hacked from both of those organizations, and see if they matched and kind of get a better feel for that. And so one of the research papers, academic research papers, was looking at how many had exact matches versus slight modifications. Maybe the password policy is different on one site than the other, so they had to add a capital letter where normally they wouldn't have one, or add a number. Or maybe some people like to do little prefixes, like for Facebook, the first 3 letters are FAC, things like that, where they felt like they were reasonably predictive. And I guess I skipped it on the first slide, but these numbers and brackets here, I'm big on references, since that was the point of me starting my website, was to point people back to the original sources of data. And I'll have the references section at the end. So if you see something you want to dig in further, just write down the number, and you can see actually where it comes from and do some reading yourself. Troy Hunt also did some comparison between Yahoo Voices, Sony Pictures, and similar type of thing. He saw that around a little bit under 60% used the exact same password within that sample, and 2% had slight capitalization differences between those passwords. And finally, probably even the most accurate, or at least more insightful, is monitoring what people do within their web browsers. And one study and one kind of industry type study have looked at that. Trusteer, data is getting a little bit old now, but I don't imagine things have changed too terribly much. Had basically a browser extension that would monitor where people were using their passwords for those customers. And I want to say that they had like 4 million different people that had that extension installed. And they were able to see that just specifically focusing on financial sites, that 73% of the people used their bank password or their credit union, whatever, to log into at least one other site, which you would think that's very bad, and you would be right. And then also the fact that they may have a different ID, but they on other sites too, but they use the same password. And then in a smaller review of just more recent, but smaller review of university students, they did a similar thing, installed a browser extension, looked at how many different sites they had versus how many passwords, and there's a lot more details in the studies that I'd encourage you to dig into if you're really interested, but 85% had fewer passwords than websites that they went to. So why is this a problem? Because of the ATO, or account takeover threats, kind of what that type of attack has been labeled, where we as site owners start getting attacked because our users have made choices to reuse their passwords. Now, account takeover is not just a result of password reuse. It could be a result of poor password choice. It could be someone's computer having a Trojan installed in it. There's different reasons for it, but password reuse is one of the threats, is one of the causes of account takeover. And credential stuffing has kind of been the name that I think Shape Security kind of. Akamai monitors a lot of the sites out on the internet, and they're able to see some more insights on their customers beyond just a single customer type of a situation. And they released this year in one of their reports, like nearly a million IPs being used in one single attack against a financial customer. Throughout that period, 427 million accounts checked. And a different customer, which I think they said was in the entertainment industry, was the second one here, 817,000 different IPs. And looking at those IPs, of course, because they've got insight into both of those, they're able to see that there's about 70% overlap between them. So either they're using the same botnets, or it's the same gang of people running these different types of attacks, or there's definitely some correlation between those different attacks. So they're out there, they're trying, whether it's your site yet or not. I mean, only probably or hopefully your logs will tell you. One of the interesting things that also Akamai said in that same report was that when new password leaks come out, like LinkedIn and MySpace and some of the others we've seen this year, they see spikes in account takeover, credential reuse type activity. They're specifically monitoring that types of stuff. And one of the biggest examples of that happened last year was Taobao, the Chinese kind of like an eBay reseller type site. They were hit in the middle of October with what authorities later said was a collection of 99 million credentials that successfully got them into about 20 that matched at least 20.5 million active users on the Taobao site. Now, Taobao said that they didn't actually get in. They got blocked by maybe, some contextual authentication type stuff. They came from the wrong IPs or they had suspicious browser strings or something like that. But regardless of how many they actually blocked, the resulting crime resulting from getting into those accounts was around $1 million worth of fraud that they detected and then had to deal with on their site. In less widespread nature, there's been a lot. TechCrunch here just in the last couple weeks got hacked into due to a shared password in their content management system, and briefly someone posted a fake article. GitHub had problems, the same type of thing after LinkedIn came out. The most recent LinkedIn leak that their users were being attacked with reused credentials, and they had to respond to that. And Shatbao was another one that said that someone got in because of a third-party breach and the credentials being the same as on one of their administrators. So it's hard to quantify how many people have suffered account takeover due to password reuse because we often don't know why their account was taken over unless they say specifically, oh, I had the same password between eBay and my Facebook account. But we know as far as just account compromises in general, roughly 25% of the population has experienced that in the past year and had to deal with the outcomes of that based on this survey. So why does that happen? I don't really want to spend too much time on this. There's lots of different reasons for people to want to get into accounts. Often you think like, why does someone want to get into my Starbucks account? I can understand eBay or my bank, but why my Starbucks account? Typically there's some way they can either get money out of it, they can get social proofing, they can do different things that are going to add value to them, or that they can sell to someone else that is interested in doing those things. So I guess one of the questions that we kind of have to answer is it our responsibility to care? Someone's chosen to reuse a password, and there's been research that says that people reuse passwords in part to deal as a coping mechanism to deal with the overload of passwords that they have. They don't try to choose something super complex so they can remember it. They try to reuse it in certain situations because they want to relieve that memory burden that they have of having, if you had to memorize a password for every single service or account that you have, that could be overwhelming. So they made the decision to reuse that password. Maybe they weren't as informed as they could have been, but they did make a decision about that. So we do have the option, and most of us are in that default option right now, which is we're not doing anything. We wait until an account gets hacked and we respond to it, and we can continue to do that if we want to. So from a perspective of back to what do users know, there's an excellent paper. I don't think Dr. Craner is in here, but her team at Carnegie Mellon has done great research over the last few years, but one of the papers that I recommend pretty much anybody dealing with password policy or authentication decisions is this one called, I added a exclamation mark at the end to make it secure, which is where they sat down in a lab and they asked people to create passwords for like a newspaper site, a bank site, and an email account. And they looked at what they did and kind of had them talk through the process. Okay, this is my bank account, so I want a stronger password. Or this is my email, so I want it to be something I can type in quickly. They got that feedback from the people that they talked to. And then they also talked to them after the fact, why did you choose to make your bank password the same as your email password? And so they specifically got feedback on password reuse. And a lot of people say, kind of like, well, we know it's a bad thing to do, and I probably shouldn't be doing it. I'm not as concerned because it seems to not have any consequences for me. They're part of that, maybe 75% of the people that haven't had their account taken over that they can't trace back to password reuse being a problem, which, you can't argue with experience. In some cases, somebody can reuse a password and never have problems with it. It depends on some of the other factors of if that password is going to get disclosed through an attack or a breach somewhere. So, but part of the problem is that they don't have the same education that some of us have as to what constitutes good and bad password decisions, what constitutes risky situations that may expose their password to compromise. 3 of the different people that they talk to, say, hey, if I've got a good password, I reuse it. I don't see a problem with that. My reused password is not easily guessed. No one can guess my reused password. Well, so the researchers then took the passwords that were generated as part of this lab experiment, used Hashcat blindly without, with someone that didn't know what the values were, to crack those resulting passwords or attempt to crack the passwords. And 2 of these 3 people had their passwords cracked. So maybe not the best, judges of someone being able to guess their password. So that's my perspective. I guess one more here. This was a guy that recently just came out here. He was contacted by a news agency because his password had been breached as part of a O2 compromise over in I guess, England. He talked about, well, I reused that for O2 and eBay and Gumtree, and up to that point, he'd considered himself secure online and internet savvy. So, from his perspective, maybe he had thought his password was good enough. But the point being, sometimes we have to provide that guidance back to users. We establish minimums or we establish standards, and users say, well, if you're saying I only have to, do 6-character passwords, then that must be sufficient. So, the office space flare scene here came to mind as far as that argument of, why did you set the standard to this if this wasn't sufficient? And password reuse, it's a little bit harder for us to set standards, but our actions do kind of speak to that same question of, is this acceptable behavior or is it not acceptable behavior? Users do also kind of have mixed feelings about who's responsible for that. In one survey, 56% said the sites that they visit had ultimate responsibility for their account protection. And another 39% said that websites are to blame if they have account compromises because they didn't offer the right security features. Whether that's multi-factor or stronger passwords or whatever it may be, they're placing some of that blame on it. So I would say, given this, we kind of have a shared responsibility. Alex Stamos, who's now the Facebook CSO, spoke at an AppSec conference here last year where he said, he was asked in the Q&A session, what's the biggest challenge for Yahoo? And he said user security, and then broke further down in talking about how they deal with password leaks and password compromises, and saying, in theory, there's nothing we can do about that, right? The user's choosing to share their password. They're making a choice. We don't really have any role in that choice. But he said in practice, it means they need to kind of readdress how they're dealing with passwords, how they're dealing with their users, and how to limit the risk of those compromises because the user's not capable or not willing to do that for themselves. So I thought that was a very pertinent quote related to this discussion. So there are different things you can do. We're going to focus on password leak processing, but I did want to kind of talk through these, and I'm not going to spend as much time. I was going to go into blacklisting a little bit more and contextual risk-based authentication a little bit more. But one of the bad things you can do is to enforce regular password expiration. And that's been talked to a couple other sessions in this conference where if people are changing their passwords every 60 to 90 days, they at least can't have they probably won't have an exact match to their other accounts because they'll be incrementing the number on the password that they've been forced to change. Maybe a slight difference, and as we talked about earlier, in some of the leak processing, people are able to guess those transformations fairly easy. So not a great way. Incident-driven would be like Citrix Go to My PC and Pandora. Was it Pandora? Let's see if I had one. Oh, Carbonite. Carbonite was the other one. Whoops, there we go. So Pandora and Carbonite, or Go to My PC and Carbonite detected password guessing attacks on their sites and just reset everybody's password, forced everybody to change their passwords. That's a fairly, scorched earth type of policy. It can work, but how often are you going to be able to carry that out and not upset your users? There was a lot of people that said, I had good passwords on your site, especially with Carbonite where you're doing backups with it, and now you got to change service passwords and stuff to make sure that it actually continues to back up. That can cause a lot of disruption that your users may not want to deal with. You can design unusual password policy requirements. If you start making sure that people have to start it with no space, no symbols in their password, or they have to have 2 symbols in the middle of their password, or Mark Burnett has a great site, Twitter feed of PW2Strong, which he retweets all the different terrible policies and different sites have. There's ton, and I don't think that typically they're designed to do that, but that is one way that someone could approach this problem, saying, well, come up with some crazy requirement. That way they won't possibly have the same password on our site as others. You can assign random passwords to users, or they don't have to be random. I mean, they could be semi-random or whatever, but you could assign passwords to users. Linux Mint was hacked earlier this year. Their forums and their partner sites or community sites were, their database for those were hacked. And as a result of that, one of the choices they made was to just randomly assign all their users passwords for the new passwords. That lasted about a week. After that, they realized that people weren't really happy with that choice. They wanted to be able to choose their own passwords. For some of us, it's not as big of a deal. We just plug it into our password manager and go on our way. But for others, either they're trying to have to memorize that or writing it down, or they're just not pleased with having to deal with that possibility. Very high secure sites, you might get away with that. Maybe there's, you can justify that and your users aren't going to react too strongly. Eliminate passwords altogether. And this is what kind of Yahoo, with their Yahoo account key and some other sites like Medium have adopted, where they just basically say, if you want to log into the site, plug in your username, we'll send you an email. You click the link in the email that has basically a session key that logs you into the site. You don't need a password anymore. Everything will be done through your email you need a password for, but that's not our responsibility, their responsibility anymore. That's, for some sites, I think, again, lower security, that may be an option you're willing to go with, just because the passwords then aren't, you have to worry, they have to worry about their email password, but from your perspective, there's nothing else you really have to worry too much about. Two-factor, multi-factor authentication, two-step verification. I mean, we've been encouraging that for years, so regardless of password use, because of all the other password and account takeover threats, it's a good idea. Probably goes without saying. But it is nice if your password isn't the only line of defense. So if someone guesses your password, they still can't get into your account. That's ideal. Blacklist from leaked passwords, and this is, I'll talk briefly about this, but and Jim mentioned yesterday in his talk about the new NIST standard that there's some pushes towards, instead of just reacting to people's bad choices after the fact, when you see it in a leak, you tell them, yes, that was a bad password. I mean, not all leaked passwords are bad, but presumably some of the passwords are, and then you would be telling them not to use them. You could just create that list from scratch or create it from leaked passwords. There's services out there. Password RBL is one I talked to. He's got millions of passwords essentially that he's compiled from leaks, from attack tools that have password username combo lists, from different places like that you can subscribe to. You can generate your own blacklist, but you can essentially try to prevent those from the start for all users rather than just saying this one user can't use this one leaked password that we found that they were using somewhere else. Contextual risk-based authentication, there's lots of different names for it, but it's essentially looking at other factors that you're monitoring more passively that are associated with the user's login experience. So you're looking at IP and geolocating that IP to their normal location. So if I log in from the United States and suddenly I'm coming from Europe, they may flag that for they can essentially flag that as a higher risk type of authentication transaction. LinkedIn is doing this and did a great talk at Enigma conference this year. David Freeman there, I think it was called Server-Side Second Factors. And he talked about essentially the formula that they use to determine risk, browser agent, time of day, all the different IP factors. And he also talked about their success at combating things like account takeover fraud, the fact that just by looking at country, they could eliminate 90-some% of automated those like the Akamai data, the automated large-scale attacks because they were coming from other countries, and some of the other things like that. So that's certainly something that I think, regardless of whether you're doing this just to combat password reuse, this is a good thing that you should be looking at if you're not already having it implemented. All right. So finally, the approach we're going to talk in more detail about is looking for password leaks on the internet from other sites. Possibly from people claiming it to be your site, and then compare that to your own users. So here's my obligatory kitten picture. So your goals are doing this is to reduce account takeover. You probably want to eliminate, but to reduce account takeover based on risks that you know to be there. If this password leak is out there and other people have access to it, those accounts by logic, have a higher chance of being attacked. So you're trying to get ahead of those attacks for presumably the riskier accounts, at least from this perspective. I haven't seen or heard feedback from the companies that are doing this. I would assume that there's some money savings from having to, for dealing more proactively with eliminating account takeover threats before the account takeover has happened, when you're not engaging customer service and admins or whoever else has to deal with compromised accounts and possibly the loss of business that goes along with customers being frustrated that you didn't protect them, even though maybe it was their bad choice that led to the account takeover. And it also, as we talked about, demonstrates some security commitment to your users, to your investors, your auditors, your management team, whatever, whoever's kind of in that field of needing some reassurance. So if you've never seen leaks before, if you're not quite sure, I'll give it a brief explanation. Typically, it's going to be just data that's posted on the internet. My experience, and I'll talk a little bit about this, the data that I collected a couple years ago was most of at least the small time compromises come from things like SQL injection, where sites predominantly running PHP would either not program properly to resist SQL injection, so the attacker can then dump their entire user database, get the passwords, usernames and things like that. Sometimes in bigger cases, it comes from just outright server compromises where they compromise an application server and then have connections back into the database server that they can pull the data out of. But there's also cases where Trojans and malware are collecting it. I think TrustWave did an analysis about the Pony botnet, and they had several 100,000 passwords that had been collected by the Pony botnet over, I think, a 6-month period or something like that. Phishing, of course, tends to be somewhat lower scale, man-in-the-middle attacks. And then there's compilations where people may just collect data over time and then will it down and say, okay, I've grabbed Gmail addresses from 7 different sources, and now I'm going to put them all in one file and call it a Gmail dump, password dump, even though it didn't technically come from a hack of Gmail. Some will be duplicates. People kind of use this as a bragging right in some cases. They put their name on the top and say, hey, we hacked the FBI or we hacked Gmail. And some leaks, of course, as you probably have heard, don't just contain password data. The Ashley Madison compromise contained all sorts of personal data. The healthcare breach that happened that was, or I guess, was leaked that was kind of given publicity this week has all sorts of healthcare information. So they're not just limited to username, password, email. There may be lots of other data within them. So you kind of, if you're deciding to do this, you kind of have to make some decisions, and you can be somewhat flexible on this. It's not a binary, yes, we're doing everything, or no, we're not doing anything type decision. Probably the most important one is for you to decide if you're going to be looking for data that comes from your own site, looking for signs of compromise, or looking for signs that someone is sharing data that supposedly comes from your users or your employees. After that, probably you're going to be looking at easy leaks to process. So the larger leaks that have plain text passwords that you don't have to worry about cracking anything, you don't have to worry about going through much effort to parse the data or try to go out there and find the data is another, I guess, easy hurdle to overcome. Like I said, the larger leaks. And all the leaks you can find. And this is kind of, in talking with Michael Coates, who's the Twitter privacy and security officer, he talked about that's kind of their approach, is they're trying to find everything that's out there that they can deal with and try to process to protect their users. But, as you might guess, that also requires greater commitment to time and resources to try to address that. So if you haven't seen password leaks before, they come in all sorts of shapes and sizes. These are some from like pastebin type sites where they're just text file type formats, usernames, passwords, emails. Some are going to have them in different order. Some will be tab delimited. Some will be space delimited. Some will be comma delimited. Some will have hash passwords. Some will have plain text passwords. Some will have passwords in a different table than they had usernames. So you'll have to try to correlate them. And just my point being that there's not a one-size-fits-all type approach to sucking in that data and having to process it. And in this case also, you can see these are passwords over here in parentheses that they've already cracked before they publish the dump out there. This one's more like a SQL type statement with all the different fields within there. So I looked at this back, it's been 3-4 years now, to try to get an idea of the scope of password leaks And I wrote a blog post about it, which you can see here in the reference. But essentially over a 2-month period, I looked at how many dumps I could find that were specifically had, I think my criteria was more than 10 usernames and passwords in them, because some might just have like 2 or 3, and some might be like one single person had a Trojan on the system and they dumped all his information, kind of like a doxing type of attack. But these were the different results. So December, 154 different password dumps, 125 that had specifically organizations or a site specifically named as the source of that dump. Whether that was accurate or not, I didn't verify it. Plain text passwords, there were 66 dumps and 40 dumps, resulting in 221,000 and 61,000 respectively passwords, and then similar with hash passwords. So you can kind of see there's some variation. There's also variation in size. The dumps with less than 1,000 passwords, there was a pretty good number of those. And a lot of these are just smaller, less secure sites where they throw up a university in India throws up a CMS for their students to log in and get courseware, or a small retailer or something like that throws up a site. And I didn't count up the emails. There were emails included in the December dumps, but the January dumps I actually did say which percent of the dumps had emails in them to give you an idea. The rest either had just usernames, or some of them may have just been passwords by themselves. To give you an idea of, are you going to be able to have access to those emails to know if they're your users or not. So roughly, that's this was a decent amount of work for me to parse through this, because there was dozens and dozens more dumps that I saw that didn't have password information in them. They were just config files or other data that was not passwords that I didn't want to have to deal with. And this was even, like I said, automating just I had to manually review them, but I could at least automate the scanning for them.
When you were looking for emails in there, I mean, emails are being used as usernames. Did you at any point see any leaks, or did you ever think about also looking for usernames that are something else than just an email address? Like, Twitter as an example, you can log in using your phone number. If you have given them that, you can log in on Twitter using your handle, or you can log in using your email address.
No, I didn't do any counting of usernames specifically. You can see like in some of these dumps, like this first one here on the left side, it's got a screen, I guess a screen name maybe. That's their username, and it also has their email. I couldn't tell you what that site allowed or used as a login. We know that a lot of sites on the internet, of course, use emails, but yeah, there may be cases where they could do either or. And we'll talk more about whether you want to parse usernames yourselves or against your own users or not, but that can be problematic. So that's kind of like the kitchen sink. You're looking for as much as you can. You're sucking that in, and I'll talk about some tools here in a minute that may make that easier for you. But you could also just look at the larger scale, and this is kind of a sampling of what's come out and what I would say has been generally available in the last few months of this year. Some of these didn't come from this year, like LinkedIn we know came from, I think, 2013, 2012, okay. And then MySpace is around that same time, and the Twitter one wasn't really Twitter, it was some other site, and they had 400 million entries, but only 32 million of them were unique entries. And so there's, but you may still find that data is still pertinent, and we'll talk about LinkedIn here in a little bit, but that data may still be relevant even if it's older. But as far as general availability, these are kind of what you're looking at as far as large numbers, clearly much larger than the, a few 10,000 password dumps that we see with just crawling Pastebin. And most of these you can't find on sites like Pastebin. You have to look for either people tweeting about them, or there's torrents, or maybe some other file sharing sources in the underground. The nice thing is, I guess, once more people get them, they tend to share them more. Like LinkedIn at first was kind of more harder to get a copy of, and now it's fairly easy if you know where to look for it. Let's see. All right. So some tools. Netflix is one of the organizations that does process for password leaks. And they came up with a tool, a Ruby on Rails application a few years ago, which they open sourced, called Scumbler. And that's not really a password leak processing tool so much as an intelligence gathering tool that looks for password leaks. So it's a tool that they have for data sources like the Pastebins, but also Facebook, Twitter. They can scan for Twitter. I'm trying to think, probably Google searches and some other stuff like that. But they essentially make it so if they want to put in Netflix password as a term in there, it gives them a workflow and kind of a checklist for them to go through of all the different sources that tool's found since the last time it's been run. You could schedule it to run daily or whatever, and retrieve that information, decide whether it's a threat you need to deal with, whether it's actual leaked passwords or not, and then and process it. Yes?
You'll also be really careful with Stumbler. By default, it will attempt to use email, and its original email source was actually, or its destination was not registered, so it was actually sending some of the reports to an unregistered email address.
Okay.
That was patched.
So he mentioned Scumbler's output as far as alerting you that you need to process data from it was originally email, and there were some quirks if you're using an older version of it, so make sure you're using a current version. But that's kind of their solution, and it works in with some other their tools as far as, like I said, the workflow behind how they process those leaks and decide, because they're looking for other stuff too. If someone says, hey, I hacked Netflix, but they're not dumping passwords, they're also interested in that type of data. So it's more of a general intelligence gathering, but it can be used specifically for password leaks. DumpMon is a Twitter account, but it's also an open source project where they are crawling pastebin for you. And I believe that was one of the primary sources I used when I was doing my research back in 2012 and 13. But you could customize that since you've got the source code to, instead of posting on Twitter, do the same type of thing. Write it into one of your ticketing systems or send yourself alerts when you find specific strings that seem to match password dumps that you want to deal with. There are some sites that there's not really. Hashes.org is pretty much the best site that I'm aware of as far as current hash dumps. They seem to have a good, and they kind of disguise the name like LinkedIn has a 1 instead of an I, because I guess they're trying to make it harder to search for. But they not only have the raw hashes, but they also have cracked hashes, so that can save you a lot of time if you want to just take advantage of their work that they've already done. Inside Pro is like I think a Russian password cracking site that they have forums where people share hashes and stuff like that. There's all sorts of other occasional sources that may have either older data or they may leak something every once in a while, but it's kind of hard to find one good source on the internet that has everything you need in one place. Yeah?
Inside Pro is a little bit more nefarious than that. It's basically frequented by a large number of people with excess GPU capacity. You can basically post large dumps of uncracked hashes
yeah.
And get them cracked. I've been watching specific actors responsible for some of the large cloud service provider breaches. And when they pick a new target, they'll pick like the hashes from maybe 50 or 60 employees at a particular cloud provider and pump them into Inside Pro with like anywhere from a $5 to $100 bounty per hash.
Mm-hmm.
And they'll usually get around 20 to 25% of the accounts reversed within about 3 to 4 hours.
Yeah.
So that's how
yep.
effective it can be.
Yep. So he mentioned basically that Inside Pro does kind of like a crack for pay in their forums where you can say, hey, I want these cracked, and you can offer a bounty for it. And so it's not always just like good-natured password sharing. Sometimes it's more of the criminal element involved in that too. Of course, a lot of the dumps we've seen this year have been offered for sale initially, like the LinkedIn and MySpace data on, underground sites where they sell everything from drugs to, whatever else that you wouldn't be able to sell on a normal site. Those can be a little bit harder to track down just because you need to get access to them. Sometimes they're a little bit more careful about that. Sometimes they're not. Depends on which sites you're talking about. I'm not aware of any just like a underground, like a Carding Pro type site that's specifically focused on credentials. Their only interest is credentials, so it tends to be mixed in with the other, either data sales or things like that people may have, credit card sales, other types of data dumps that are out there. Law enforcement may also, I've heard cases I think with Time Warner Cable where the FBI said, hey, we found this data we think may be associated with you and you might want to take a look at it. I wouldn't count on them doing that for you. If they do, great, but it's probably more of a, try to know who your local cybersecurity person is in the Secret Service and FBI or your national law enforcement agency of choice. But that's it's nice if you get it, but I wouldn't count on it. There are a couple companies that are specifically focused on providing you with either password leaks or allowing you to check your users against the password leak data that they have collected. Hold Security is run by Alex Holden, which you've probably heard him in the news in the last few years, but they've got several, they have a pretty, I guess, mature program for going out there, getting large data leaks from their underground connections. They do crack some of the passwords themselves. They put in, it said like about a week's worth of effort. They do find a lot of plain text passwords. And their idea is that they sell you essentially an API service to query users and find out if your users, whether they're employees or customers, have passwords in their database. And if you need to crack them, you can crack them, do further cracking on your own. Leak source is a little bit newer. They've also kind of focused more on the end user as far as you can go out there, plug in your email, and they'll show you which sites you've been, your credentials have been leaked through. But they are also offering a business option. Again, they do some password cracking themselves. They've got the API, and you would have to subscribe to that. Threat intelligence service providers I'm not as familiar with, and I would imagine that if they found a leak that had your name on it, they'd probably tell you about, but they may not be willing to share like a Netflix dump with you if they found something like that. I don't have any, like I said, if you've got feedback on that, certainly feel free to pitch in, but I know that they'll at least alert of, hey, LinkedIn had this big credential dump and it may be something you're going to be aware of, but they may not provide you with that data directly.
Leak source, though, doesn't just allow you to look at your end user's data. It allows you to search anybody's data.
Right. And he mentioned that leak source doesn't restrict you to just searching for your own user's data. You could essentially search for any matching emails within the dump. And I would imagine hold security is probably the same way, but I don't know that for sure. So you've got these leaks, whether you're pulling them from large sources or single sources, you've got to decide, make some choices on how to process that. The first one, like I mentioned, there's duplicates. So you probably would be good to have like an indexing type of a history where you're saying, okay, we've already done LinkedIn from 2012. We've already done blah, blah, blah. So you don't waste time going back over the same data, especially if you've got, you're parsing a lot of the small dumps where you're probably getting duplicates every month if you're doing that. The cleanup and conversion of data, some of this can be automated. Just things like I said, I showed you kind of the different formats. There's headers and footers and different columns, and you can sometimes use regular expressions to pull out hashes and email addresses, but getting the other data may be problematic. And then of course, if you're presumably going to filter that and focus on your users, you just care about the email addresses that match your user accounts. There's another decision about which users you're worried about. Pandora was the one that got the leaked in data, and any user with an email in that dump had their password reset or got flagged for password reset. They didn't try to crack the passwords. They didn't try to make sure that they were the same. That, as you might guess, angered some people that didn't use the same passwords, probably frustrated some others that weren't sure why that was going on. And again, it's kind of like that nuclear option of, we're not really willing to put in much effort into this, but we want you to be secure. So they're kind of pushing that back in the user's responsibility realm. Any user with a username appearing in the list, and kind of back to your question about if you should look at usernames, that can be problematic just because usernames aren't necessarily unique, globally unique. Email addresses are a little bit better about that, although they can be reassigned over time. But J Smith is a username. There's probably a lot of sites out there with a J Smith that isn't your J Smith. Alex Stamos also mentioned in that same presentation from the AppSec California that they do strip off the recipient of email addresses and check that against matching usernames within Yahoo. At least they did at the time for matches. So for them, but they were specifically also looking for password matches. So if the coincidence that J Smith 1 and J Smith 2 had the same password, J Smith was still getting a password reset even if he wasn't necessarily the same guy. And of course, the more precise option is to say if the username and email specifically match, that's who we're going to worry about putting through the reset process. So depending on what type of data you're dealing with, like I mentioned, sometimes you're getting hashes, sometimes you're getting plain text. Plain text, you're normally going to take that, put it through your normal hashing process. You may have to pull down the user's salt if you're hopefully, salting your password, so you would have to retrieve some of that data. If you have an existing API that this works well with, it may be fine. Otherwise, you may have to decide to design something specifically for password leak processing, either because you're dealing with different performance issues, or you do things in your normal login process that don't make that the right approach to take for this. If they are hashed, you're going to identify the hash, whether it's MD5 or SHA-1 or something else, and then have to decide how much effort you're going to put into cracking that. My recommendation would be to say we want to prevent people from getting their passwords cracked if they are having, similar to what an attack, the amount of effort an average attacker is going to be. So maybe that's a week, maybe that's 2-3 days. You're going to have to try to make that decision yourself. As far as the different approaches, I mean, we don't really need to get too much into that. You're going to try different approaches to crack the passwords. You can certainly customize that. Your policy is 8 characters and higher. You don't have to try to crack passwords lower than 7 characters. That can be problematic as far as the different hashes. This is data from a presentation that Rick Redmond did from CoreLogic a few years ago, where over a 6-month period, they gathered data on what types of hashes they saw on the dumps that they were capturing. MD5 was like 46% of all the dumps they saw. SHA-1 was, 4%, or it was much lower. But you can kind of see you're dealing with a lot of different options. And this is just the top ones. They had, a list of 30 or something that they gathered. And you can look at that source for more data. But the idea just being it's not going to be an easy, everything's MD5 or SHA-1. You may have to deal with more options than that. One alternative to hashing, or to going through the cracking process, is something that we learned about with the Facebook presentation that Alec Muffet did a couple years ago in PasswordsCon Oslo, or I'm not. Trondheim. Okay. He talked about how Facebook deals with passwords, and one of the things he mentioned was that before they use, I think, Scrypt, HMAC, and some others, so they're doing better security. But he mentioned that they do have an option for feeding passwords through MD5, the normal user passwords through the login process through MD5 first, and then into the more complicated, more secure systems. So if you find an MD5 dump and your user's passwords ahead of time have already been hashed with MD5 initially, and then your more secure alternatives, you can just skip that MD5 hashing process and put them through your more secure process. Again, maybe having to pull down salt values. But you could make that comparison even without having to crack the original password. Just, like I said, assuming MD5 to MD5, SHA-1 to SHA-1, you've got comparable types of approaches. If you're going to do that for more than one, like if you're going to do MD5 and SHA-1 and who knows what else, you may have to have additional records stored within your account database. You may not want to go through that much trouble. It kind of depends on how serious you want to take it and save yourself some trouble. One approach I thought of, which I'm not sure if it's good or bad because it's got some drawbacks, is instead of trying to crack those passwords, you decide to just compare users when they log in, take their plain text password they provide to you, hash it if you've already determined how those passwords have hashed, if they have a matching record in different dumps, make the comparison then without having to do any cracking on your own. So that's going to compare both the secure and less secure passwords. The problem is you kind of have to keep that database around for an indefinite amount of period of time. Maybe users don't log in except for every couple months. It's definitely more overhead. You may not want to have to deal with that, but it would get you out of some cracking work. So what to do and tell your users? You could just notify users. You don't have to necessarily force them to reset their password. That's kind of what LinkedIn did. LinkedIn, the initial dump had like some 6 million passwords in it. So I understand that they made those users reset passwords if they had a matching password. But the most recent dump that had all 117 million accounts in them had not been reset for the most part. In fact, LinkedIn reported of those like 117 million users, more than 100 million had not reset their password at all. And that was after all the media attention. LinkedIn was in the news a lot about being breached and passwords being compromised, but they didn't tell users to change it. And some users probably said, if I don't, if LinkedIn's not telling me to do it, I don't need to worry about it. So that's kind of the give it back in the user's hands, but they may not make the decision you want them to make. So if that's concerning to you, don't let them make the decision. You can lock the account. You can either do a custom unlock workflow where you say you have to go to this page to reset, recover from this, which some sites have done. Most of the larger ones seem to try to push people through the normal forgotten password workflow, because you've already got that in place. It's better to reuse that same code and functionality. The problem can be like in the Tumblr case where they had to reset some user passwords, is that this is literally the only message they gave their users. It's time to reset your password once they tried to log in. They didn't know why. They didn't have any context of why this was happening for them. So if you're going to put them in through your normal password workflow, you may want to have some sort of a flag you can set where it says, click here for more information, and it points them to a URL where you can explain why that's happening. You can do what Microsoft and Facebook and some others do, which is to not lock the account necessarily. They can still log into the account, but once they log in, they're required to go through a password reset workflow. But they're also subjected to that secondary authentication during that process. So they're looking at, are you coming from a country I know, are you coming from a browser I know, and things like that. And of course, invalidate session tokens is also important if you've got mobile apps or persistent cookies or something like that, where even if they may not be logging in, so you can't necessarily force them through your login workflow. I've got to kind of rush through this, but there's some important things to tell your users why it's happening. There's going to be confusion on their part. I don't recommend there's a question about the name of the third party. I would say typically you don't want to tell them where the leak came from, and that may cause some confusion, but as we'll talk about from a privacy standpoint, that could be problematic as well. Make sure you emphasize your site wasn't compromised. This is from a third party. Whether or not unauthorized access was detected on their specific account, that's also helpful for them to understand that you're protecting them. Education, media, some stuff like that. Nuisance leaks, I'm going to skip through this. Basically, just you may have to process stuff that didn't come from you. Like there was a release a few months ago where large email providers, and here's the actual headline that came with it, breach these big major email providers. Well, it wasn't a breach. That's just the way that routers decided to spin it. But they had to process this data, and they found that as far as a percent of the accounts that were in there, a very minimal amount were actually valid data. The vast majority was either old data, fake data. Regardless, they had to go through and process it.
So you're calling 2% a minimal?
Well, 2% of what was in there, what they were claiming, clearly 2% of meaning 476,000 accounts, that's pretty significant. But as far as the percent of...
1% would be incredibly significant at any normal breach scale.
Yeah. My point is, like I said, not that you wouldn't care to reset this data, just that the data itself was, for the most part, bad data. It wasn't something that you would normally have to worry about, except for those small percents that you do.
Was it really bad data, or was it just mischaracterized data, like you were saying before, where somebody accumulates all these breaches and then sucks out just the Gmail addresses and says, hey, Gmail's been breached?
Yeah, and a lot of times we don't know. Like I'll mention, and this is some headlines from it, but some Pandora confusion. Well, I guess I don't have it in here. Someone basically said that Amazon Kindle was hacked. They had a record, 80,000 records, and that turned out to be entirely fake data. So sometimes it's completely made up. Sometimes it is just old data from collections that are years old that's no longer valid. But regardless. So quickly going over this, there is some risks involved with processing this. Like I said, users confused about how'd you know my password was in this leak? Are you keeping my password in plain text? Are you encrypting it? When Facebook announced their policy, there was a lot of comments on there, and as well as other news articles about it from users who were confused about that. Some people, if you lock the accounts, they're not going to be able to get back into their accounts. They've changed email addresses. They don't have access to their email. Their phone number's changed. Whatever recovery options you have for them aren't going to work. So just be aware you're going to have to deal with that in some cases. Privacy concerns. If you tell me, we found your password in Ashley Madison, or we found your password in Fur Affinity, I'm going to say, I'm not sure I want you to know that I was using that site. I haven't heard of people specifically being concerned about this, but I would not be surprised if I heard concerns from users being voiced. And notification fatigue, if this is happening every month, I could certainly see that being a problem. Legal risks, the short answer is talk to your legal team, because you're dealing with stolen data. From a US law perspective, federal law perspective, if you're not actively using that to compromise sites, you might be okay. From a trade secret intellectual property standpoint, it kind of depends on what data you have. And of course, avoid actually testing those credentials. So successes, WordPress went out there, looked at Gmail data that was compromised, found 100,000 users that used the same credentials, and they were able to reset those people's passwords before they got compromised. Yahoo, Alex Stamos again mentioned that they, in some of the bigger password dumps they deal with, 10 to 20% of the entries match their users, and they're able to get those passwords reset before it causes much trouble. And Twitter also felt like it was successful. So I like to feature my niece in every year's slides, and she's plugging the password leak, of course. This isn't going to solve all your problems when it comes to account takeover, but it may help you and demonstrate your commitment. So I'll open up for question and answer. I'll just kind of slowly tab through the references so we can get it recorded in the video, but I also have a link to my slides at the end, so you don't have to worry about writing these down. But any questions?
This is really just more of a comment, maybe to help. I recently did a analysis of the LinkedIn data against a large e-commerce site, and just against the subset of commercial customers, there were about a 16% overlap between the LinkedIn data and their active customers, and of those approximately 300,000 users, only 10% of them had changed the password since the LinkedIn breach. So that kind of gives you some sense of what the potential exposure is from these breaches, and giving you the incentive to go, to go down this road.
Yeah.
Yeah, the customer angle, I guess I agree on the 10%. We tried resetting passwords, sent password reset email to about 4,000 people, and about 200 people changed their passwords. So it's a tricky issue. Yeah, you can easily off-put customers from your website easily by doing that. Also, an interesting observation. So all the leaks that recently have been for sale for $1 and all that stuff, it seems like the information that's being sold now is probably the same one that maybe Alex Holden has had for a number of years, only now gotten into somebody else's hands.
Yeah,
So
yeah. A lot of them seem like it's people that they've maybe weren't even directly involved with the hacking it when it originally happened, but they were one of the inner circle of people that happen to have that private data, and they've decided now, well, I might as well sell it and try to get some money out of it or share it or whatever the case may be.
So you briefly touched on the possibility of storing user passwords in a weaker hash algorithm in order to compare against leaks or leak data. Do you have any advice for making your system robust such that if you decide to follow that strategy, you don't make your own system more risky or more risk-prone to a dump?
Sure, and let me be clear on that. My advice is not that you store an MD5 record, password hash record for your users. It's that you hash with MD5, and then you use your scrypt or bcrypt or PBKDF2 on on the resulting hash of that. So the idea being that you're starting from a known place, the MD5 hash. So if you get more MD5 hashes in from a leak, you can then put them through that same, starting on that step, put them through your stronger password hashing process, and then compare the results without having to crack those original MD5 passwords. But yeah, don't store like an extra record with MD5 or SHA-1 or anything weaker than that.
Okay, so I'm going to stop it there, and I will give you the opportunity to have lunch. When we get back again, the next two talks are really taking us into the psychology and linguistics area of passwords, and I'm really looking forward to those talks as well. So be back here at 2 o'clock. Okay? Thank you.
Hey.
So, hey, no brown M&Ms. Nice. You should ask.
The Android lock pattern analysis on how people create lock patterns on Android phones. So now I'm messing around with this Chinese student for her PhD project. We are also looking into some password-related stuff, obviously. So we'll see next year if there will be any talks from that research as well. So yeah. Do I have any? Jeff, do you have any funny password stories to tell? I'm kind of like, this is the 10th time, so I think I've told the majority of my password jokes so far.
Maybe we should just go back to that password jokes thread on Twitter.
Oh, yeah, that one, yeah. A password walks into a bar and...
I forgot.
You can, I forgot it, yeah. I did that on Twitter. I just wrote, a password. Well, a password walks into a bar, and as an example, there was one. Yeah, we don't allow any funny characters. That's one of them. Yeah, and this actually sets the bar pretty low. Jokes like that. Yeah. We could also do for biometric or for PIN codes, for that matter. A passphrase walks into a bar. So. We don't. We do allow special characters, or we don't. Yeah. You have a big smile. You do look like an emoji. What are you doing here? A passphrase walks into a bar, and the barman says, "We don't have space for you." Okay, I get it. I'm gonna refresh that thread on Twitter again. Because that was actually, it was really good. Yeah, there was lots of really crazy examples there. So I should rerun that one. Passphrases, passwords, pins, biometrics, maybe. I'm not sure. Global entry. One of the things that I understand, every time I come here to the U.S., I have to give away all my fingerprints at border control. But this could be related to the fact that I have been military police, so I know very well how to do a pat down. But these TSI people, the few times that I have been, the subject of a pat down, they don't seem to really know how to do it. I mean, like, are they afraid of touching something, or what is it? It's like, do it properly. That's me. Well, maybe it's just me.
Pat down unless they need smoke afterwards.
Well, I haven't actually seen any of the agents qualify for that one yet. Maybe just me. Hey, it's 2 o'clock. So this is Matt. He's been with us before at Paswords16 here in Las Vegas. And like 20 minutes ago, he told us that he only pulls the doctor card when he's mad at somebody. But Matt actually has a PhD in password cracking and optimizing how he can crack your passwords. So and he told me, he put actually out on Twitter that he was going to try to make this a little less academic. And I can only say thank you for that. And I look forward to talk, Matt. Go ahead.
Thank you very much, Per. So I got my start, as he mentioned, basically when I decided to go back to college. And I was very lucky to be able to get involved with the E-Crimes Investigative Technologies Lab at Florida State University. And the whole idea behind that lab is to do research and develop better forensics tools for law enforcement. And as you can imagine, cracking passwords definitely kind of falls under that category there. So that was a tremendous opportunity. I've since graduated, found myself a real job, and so since I like that real job and I want to keep it, I really need to mention that all the password cracking and password security research that I'm doing is on my own time, and so all of these opinions are my own and not my employer's. So I was spending a lot of time trying to think about what I should submit here to PasswordCon, what would be fun. And I just wanted to mention a couple of other little hobbies that I'm doing right now when it comes to password security. One thing is that IBM right now is offering a real-life quantum computer free for any researcher that wants to use it. So you can log right onto this here. It's a 5-qubit computer, so it's a real one. It's not like those D-Wave ones where it's somewhat kind of like quantum computers. And it's basically like the old mainframe days where you basically you write up your program, you submit it to them, it gets queued, eventually they run it, and then they send you the results back for it. And it's just a tremendous, wonderful opportunity. Now, quantum computers have the potential to really impact the password security landscape. I won't really talk about that because there's been other conference talks that people have mentioned about it. But what I really wanted to highlight once again, though, was that this is free, and this is something that anybody can do. So I highly recommend that everyone here in this audience go out, sign up, and then just play around with this here a little bit. Even if you don't care about quantum computers, just do it for the bragging rights. Have it open on your screen on your work. When your coworker comes by, you can be like, and they ask you, like, what are you doing? They're like, oh, I'm just programming a quantum computer. What are you doing? I mean, are you still using a classical computer? That's, really lame. So, I mean, that's just kind of what I want to really kind of highlight about that.
Yeah, but that's when your coworker then reminds you that they're a PhD.
So another, research topic that I'm very interested in right now is trying to figure out what a hashing algorithm for biometric measurements should look like. Because this is a really big problem right now. And I'm not talking just about your iPhone logging into that or potentially log into a website with your fingerprint. I'm talking about these large databases of biometric information that's currently out there right now. I mean, for example, who here had their fingerprint stolen from an OPM hack at all? I knew I'd catch a couple of feds that way. But it sucks, doesn't it? I mean, and the problem with biometric information is once it's stolen, it's gone, okay? There's no getting that back. You can't change it. It's just gone. So this is an area that we really need to have better research on in order to try to limit the value that these biometric databases provide to an attacker. So that's all cool stuff, but I'm going to talk to you about modeling instead. I know this is generally not something that people really, get super excited about. Like, oh, hey, we get to use, different types of, regular grammars and go ahead and try to figure out how to go ahead and model how people, behave. But it's something that I feel is very useful for probably just about everyone here in this room. Because there's definitely offensive, uses for this here when it comes to, developing better password cracking algorithms. Because if you can model someone and how they create passwords, you can definitely, weaponize that model in order to, crack their passwords better. But there's also lots of defensive applications as well. So you can start talking about how you make better, password security policies, and how, there's a couple other applications as well. So regardless of whether you're on the offensive side or the defensive side, or you just want to do some more research, there's a lot of stuff here that I hope can be useful for you. So it can be very easily said, though, that we don't need better modeling techniques. I mean, current attack techniques are amazingly good right now as it is. This was based upon the more recent MySpace leak, and Cynosure Prime posted basically a write-up of how they were attacking it. And they managed to achieve a 99% success rate against all these MySpace users. I mean, that's really good. I mean, whenever you can say that you cracked 355 million passwords, you don't need to up your game. Your game's already up there, okay? You don't need to really advance your techniques that much. But there still is a lot of room for improvement in areas where that improvement is really kind of needed. So, I mean, for example, when we talk about computer forensics, hashes are getting stronger. You can only, especially when we're talking about like full hard drive encryption or other types of file encryption, you're really kind of limited in the number of guesses that you can make. Or you start, people actually start deploying Argon 2 eventually, maybe. On the defensive sides, we really want to go ahead and have these better models so we can tell what's a strong password versus what's a weak password, so we can make more sane password policies. And then also I'll talk about honey words, which is a way to be able to make basically fake passwords in order to mess with people. But what it really comes down to is that we have all these different data sets that are getting released and that we're cracking and we're learning about. And a lot of times, we'll go ahead, we'll run some statistics against them. We'll make some great, graphs. Per and Jeremy made this one here about the LinkedIn list. And there's a lot of little cool tidbits in there and a lot of kind of useful information. But kind of the question comes back to, how are we going to actually make use of this information? How can we go ahead and use this to improve our password cracking techniques or improve our defensive techniques in order to make people more secure? So that's what I was really kind of curious about, is how can we go ahead and kind of automate the learning process of, here we have this leak, and how do we incorporate that into our knowledge of how people create passwords? So when I first really kind of started working on this research, my approach was I wanted to make an automated rule generator. So I wanted to go ahead, parse a list of cracked passwords, and then just create mangling rules based upon that list in order to feed into John Ripper. Hashcat wasn't really around that time, but that's the kind of general approach that I wanted to take. And I ran into a lot of different problems, which I'm going to talk about really shortly here. But it's a very useful technique. So I mean, if you're looking for tools that do this type of thing, I would probably highly recommend either Barbell's Rule Finder or Password Analysis and Cracking Kit, PAC. The problem is both of those tools haven't really been updated in the last couple of years. So if you're looking for a research project and Per hasn't already tasked you with something, I would say that this is probably an area where there definitely can be a lot more work being done. Probably though, the one area that was the biggest problem when I was running into when trying to go ahead and create an automatic rule generating kit was that the words that people use in passwords have very different probabilities associated with them. A whole lot of people use password. Some people use monkey, and then or baseball, and then you have people that are down there who are using like piano or zebra, and you really kind of want to be able to represent that. And it's hard to do in a lot of your password cracking sessions that you run. So for example, if you want to use like the entire core logic rule set that they released there, you have to run a really small dictionary against it if you ever wanted to have it complete. So a lot of times in order to crack passwords, I'll have a very targeted input dictionary that I'll run really advanced rules against. And I'll have a much larger input dictionary that I'll run much more targeted rules against in order to try to do that. But that's it's a big pain in the butt. I would like to be able to just go ahead and run my cracker and have it be able to take into account the different probabilities of these different words. So that way I do a lot of advanced mangling rules automatically with these really very common passwords, and then less mangling rules with the less common passwords. Also, combining different mangling rules is kind of tough, especially when you're talking about learning from a data set. So doing a very basic idea of like, okay, people put digits at the end or they, capitalize the first letter is pretty straightforward. But when you start combining it, so like, okay, they capitalize the second letter in the word and they replace the A with an @ symbol and now they add digits to the end and then they have a special character, that's really hard to go ahead and figure out how to combine those different rules together. And when you start to do that too, the number of rules that you have just absolutely explodes, where all of a sudden you're generating millions, if not billions of rules. And I'm not exaggerating here. That's actually what's going to happen when you start trying to go ahead and do this types of modeling. Also, when you do a lot of this training, it's often not very predictive. So you might not see something exactly in your training set, but you'd want to try that in your cracking session. So you want to be able to support that. Now with some of these bigger data sets, that's not as much of a problem. I mean, when you have 360 million passwords, you're probably going to see just about everything. Or if you don't see it, then you generally don't care about it that much. But when you're trying to make a more targeted rule set against, let's say, a corporate entity, you might only have, several thousand passwords. And you want to be able to learn based upon that there. And so that's what really kind of drew me to probabilistic context-free grammars. Because when we talk about how people create passwords, we generally always talk about probabilities. So we say, okay, 90% of people, capitalize the first letter of their password, or 80% people put digits at the end, or 5% of people use their dog's name in their password. And so these are all probabilities. So it'd be really nice if we could take all these probabilities that we're talking about, the probabilities that we learn from these different data dumps, and directly incorporate them into a model and then generate password guesses based upon those probabilities. So that way we don't actually have to manually create all these different rules. We just kind of let the probability is kind of sorted out for themselves. And, oh, sorry, yep. Oh, yep. That was definitely a good kitten there. And that's pretty much like my cats. Oh, it is kitten? Twice. Kitty? No, the H instead of the N. Oh, that's intentional there. Yep. But we don't get it. Sorry. It's kind of a lolcat speak, where they'll go intentionally make it the cat speak incorrectly and not use proper grammar, which I'll admit it's probably a little ironic since I'm talking about grammar here and proper grammars.
Irony's good.
Yep. So I can start talking about all this and how probabilistic context-free grammars are good. But really, I mean, the proof is that when our researchers have done studies on this, is that probabilistic context-free grammars, when you use them, generally tend to mimic how people create passwords better than alternate methods. So this was done by Carnegie Mellon University last year when they were going ahead and testing different password cracking attacks, and they have basically a password guessability lab that you can submit passwords to and have them running these attacks against it. And probabilistic context-free grammars really kind of did better than just about everything else. And that includes, let's say, the pros, which was the core logic team was brought in, and they definitely know a lot about passwords. And while they eventually were able to crack more passwords, if you really want to talk about just how it accurately modeled the precision of the grammar, PCFGs pretty much did better than anything else. So that's kind of my spiel on why this probably is going to be interesting to you guys, hopefully. So I'm going to have to do a little bit of academic stuff here, and I apologize. But what I really wanted to do was just talk a little bit about what probabilistic context-free grammars are, because there's a lot of misconceptions. And probably the biggest misconception is that they're complicated and require lots of math. It's kind of great when I get up and talk about people and they're like, oh, he's talking about probabilistic context-free grammars, he must be smart. Not true. Well, hopefully it's true, but it doesn't automatically flow from that there. Probabilistic context-free grammars are actually probably easier to use than Markov models there. I mean, there's really no math required when we talk about context-free grammars themselves. It's more like Mad Libs. So any type of grammar can be defined by 4 different things. Non-terminals, which can be replaced, and they're basically variables. Terminals, which are kind of the constants, they can't be changed. Replacement mapping variables to the constants. And basically your start variable that you start out with. And what you do with a context-free grammar is you start with your start variable, and like Mad Libs, you just start replacing it until everything that you have is now a constant. So let me go over an example of that there. Let's start with this very basic kind of context-free grammar that's kind of modeled after passwords here. And you have a start variable, s, that goes to letters and digits. And you have an L that goes to 3 different words here, and then D that goes to 3 different digits. So with the context-free grammar, you start with your start variable here. And then you just go ahead and replace it. So you replace that with L and D. Now, since it's context-free, each of these different variables here, these are 2 different variables, can be replaced independently of each other. So if I want to, I can go ahead and replace that L with anything. So for example, I can replace it with baseball. And then I take that D and I replace that with 82. And since everything now is a constant, I can't replace it anymore. Now I have my final terminal. So as I said, it really is just kind of like Mad Libs. You just keep on doing this. And while you can get more complicated with your grammar itself, essentially all you're doing is just this right here. And that's context-free grammars. Now, when we talk about probabilistic context-free grammars, unfortunately there's a little bit of math involved. But really, that's the only math that you do is multiplication. Nothing more complicated than that whatsoever. There's no calculus or anything else. You're not doing matrix multiplications or anything. It's just standard multiplication. And what you do is that every single replacement that you have has an associated probability with it. So that the final probability of your terminal is the product of every single replacement it took in order to get to that terminal there. So just kind of going through that previous grammar that we had there. You start with your start symbol, and probability of that's 100%, because that's where you always start. And this grammar here, there's only one replacement, so the probability of the next replacement there is still 100%. We want to go ahead and replace the L with baseball. The probability of that's 10%, so 10% times 100% is 10% for this current running probability that we have. We replaced the D with 82, which is a probability of 25%. And 25% times 10% is now 2.5%. And what this means is that the probability of this grammar generating the string baseball 82 is 2.5%. And this is incredibly powerful. So if you're cracking passwords, it's pretty obvious to see how you'd use this probability. You want to start with the most probable password guess, try the second most probable one, then try the third most probable one, and so on. Or if you're trying to go ahead and do it a little bit faster and parallelize it, you can take some shortcuts and instead say, I want to go ahead and generate every single password guess that falls above a certain probability threshold. So that way you can kind of limit the key space that you're searching against while still making use of this grammar. It can be used also for like password policies for defensive purposes, where you basically go and tell someone, hey, I'm sorry, your password's probability is just way too high. Because you actually have a probability associated with that password that they just created. And what's more, you can go ahead and suggest other alternate replacements according to your grammar that would reduce the probability of their password down to an acceptable level. So that way people can go ahead and create passwords kind of the way that they want, or at least somewhat related to the way that they want, while still meeting your security requirements. Yep?
Why wouldn't it factor in that certain digits may correlate differently with the words, the letters?
Okay, so that's a good question. Yeah, so I'll go ahead and do that. So the question was, how does this go ahead and correlate, let's say, the probability that certain digits might occur with certain words in a higher different probability? And the short answer is, at least if it's using context-free grammars, it doesn't. And the reason why I chose context-free grammars versus context-sensitive grammars is mostly because the training is much easier. And when it comes to passwords, I found that there's very few context-sensitive letter replacements. People, they might choose their dog's name, but then they don't choose, 82 related directly to their dog for the most part. It might occur some occasionally with, let's say, your daughter's name and then her birthday or something like that. So there might be some context sensitive, but that's really hard to model, unfortunately. And I'll actually talk about how you can cheat a little bit and get some context sensitive information and kind of mash it into a context-free grammar. So that's something that I've struggled with, but long story short is that most passwords I've found anyway, you don't have those context sensitive replacements there. So and then the other thing I'll talk about a little bit is just honey words, which as I said are ways to be able to create fake passwords that look real. So that's kind of the end of the academic side of things. I want to talk more about the practical things because I promised I'd do that. So this has been around for a while. And about last year I decided I wanted to go ahead and completely recode my entire probabilistic context-free grammar. And part of the reasoning behind that was that it was becoming very hard to modify. I had basically baked in a particular type of grammar in order to model how people create passwords. And that was limited, and I wanted to make changes to it. And what was actually really driving that was I was trying to get into passphrase modeling with context-free grammars. So I was scraping Per's Twitter account and his blog posts and stuff like that in order to try to make a paraphrase generator. Yeah, I mean, so actually some of that's still going to get the GitHub results there. But basically I was breaking my code left and right, and I was getting really annoyed by it. And what so I really wanted to do was kind of go back and be able to make a kind of a cracker that would be able to work with any generic context-free grammar. And what this means is I could really focus my time on trying to mess around with the modeling of how people create passwords. And I just have a tool that would just kind of work in order to be able to test and see how effective those models were when cracking people's passwords. So it's coded in Python, so that way it'll go ahead and run pretty much wherever you want it to go. It works with both John the Ripper and Hashcat. It is open source, so you can go ahead and grab it and modify it to your heart's content. And there's a lot of documentation that I've been trying to put up there on the wiki itself. And so kind of going back to why was I doing this, there's a lot of improvements in the grammars that I'm going to be talking about. So beyond from what I was doing before, another group at Florida State University decided to go ahead and modify the grammar a bit. And they had absolutely huge improvements in the results of just going ahead and changing how the grammar was laid out. And I think there's a lot more room for improvement even beyond this here. So what I really want to be able to do is allow other people to go through and kind of make their own grammars, make their own training programs, and then have the tool for them to be able to go ahead and test to see how well they work. So I include one kind of default training program in the GitHub page right now. I'm probably going to release a couple more as they mature a bit. But basically what you do is you run it on your list of cracked passwords, and it'll go ahead and generate a grammar for you automatically. The only thing that I really recommend is that you install the character detect Python package when you do this. It's not required. It'll give you a warning, but most people will probably ignore it. As we learned from last year's Core Logic Crack Me If You Can competition, dealing with different encodings in your training set is a real pain in the butt. So I found this Python package actually handles a lot of that for you automatically, which is really nice. Because we got to show some love to some non-English speakers out there too. So I don't expect you all to read this, but basically when you run this here, it goes ahead and creates a config file that describes the grammar that you have. So you'll start with your start symbol up here. You'll have different replacement values in there, and it'll actually say, okay, your 8-character letters are stored in this directory. And this just kind of goes back to the fact that you can now modify your training program to run a completely different types of grammars, and then the cracker will automatically read this in and dynamically use this. So that way you can use the same password cracker or the guess generation tool for, let's say, passphrases versus password cracking. So now I'm going to talk a little bit about the basic model that I'm using right now in order to model how people create passwords. And what I expect when I go through this is good questions like the one over there, where basically you kind of ask you like, wait, there's got to be a better way to do this. That seems kind of ad hoc or crazy. There's totally a better way in order to represent something. And that's what I kind of want, because that way, quite honestly, there is. I mean, every single choice I made here. I mean, there's a couple of alternate choices I could have made. So I really want people to go out and kind of make their own training program, make their own grammars, and then make a better model than what I have. So right now, what I do is I first kind of go ahead and scan the password, and I break it up into what I call a base structure. And this is kind of resembles like a hashcat mask, where you go ahead and you break everything up. So okay, it's alpha characters, digits, or other. And I associate a number after as well. So this is like a 3-letter word or a 4-digit number. And the reason why I associate those numbers directly after it is so that way I can do things like I can represent 2 words, 2 4-character words versus 1 8-character word in my base structure there. So for example, cat123 would be parsed as an A3 D3, or hashtag Paswords16 would be parsed as a O1 A9 D2. So the next question though is, what about capitalization? Because every once in a while someone capitalizes their password if they don't have to. So what you can do is have a replacement go to another replacement. So basically you can have a rule that your alpha characters go to essentially a capitalization mask that gets applied to your password as well. And those capitalization masks have a probability associated with them too. So that way your A3 can go to, let's say, uppercase the first character at 10% of the time, and then that will go to, let's say, cat, a capitalized cat, at 80% of the time. Now you can get even further into that there as well. So now we can assign probabilities to individual words. And this is kind of really powerful. So that way we can say exactly, this is how probable the word password is, and this is how often we want to use it in our test set as well. And what's cool about context-free grammar versus some other techniques is like Markov models is that you can dynamically change this without going ahead and having to retrain your entire data set. So let's say I go ahead and I train this on like RockU. I can go back later on and say, okay, I'm attacking some other data set. So I'm going to go ahead and change the probabilities with these words and make these other words associated with that data set be really high. So that way we can start directly using things like your target's pet's name or the name of their site that they go to and so on. And we can do the same thing for digits as well. So that way you can raise the digits of their birthday or their zip code to be much higher than you would normally see from your training set. So the next kind of improvement I've been making is modeling keyboard walks, because those are really popular, especially in your corporate environments. Because, I mean, if you're giving these people these crazy password requirements, I mean, that's obviously what they're going to do. I mean, it's much easier to remember a keyboard walk than have to remember, some random passphrase. So I added a new non-terminal to the base structure K just to represent, keyboard walks that you have. So now we have alpha characters, digit characters, keyboard walks, and other. So for example, one QAZ pass would be a K4, A4. Or you could have multiple keyboard walks, so you have multiple, K4s, back to back there. Because that kind of represents how people kind of have a tendency to kind of do a keyboard walk here, and a keyboard walk over here sometimes. Now, one cool thing about this is in the training set, it basically creates a dictionary of all the different keyboard walks it finds. So if you want to, you can go ahead and rip this data out of the grammar here and use it for whatever input dictionary that you want for your normal password cracking attacks as well. So you don't actually have to use a context-free grammar when you're making use of this data. And there's not a whole lot of good keyboard walk data sets out there. So this makes a pretty easy way to do it. Now, one thing I want to kind of point out, though, is that you have to be really careful in training this. Because there's a lot of words out there that look like keyboard walks that aren't. And you don't really realize that until you start running this, and you're like, why the heck is Drew like one of the most popular keyboard walks? Well, it's a name. But, if you look at your keyboard, it's going to be, it's a keyboard walk as well. So you do have to kind of start adding some whitelisting on that. One other thing that I've been kind of dealing with that causes a lot of false positives is I was trying to include hitting the same key multiple times as part of a keyboard walk. I don't know how much people actually do that. I mean, I've been looking through the data sets. It's not really that common, it seems like. So I have to admit, in my training, I'm probably going to just go ahead and exclude that so I don't cause a keyboard walk like tree, which once again is, looks like a keyboard walk to the algorithm there. So as was mentioned earlier, while rare, there occasionally are context-sensitive replacements as well. And you kind of want to, kind of shoehorn those into your cracking session. So, I mean, probably the most common examples of that are emoticons. So you don't want the, funny, smiley face to be parsed as, a A5, S1, A1, where it's, a word, special character, and then another word. Also things like, number one. I mean, that's a very common, context-sensitive replacement, and you want to be able to kind of model that. So what I did was I really cheated. I mean, that's what it comes down to. And I created a new class that says, okay, these here are, context sensitive. I'm going to go ahead and manually enter those in my training data set. And I'm just going to treat those like a whole nother replacement, just add them together there. So that's pretty limited right now. As I said, there's not a whole lot of context sensitive data I've been seeing in the training sets. But if you want to extend that, you can start adding all sorts of emoticons there if you really want to. So letter replacements, this is actually something that I'm working on still right now. It's proved to be a little bit trickier than I originally expected. But one way to be able to handle this is to just handle it as another mask for your replacements, just like we do with capitalization. So that way your three-letter word goes to your capitalization mask, then that goes to your word, cat, and then that goes to potentially a replacement at a certain probability of, like, let's say replacing the A with an at symbol. Unfortunately, this does complicate the grammar quite a bit by adding another level into that there. But what's really kind of I'm struggling with is just training is difficult for this. Because you have to have a way to be able to differentiate that, cat one hat is not a replacement. It's just adding a digit right in the middle of that there. And then you can have words that have multiple replacements as well, like, password with the at symbol and the 0. So, I mean, that's still something to really kind of work on there. Luckily, not a whole lot of people still use replacements. I mean, it shows up if you're really trying to crack passwords, but it doesn't hurt the grammar not to have them that much. But really, I just want to be able to model this because that is something that does occur. So that's the current grammar. So if you go ahead and you download it right now, you run it, that's kind of the grammar that's using in the back end. But I wanted to take just a couple of minutes to talk about potential grammars that I've been thinking about and eventually might get off my butt and start trying to code, because I think there are much better ways that we can go about doing this. So what I'd really like to do, though, is kind of go back and take a step back, get rid of those base structures, and really start to have a grammar that kind of models the thought process that people use when they're creating a password. Because people don't immediately create a mask and start filling it out when they create a password. They basically, you say you want them to create a password, and they immediately go to kind of a coping technique in order to create that password there. They say, okay, I want to go ahead and create a dictionary-based password. So name of my dog, or I want to go ahead and create a passphrase, or I want to go ahead and use a keyboard walk, Or you can get things like, I'm going to go ahead and use my email address. So that can be the very first kind of step in your context-free grammar here, is figuring out which attack method you really want to model. Next after that, let's say they choose a dictionary word based attack. So the next replacement would be, do you want to go ahead and choose a word from your input dictionary, or do you want to kind of dynamically generate a word from, let's say, a Markov model? Because I'm going to talk about this in a little bit, but probably the biggest weakness in current context-free grammars is that they're really dictionary-based. They're really dictionary-focused. And our input dictionaries really suck. So that's when you start seeing how Markov modes and neural networks start really being much more effective over a longer cracking session in context-free grammars. The reason for that is that your input dictionary has basically exhausted all the words that it could possibly crack. So when I start looking at the words that I didn't crack, a lot of them are really basic mangling techniques. It's just that I didn't have that word in my input dictionary. So you need to be able to have a way to go ahead and kind of dynamically generate those, because trying to keep an input dictionary up to date with all the new Pokemon characters is just a losing proposition there. But let's say you choose a word from your input dictionary. The next step in your context-free grammar there might be go ahead and apply required digits. So then you can have a probability of it appending the digits to the end, inserting the digits to the front, or performing a letter replacement. And you can have other different types of replacements as well. So at the same time, you'd be going ahead and applying required special characters if need be, or checking for length requirements as well. Now, for some of you formal grammar fans out there, you might be looking at this and saying, this looks a lot like a finite state machine. Okay, I know there's probably like one of you, but the answer is yes. And so one nice thing about context-free grammar is you can model finite state machines with it. So this way we can go ahead and start testing out how effective this is. And then if this turns out to be a really effective way to be able to go ahead and model people's passwords, we can go ahead and then go back and make a much more simplified model using a finite state machine. So that way we can go ahead and potentially make it faster or make it smaller. Actually, I covered this part here, but so as I said, one of the biggest problems though with context-free grammars is the fact that they are, are dictionary-based. Probably the best example though of a context-free grammar that handles brute force really well is actually the Prince attack in Hashcan John the Ripper. And what this does is it just takes an input dictionary and it starts combining all the words in an input dictionary together. And where it performs essentially a brute force attack is that if you have one character words in your input dictionary, it's going to start combining one character words together, and it essentially does a very basic brute force style attack, while at the same time adding digits to the end of your longer words. And so that's one approach, but I think that we can probably do better and start using some of these more advanced Markov modes as well to make just this a little bit more precise. So that's definitely on my to-do list. So I'd mentioned earlier passphrases. So this is kind of one of those big problems there. And one question I had was, can I go ahead and use a context-free grammar to kind of dynamically generate passphrases for use in password modeling? And probably the best example of a context-free grammar generating passphrases is SciGen, which is Omeg's CS paper generator, which is hilarious, by the way. Basically, some researchers coded this up and started making fake scientific papers and made them to conferences to see whether they could accept it. Might try that sometime with Paswords16 here. The Nmap one, if you've ever read that one, it's hilarious. I probably won't talk too much about it because it's not safe for work, but it's a very good example of that there. So I thought there might be some potential there for that. So as I said, I started going ahead and trying to model this. And one problem I ran into was that you're just kind of your generic model of taking like a proper noun, verb, adverbs, and noun. Even when applying some probabilities to that, it would create too large of a search space. It just wasn't very effective at all. So a successful grammar probably needs more context-sensitive information than a pure context-free grammar you can get. But as I said, one way that you can start getting more information is really just target this against a particular individual. So not just going ahead and saying, I want to go ahead and generate passphrases for everybody, but I want to go ahead and base these passphrases on one particular writers. So one thing I highly recommend, and I have a little bit of code there in my GitHub repository, it's kind of iffy state, is to use what's called the Natural Language Toolkit, which is a Python library that you can run a corpus of data through, and it'll automatically go ahead and parse it down as noun, verbs, or adverbs, and break this up into different structures. So that way you can kind of use this in your training set. One thing I really want to try, though, is a much newer toolkit, is Google's new Parsey McParseface. I'll admit 90% of that's just due to the name of that tool. But basically, they released it as part of their TensorFlow toolkit, and it does a lot of the same types of things of parsing a input dictionary and breaking it up into these different types of grammar structures. So kind of the next question, though, is, okay, so we have this great and wonderful grammar. We spent all this time training it. We spent a lot of time trying to figure out how it works. How do we actually make use of this grammar? Okay, how do we get from the academic side back to more of the practical? So I'm going to start with the defensive applications first because I really want to kind of push those. But one way, and it's been really kind of fun, is with honey words. So honey words are kind of a synthetic password. So you kind of algorithmically generate these passwords, and you can use these for different types of opportunities. So they were originally thought of as kind of being like a canary type of alert sensor for your data sets. So you create these fake honey words, and then if you ever see someone try to log in with those honey words, then you know you've been pwned. So you can set that as kind of an alert. I have a little bit of disagreements on how it was kind of laid out in the original papers that talked about it, but one really cool tool I saw out there was this one right here that basically goes ahead and installs a client on people's computers and installs basically a fake account or a password into the computer's memory. And this password is unique to that computer. So it's a valid password, and you could use it to log in. It shows up in memory. If you have, you logged into it with Metasploit and you jump to credentials, it's going to look pretty much normal. But that password is only valid on that one particular computer there. So it won't help you go ahead and actually move laterally. But if someone tries to go ahead and authenticate against the Active Directory account, it'll send out an alert. So that way you can kind of start detecting some of this lateral movement that's going on in your network if someone goes ahead and tries to pass the hash with the wrong hash. So that's a really kind of cool tool. But part of that is you have to be able to make a password that fools an attacker so that they think it's actually a real account versus something that's set up to fool them. Because they're going to see that client tool on the computer as well that's inserting those passwords. Other usefulness for that there, if you're setting up a huge honeypot. I mean, if you want to create a fake Active Directory account or a server for people to break into, you don't want to have to go ahead and hand jam 1,000 passwords into it. So this is just a really quick way to be able to go ahead and generate those passwords and have those look fairly legitimate. Also, if you're going ahead and running a password cracking competition, if you need to create a large data set that looks somewhat real, this is probably one way to do it. So that way you can go ahead and you can run it, and these passwords are going to look a lot like the passwords that you trained on. I didn't put this in the bullet points, but also if you want to go ahead and just mess with people, you could create fake password data dumps too if you wanted to. So, I mean, they're just a lot of just kind of fun things. So this is one of those things that when I started playing with it, I was like, yeah, it's not really worth that much, but it's really easy to implement, so why not? And the more I've been playing with it, the more fun I've been having with it. Included in the tool set there is a tool to go ahead and generate honey words from whatever grammar that you create. So you basically just tell it which grammar you want that you trained on, tell it how many passwords you want it to generate, and it'll go ahead and just go through that there. And that's actually pretty fast to be able to do too. So you can generate as many passwords as you want. So the other thing is with password policies. So as I mentioned earlier, if we can go ahead and assign a probability to a password, we can then go ahead and say, okay, your password is, 2 probable. Where this is really nice, though, is as I said, you can recommend passwords that are very similar to the password that the person created, but have just maybe 1 or 2 transitions that are different from how they selected it that would lower the probability of their password. So that way they can create a password that's kind of like the way that they want to, but it's a little bit more secure. Now, how you recommend these transitions has to be randomized too, because you don't want everyone who chooses the same password to automatically choose the same replacement. But you can start to go ahead and do this in order to kind of stretch out that search space an attacker would have to do in order to be able to crack them, while at the same time hopefully not infuriating users that much. And kind of going back to that keynote speech, you can start teaching people what makes a secure password and what's not by showing them examples of this here. So that when you show password, 83 versus kitten 83 and saying, are these passwords, the same probability, people will be, okay, kitten 83 might be a little bit lower probability password. That being said, about 1 week before I presented here, Carnegie Mellon University came out with this amazing paper, absolutely amazing, talking about going ahead and modeling passwords with neural networks. And the one nice thing about them is that the resulting neural network that they can send out is really small, so that way you can go ahead and incorporate it in, let's say a browser. So I would say that if you're really interested in making more secure password policies, to go ahead and check out their work as well. They're going to be presenting this at, I think, SOUPS in a couple of weeks. Or Usenix, okay, sorry, yep. So that would probably be a better way if you want to go ahead and create better password models for password policies. That being said, after my depression came off and I had a chance to really read through that paper a couple times and realize that
what are you doing here?
yeah, I know exactly. That was exactly what I was thinking. I had a chance to kind of look at this, and there are pluses to using probabilistic context-free grammars. And probably the best one is that I can go ahead and I can incorporate their work directly into my grammar. I mean, there's a Star Trek convention going on right now, so I can be like the Borg essentially. I can go ahead and take their techniques, and just like with Markov models, I can go ahead and incorporate their techniques in order to basically generate better strings. So actually this makes me very excited. So unless they can show that their entire model is better than using probabilistic context-free grammars at all, it's something that I can basically make my tools better. So what you're probably all interested in really though is cracking passwords with probabilistic context-free grammars. So really the first thing I have to say though, and this is going to probably be disappointing to everybody, is that the current implementation is god-awful slow. Okay, so when I run it, it's generally generated about 50,000 to 100,000 guesses a second. Now that may seem like a lot, unless you're used to using your hashcat cluster where you're making billions of guesses a second. So if you're talking about attacking a fast hash, don't use this. Okay, you're much better off using even pure brute force or something like that. Because you're just making so many more guesses that even the increase in the precision just isn't worth it. Where this is useful, though, is when you're dealing with hashes that are really slow. So let's say you have a large list of salted hashes, or you're trying to attack like full hard drive encryption, or doing something where the slowness of the guess generation it doesn't really impact your hashing of it because the hashing just takes so much time. So there's definitely still uses for this here. The performance of this is very dependent upon the grammar. I won't go into that too much here, but basically, depending on how many replacements you have and how many values can map to a certain probability in those replacements, it generates essentially very fine-grained word mangling rules. So the less fine-grained that you make it, the less overhead that you have in trying to generate in probability order, and then the faster the whole thing runs. And if you're interested about that, I can talk to you more about that later. So long story short, though, you can totally crack passwords with this right now, but it really is kind of geared more as a kind of a research tool. But that being said, probabilistic context-free grammars don't have to be slow. I mentioned earlier, Prince is really just a probabilistic context-free grammar. It's just a very specialized one. And I don't think anyone said that anything that Adam has ever written has been slow, okay? So, I mean, you definitely can take a grammar and move it back and then make it much more fast if you want to. Also, when talking about replacing, or how to make these grammars and stuff like that, you don't really have to make things really that fine-grained. So there's this really fun law called Zipf's law. I just love it because of the name. But it basically says that the probability of a word is proportional to where it is. And what that means is like the most probable word is used a whole lot. The second most probable word is used a little bit less. But then you start getting down to this tail end here where all the probabilities of the different words kind of look pretty much the same. And if we just go ahead and flip this around here, this looks like just about every single password cracking session ever. And so the question was whether Zipf's law applies to passwords. And there actually has been a paper that does that. And it says, yes, passwords follow this type of distribution here. Which is kind of, we should all know, password 123 is really common. Zebra 123, not so much. And what this means is that modeling the probability of these first ones here is really important. But after that, you can just feel like, screw it, everything's about the same probability. And this is a way that you can go ahead and make the grammar a little bit more effective, or at least a little bit more scale a bit better with performance. Also, Carnegie Mellon University, they've been definitely doing their own work on password probabilistic context-free grammars as well. And their approach was to, in order to reduce the overhead, was to go ahead and spend all the time, generate all of these basically rules here, and then save them on disk and sort them, and then it's already there. So that way, all that overhead just goes away, and they can go ahead and make guesses with that at a much faster speed. So, it's not like we're using those disks for rainbow tables anymore, so we might as well be using them for something. So that way we can go ahead and start using these pre-computation attacks as well. The problem with that is when you do something like this is that you lose the ability to dynamically change your grammar after the fact. So if you want to go ahead and model it towards, let's say, a particular target, this pre-computation attack is not going to work quite as well. So kind of the deal with this here, I'm starting to look into maybe moving the grammar into the GPU. So the current PCFG cracker that I have right now, it tries to generate all the guesses in probability order. So it'll generate the first one, then the second one, and then the third one. In the GPU, you really don't care. You just want to go ahead and generate all the guesses that fall within a certain probability threshold. So that way you can go ahead and parallelize it. So what I can do is, I'm starting to modify Hashcat. Hashcat's open source, which I'm really psyched about. Version 3.0 is really cool too. And I'm basically kind of copying some of the techniques that Hashcat's already using in their Markov mode, where it uses what's kind of called it's a modified beam search, where you basically look at the different replacements and only do the first couple of replacements that you specify, and everything else you just kind of skip. And this way, you don't actually have to do any math whatsoever in the GPU, which is really big. And it also reduces the size of the grammar because any single replacement that falls below that threshold, you just don't even need to load up into the GPU at all. So basically, we're trading precision for recall. We're trading the ability to make guesses in probability order for the ability to make guesses massively parallelized. Now, I'm only in the very starting stages of this. I've forked Hashcat. I've been basically breaking it left and right. It's going to be a long time before I actually get this working, but this is definitely something that I think is going to be coming down the road here. If not by me, then by somebody else who can actually program well. So just kind of as my closing thoughts, just to show you kind of the differences in grammars. From last year here, I ran my previous grammar. I trained it on RockU, and I was targeting it on phpbb.com. This is Johnny Ripper's incremental mode, which is kind of a Markov-based attack. This is a previous probabilistic context-free grammar, and here's the currently one that we have released here. So, it's getting a little bit better here. It's only 1 million guesses. But still, for 1 million guesses, all of a sudden, we're cracking, 35% of the passwords in this data set that's completely different from the data set that we trained upon here. So when we talk about things like salted hashes or, really where it really helps to crack a lot of them really quickly, because that way it reduces your workload for making future guesses. This is something that's kind of nice just to run really first off before you start moving into your more traditional attacks. Now, when we expand this out to, let's say, 50 million guesses, you notice it really kind of hits this plateau. And as I said, that's kind of because of the limits of the dictionary itself, where the words just aren't really matching up with, say, the uncracked passwords that we're seeing here. So I'm hoping once I integrate Markov modes that we can start getting this to look more like a Zipf law type of a distribution. Because right now it's just kind of hitting kind of a wall. But that being said, when you look at the difference in the probability, or in difference in how long it takes for the previous method to catch up to it, right here, it's about 1/40th the time in order to crack the same number of passwords. So this is where I'm really big about making the grammar itself be more precise. Because even though it's not as fast or you're not getting those speed bonuses, you're reducing the cracking session time you have to run because you just have to make less guesses. So that's about it. If you have any questions, feel free to contact me on Twitter. I have a tendency to use like IRC. I really apologize. I'll just post 20 things. Or if you have questions, feel free to ask them now.
Questions? Okay. Just a couple of quick points. I don't think that your context-sensitive non-terminal is a cheat, or that it should be called context-sensitive.
Oh, if someone's saying I'm not cheating, I'm happy with that.
Yeah. I also think that when you're talking about Zipf's law with password distribution, I assume you're talking about David Malone's research.
Yep.
If my understanding of that, and also my look at the Adobe stuff, is that what he was saying is that this stuff superficially looks like Zipf's law, but when you do a proper statistical analysis, it isn't.
It has a tendency to break down at the tail there, but when you look at the front portion of it, it actually does follow it pretty well. So,
Matt, I've been using your tool for about 8 years now, so it's pretty great. Years and years and years back, there was really no memory limit. And so the limit on time was how much memory you had because it didn't really free up memory. So you're running in sort of somewhat reasonable constant memory now, or is memory still or space still a problem?
memory is still a problem. So in the previous version, I'd kind of capped it out where it would basically free up that memory. And one thing that I'm really kind of struggling with now with the generic context-free grammar is it's hard to make use of those optimizations. What I'm doing in order to try to free up that memory is I'm just kind of dropping some very low probability transitions on the floor, so that when you're running this, it'll run in a constant memory space, but it'll eventually terminate much faster than what the grammar would do. So you're not going to be able to run across the entire grammar.
So you can't run for infinite time or constant memory?
Yeah, you can't run at infinite time with constant memory. Now, if you want to do it not in probability order, where you do something like a beam search or something like that, you can start going back through that the data set and run it in constant memory, though. But you're not going to have it in probability order.
Last one.
So I asked a variation on this question during the Wordsmith talk at 10 a.m. That is, when you generate a grammar and generate the probability table for each individual word, have there been attempts to expose that publicly, which is to say, given n+1 password leaks, can I check to see what the probability is for password I love you 123, etc.?
So are you saying that, have I tested to see whether, when I run it against another data set, whether those probabilities match up with the probabilities I saw on previous data sets?
Yes, but also if that data is public in any capacity, because I've been looking for that. So
the short answer is no, as far as it being public, because people haven't been posting their grammars, and I'm included in that. So I mean, but the fact that we're kind of breaking this up into all these different, here's the probability of these words, and you can compare that against different data sets. It makes it much easier to do. The one thing to be a little wary about is if you do post your grammars, it leaks an absolute ton of data about your training set, kind of by design. So you have to be a little bit careful because let's say you train it on some corporate passwords and then you post it online. Someone can really use that to figure out a whole lot about what your users are doing. So you have to be a little bit careful about that.
Okay, so we got to stop there to move on to the next talk, but thank you again, Matt. And you will, I'm pretty sure you will stay around as well. So, if anybody else would like to talk to him, feel free to do that. And we just have a very quick change here and we start again in, 6 minutes. See you then. Okay. Then we are ready to start again. And I've told Flo and Scala here that, there's absolutely no pressure at all in this. And, I've told them I'm really looking forward to this talk. And they are going to talk about passphrase wordless generation. And I'm very happy to tell them once again that the author of Diceware is in the audience. So, please welcome Flo and Scala from Perio.
Sure. So, welcome to Passphrases for Humans. My name is Flo, Florencia Jara-Vega. I'm the CTO at Perio, and we are a tiny startup that you may or may not have heard of. So my own background is I'm a developer. I'm not a security researcher. So I'm tackling this problem of passphrases from a sort of developer perspective, and a developer who's very interested in user advocacy and user education.
My name's Skylar Nagao. I'm product manager at Perio, but mostly kind of a humanities geek, and that'll hopefully shine through a little bit in some of the work we're doing here.
It's just a switch.
Where?
Yeah,
there we go.
got it.
Does that work now? Oh yeah, it does. Whoa. So to give you a little brief overview, the beginning will be some basics. We're gonna introduce Perio, passphrases, and some of the standards that we arrived at, move towards the problem with some maybe the existing Diceware dictionaries, discuss then what we consider a more cultural approach to how we can develop these word lists, and then move to the future and some ideas that we're already working on, some ideas that are out there, review some current research, and then we'd also love to hear from the audience if there's time about their experiences or ideas here. For anyone who's not familiar, we just wanted to have a couple of definitions just so we're all on the same page. We're going to use some pretty broad ones here. Passphrase is really just like a password, but it's just usually longer and composed of words. There are different ways you can do this, but we gave 2 examples on the board in some basic ways. And entropy is just a lack of predictability. To have more entropy is to have less predictability. So if you were to guess one number on these dice, the 20-sided dice would be harder to guess correctly.
So for some background of what the app is for context, so we do easy-to-use message and file sharing with an emphasis on Teams. So it's cloud-based, and everything is end-to-end encrypted. And users need to be able to log in from any device on any platform with a passphrase. So we derive the user's private key from the passphrase using Blake2S and script. And basically, so what that means is we don't ever get the private keys. So if the user loses the passphrase, they're screwed. So the passphrases are a very important component of actually being able to use the software at all. So when we say that we want this to be easy to use, we want users to be allowed to not think very much. So that should also mean that the software should be very hard to screw up. So for example, that's one of the reasons we're doing end-to-end encryption by default, so that you can't accidentally reply to something and send it in plain text. There's actually no way to send stuff unencrypted. So there's some stuff, though, where there is user input required, such as choosing a passphrase. And so that's where things get really dicey in terms of enforcing some sort of sane default. So minimum password strength is a big question mark for us. So for the sake of our research and our development style, there's a couple of assumptions that we're making, and we get that these are controversial in some ways, but this is just kind of what we're rolling with. So the first thing is that people cannot and will not remember more than a few passwords. So for example, I know that I have several hundred passwords. There's no way I can memorize several hundred passwords. We also think that password managers are great for most people in most use cases, precisely because you have a million services and you have to be able to access them and have good passwords for them. And we also think that critical services should have strong passwords. So that includes, let's say that maybe you have a password manager like 1Password, and you have a great passphrase for that, and maybe you also have a great passphrase that you memorized for your Gmail and your Facebook, which you might need to access from someone else's computer from time to time if your phone is dead or whatever. So based on these assumptions, when we're deciding on defaults, we have a bit of a trade-off to make. So there's things that are there's some stuff that's more secure, but maybe it's less convenient, and we need to constantly straddle the line. And so that's basically what we do every single day, is say, okay, well, this thing is the more secure thing, but it's also less convenient, and then we have to kind of extrapolate from there and sort of imagine what kind of scenarios most users will be encountering and pick some sort of sane default from there, and then also figure out what kind of configurations we want to allow users to define on their own. So in terms of modeling threats, it's a bit of an exercise in fantasy, but it's also fun. So at what point does trying to crack a password become unreasonable for an attacker? So that depends on who the attacker is and how much time and money they have. So does your attacker have $5, $1,000, maybe $1 million? It turns out that in certain situations, you do get someone who has $1 million to crack something, so like the FBI, for example. And if you look at, like the biggest budgets that you can possibly find, that's kind of what you're looking at. And then there's this wonderful paper from Joseph Bonneau and Stuart Schechter that kind of takes a look at gigantic hashing operations and how much they cost, and sort of extrapolates from there that something like performing 2 to the power of 80 hashes in a year would cost around $1 billion for a centralized actor, sort of based on what you see in Bitcoin, which isn't a centralized actor, but is in fact distributed and not optimized in various ways. So that's like really, really high end. And so we decided we'll take a high end standard, and so we call it the $1 billion standard. So $1 billion and a full year is probably more money and time than like anyone is willing to spend on cracking a password. So if we go up beyond that standard, we start having really, really high entropy requirements, which is going to mean like really crazy, crazy passwords or passphrases, which really affects usability. And also, like, realistically, we all know that if someone's out to get you, that cracking a password is not where they're going to spend all their time and money, because there's going to be way easier things that they can do, even if you do have billions of dollars at your disposal. So therefore, we arrive at this entropy requirement, which is based on the way that we generate our keys. We're using private key stretching, with scrypt, and so we actually end up needing, in order to get 81-bit passwords, which are our $1 billion passwords, we actually need a passphrase with 67.5 bits of entropy, and then we stretch that with scrypt. With basically the most amount of scrypt that we can manage, that on a slow phone's processor, it doesn't take like ages to actually sign into your account. So from there, I'll let Skylar take over.
So it may not mean much to everyone, I guess, but to start, so our goal is to hit 67.5 bits from our users. And the problem, right, is that most people are really terrible at making passwords. Like, I don't need to iterate too much on this. 2 little stats. One study found 30% of users were using one of the most 10,000 common passwords. Ashley Madison, you would think would be a very, maybe more privacy-minded service. Yet it turned out hundreds of thousands of people were using passwords like those that you see on the board, like 1, 2, 3, 4, 5, 6. A data dump from Gmail in 2014 revealed that the average password strength was roughly like 21.6 bits. So this is quite far off from our requirements. And unfortunately, it's not just like some Joe Schmo whatever who's creating these passwords. Like in that same dump were passwords from the companies you see on the board. We have journalists from major news networks, a division chief at the Department of State, a PayPal senior engineer. And it's like, oh, no surprise that like the GitHub developer has a 96-bit password, but all these other people who, all of us are probably trusting with our data, may not be doing as well here. So, we have this question like, well, how do we ensure our users are meeting this standard? And I mean, one thing would be to use things like password meters. This is one of my favorites, the passive-aggressive password meter, where as you're entering characters, it'll tell you just how bad your password actually is. Before we continue, we were given some little treats / booze before starting and told that we can give them out for however we please, really. So since we're going to be discussing this, does anyone know how to pronounce this? And I refuse to accept anyone who just tells me each individual letter.
So whoever pronounces this for us gets this.
I would pronounce it Dropbox.
Yeah. We can run with that.
Sure. Yeah, sure.
I've been calling it Zixbin this whole time. We can call it the Dropbox method though. So, one problem with these like entropy estimates is like, the traditional method is like, well, okay, how many different characters are there? And then multiply that by how many characters are in the password. And then you might see numbers like this, and it's like, oh, cool, like I can have like leet password, and I'm like almost at this requirement, right? Well, this Dropbox method is like, actually, nah, that doesn't really fly. Because, it accounts for some human elements, like people's tendency to use these common keyboard patterns, or people's tendency to just try to work around password rules in the laziest ways possible. Like, apparently 1 out of 4 people will basically just add 1 to the end of their password.
Yes.
Some people are either really creative, really lazy, or really egoistic and just use their name for both username and password. I don't know if y'all can see this because it's kind of small, but here's like a breakdown of what Zixbin Dropbox method looks like, where for fun we entered a password that would pass most standards. It is baseball 1 2 3 written in leet, so with mixed case, numbers, and such. And you can see that it actually detects like, oh, you know what, you use the word baseball, which happens to, for some reason in America, be the 9th most common word appearing in passwords. It recognized the letter substitutions and these common sequences. So although this would pass many standards, it turns out to be something that would be cracked instantly.
So our first solution was kind of like a classic lazy developer solution, which was like, oh, okay, so there's this tool that we can just import, and we realized that maybe this is not quite good enough, like the estimates that it's giving are maybe a little off. So okay, let's just require 100-bit passphrases, and then we'll like write all this intro text about how to choose a good passphrase, and we'll give a strength meter, and that's totally a great solution, and users will totally do the right thing, and it'll be great. And then, of course, it wasn't. So basically, the feedback that we started getting was like people hated it, and like we just got so many support requests of people complaining that like they were entering 50-character long passwords, and they were basically writing whole novels into the passphrase field, and they were still not hitting the entropy requirements. And it was. And we were seeing also a lot of lost passphrases and people emailing support being like, I'm locked out of my account, and us being like, we can't help you, sorry. So that was pretty bad.
And I mean, what we found is that people are basically bad at making passphrases for many of the same reasons as passwords. I mean, on one side, they're just not used to it, and so these rules like were confusing and had some overhead. But the other thing is that they're still predictable. Like when we get a request that verbatim said, well, I've entered 50 characters and I'm not passing this. And we're like, well, I mean, we have this tool, and it's like, yeah, if you enter password, it might be 50 characters, but it's not going to fly. The other problem we had is that some people succeeded, and then we were talking to our users to get some feedback. And one of the things that constantly came up was like, oh yeah, I just use this quote from like my favorite book or my favorite band, which also happens to be listed as one of my likes on Facebook or Tumblr or whatever other platform that's really easy for people to find. And in these cases, you can see that these Drake and Bon Jovi quotes actually passed this 100-bit standard. Another problem is that language is pretty predictable. Like, we like to think we are able to create random statements or sentences, but as is the case, language follows patterns, and machines are really good at identifying this. This is some data from Google's Ngram charts, and basically what it's saying is that if you enter the word you, what words are most likely to follow? Because it's not going to be every word in the English dictionary. It's going to be you can, you are. And that can actually go to multiple levels, like you cannot, you can get, you can see. And you can see how this really quickly narrows down the possible options that a machine needs to run through. Another issue is that when you let users pick their own passwords, their memory is fallible. Like, I would say close to half, if not more, of our forgotten passphrase support tickets were resolved by, did you capitalize the first letter? Did you add a period at the end? And that resolved many, 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 many. The other fun part with this user-chosen system with meters was how meters themselves work. And in this case, it's like, cool, you did it. Like, okay, cool, this is my super sweet password. I'm going to put in this last letter. Too bad. Like, password isn't appreciated by Zixbin or Dropbox.
So it's just like really frustrating experience to be typing and being like, yeah, and then never mind.
So, we're still sort of at the same question of like how can we actually ensure that users meet this standard. And in this case, passive aggressive password meter had some great advice. Maybe if you just mash your head onto the keyboard, it would be more secure, which could also mean maybe if you just had a way to randomly generate content, then users wouldn't have to think about the passwords they create, and we could get reliable standards for estimating password entropy. And the best part of all of this is that academics have actually studied this already and found that it doesn't matter if users pick their own passwords or they're given to them. They are just as likely to remember or forget them either way. So it's like, well, okay, if it doesn't make a difference, why not let it be random? So then we get into, I guess, some of the problems with passphrases. I assume most people in this talk are familiar with this comic. And this comic is 5 years old now. And this is what basically got me interested in passphrases in the first place. I didn't know what they were like a year and a half ago. And I saw this and I was like, oh wow, this is awesome. This is a really easy solution to avoid things like this that I get asked all the time. This is a particularly bad list. And this is a real list of password requirements. If you can't see, it says you need exactly 8 characters. You need at least 1 letter, 1 number, and 1 special character. But those special characters can only be at, hashtag, or $. It can't be in the first or last. It has to be like a different one than you use over the past 5 times. It's huge and terrible.
It requires a simile, a metaphor, and the name of one of your children.
And I mean, it could be, no, it doesn't. And I mean, it could be that passphrases are also a fair bit longer, right? Like on the left is a randomly generated password, and on the right is a passphrase, and you can see the passphrase has almost twice as many characters. On the other hand, the passphrase only has 5 chunks of data that you need to remember. With the 13-character password, I have to remember 13 characters. With the passphrase, I remember 5 words. Another issue is that passphrases need to be localized. You can't just give an English passphrase to a French speaker and expect them to remember these 5 English words. And that means you also need different dictionaries for every single language. And it also means each language presents its own problems. Like, for example, German is probably going to have longer passphrases than French or English. Also, against passphrases, there's some evidence that passphrases aren't more usable than passwords. One study found that 5-character passwords were significantly easier to remember and faster to type than equivalent strength 3 to 4 word passphrases after using them for a few days. However, the same study found that 6-character passwords were significantly harder, more annoying, and less fun to learn than the 5-character passwords. That, good for us, using larger dictionaries for passphrases didn't seem to affect memorability at all. And that, importantly, and a word you rarely hear with passwords and passphrases, is that people found passphrases more fun to learn. On the other hand, when we started looking at what happens when you use stronger requirements for passwords and passphrases, turns out that a 6-word passphrase is significantly more likely to be memorized faster and more reliably than a 12-character password when using a service over a couple weeks.
So, okay. So could it be that the problem with passphrases is actually just the words? So our question was, what actually makes a good passphrase dictionary? And that's something that we hadn't seen a lot of research on. So what we looked at was, the most famous word list is the Diceware list. And so the idea there was almost 8,000 words, short words. And they're supposed to be common, but arguably words like Zloty, Wuhan, and NCAA, and Boise, as in Boise, Idaho? Yeah. Are not actually particularly common and also are very culturally specific. And also there's a bunch of kind of gibberish that is included in there. So, and one of the things that for us was just didn't quite go with our philosophy was the suggestion that, if you don't know a word, you should look it up. And for us, we want to reduce friction as much as possible for the user. So we don't want people to need to go to some external site to look something up in order to be able to find it memorable. So that's something that didn't work for us. So a different example is SecureDrop, which uses a sort of trimmed down version of the Diceware list. And it removed a bunch of stuff from it, like Americanisms and symbols and gibberish. But it still has some pretty difficult words. There's also the PGP word list, which is very short. And it also has very long and kind of hard to spell words. It's actually meant for being spoken, so that factors in there. There's also, so Perio was originally based on Minilock, and Minilock came with a list of words, which was extremely long. And we don't actually know what the source from that is, but it includes some pretty long and obscure words. For example, does anyone, we have some more booze for anyone who can spell the word psoriasis?
Without looking at your phone right now. Yeah.
I think yes.
Yes.
Easy one.
Congratulations. Okay, what is an
Peach snobs or apple pie?
epicycloid?
In an orbit, it's a portion of an epicycle which was used in the Copernican system for describing, the motion of the planets.
Excellent. Congratulations, we are all a bit...
We have an educated audience.
Yes, we are all a bit smarter today. So we also have up to the minute, which is
minute.
So this is fun. We also have, there's also this study, Correct Horse Battery Staple, which uses another word list, which is from the Corpus of Contemporary American English. And that's a much shorter word, but a much shorter list. But it does use really long words, and it did actually find that character length was character length in a general passphrase or password was actually a huge factor in usability. So the study found that 5-character passwords were more memorable than 3 to 4 4-word passphrases, but length seems to have featured in that. So that's something that we took note of. There's also this other study that we love towards reliable storage of 56-bit secrets in human memory, which uses a much shorter list as well, and it actually does do a lot of trimming. So it's chosen from Google's Ngram corpus, and it eliminates words that are close to each other, so easy to confuse, and also removes prefixes so that autocomplete can work better, and excludes vulgar words, plural words, and slang. So it's got a little bit of the sort of cultural element of trying to figure out what are good words for a human. So that's pretty great. But one of the things that we had a lot of questions about is what words are people actually likely to know? And if they know them, then we might extrapolate from there that those are the words that people are likely to remember. And another question that we ask is what words are easy to type? The other question for us, given our entropy requirements, is how many words do we want to use? So these lists have a huge range, I mean from 200 and something to 56,000. So, and a larger list means, of course, that we get more entropy per word, but it also means more characters per word on average, and it also means that we get weirder words like epicycloid and whatnot. So we think that the problem in all of these lists is that this is actually a UX problem, and so a lot of these lists have been designed by developers and security professionals, and they haven't been formulated from a sort of more usability kind of side. And so that's a problem that we found really interesting. And that is how we got to a cultural approach to passphrases.
Which we're also dubbing how Seinfeld and Game of Thrones makes passphrases better. So like a quick review, some of the technical approaches is like, well, use shorter words, use words based on patterns, use phonetically distinct words or semantically distinct words, make it friendly for autocomplete and autocorrect. But some of the questions we were interested in is like, well, what words do people know? What words do they know how to spell? What languages do people speak? What education level can we expect from people? What words might offend people? And like one simple thing is like, well, what do users actually think of this? Like, are these words working for them or not? You know, talk to your end user. So, on the first question, it's like, well, what words do we pick? And we could pick the most common words that appear in corpuses like from Coca, Google Ngrams, Wiktionary. And these are cool because they help us identify the most frequently used words in English. But we're wondering if we should include all these words. These lists include, for example, the Harvard Law Review, which has a Fleisch grade reading level index saying that you should have been in school for about, I think, 33 years to understand most of the content in there. In contrast, Dr. Seuss has a grade index of 1, i.e. you can have almost no education and be able to read some Dr. Seuss books. So basically what we think is that, well, what if we sourced the most commonly used words from the most accessible sources, Because we know language has some social biases of like who gets published and where and in which mediums. And the mediums themselves have different words. Like the most common words appearing in printed media is not the same as what appears online, is not the same as television and film. And so, when trying to source words to protect the kingdom, we used popular film and television. For most languages, corpuses from OpenSubtitles.org. And we did this on one side because, popular video is accessible and well-known, tends to get translated on its own anyway.
Or also, if you're looking at other languages, there's also local media that gets closed captioned, and all of that also ends up on OpenSubtitles.org.
Yeah, OpenSubtitles.org actually as a source is fantastic because in many cases it's also local translators too, and so people from that language will actually be the ones, recreating their phrases in a more culturally relevant way. But importantly, subtitles were actually studied and found to have that the word frequency data from subtitles is more accurate. This is a more accurate indicator of reading performance in a culture and word recognition. That when studying French, American English speaking, Dutch, Chinese, and Greek youth, they actually found that the way kids were learning was most accurately measured by the words they knew in subtitles and not by corpuses from written text. So if we take that as our source, we still have the question of how many words? Do we keep it small? Do we keep it huge? Do we take the common wisdom, or do we just ask the question, well, how many words is someone actually likely to know? For this, we used a website called testyourvocab.com. It's basically been a long-term research project that I think has been on for 10 years, where they just ask people to take this quiz online and it'll measure their vocab. And we wanted to try and take one of the lower percentiles because we wanted to be as accessible as possible, which for an 18-year-old, so high school graduate possibly, in the lower 20th percentile, it was measured that they would know about 15,800 words. So we just started with this as our guide. So our process was basically find a large corpus of subtitles for the language you're working on, compare that against a native language dictionary to try and get rid of slang, sound cues, or potential typos from the subtitles. Organize the remaining list by word frequency. Isolate the 20 to 35,000 most common words, depending on the language and how large the corpus was. Remove offensive words from the list, and then start trimming it down by removing the longest words until the list is about 12,000 words long. And the result is that we have 12,000 word lists of the shortest and most common words in a language with a cultural basis for assuming that people actually know what these words are. It also means we end up with a larger dictionary with more entropy per word. You can see that compared to say a word list with only 1,000 words, you would need 5 words instead of 7 words in your passphrase for a similar strength. It also tends to mean that when you have less words and they might be a little longer, that it may not actually result in that much longer of a passphrase than just having more shorter words, which has been some of the conventional wisdom for now. So we threw this up here. This is from one of the newest EFF short word lists coming up that has an average of 4.5 characters per word and requires about 6 words to have similar strength to a 5-word perio passphrase. And on average, they're very similar in length. And just so you guys can get an idea of what this looks like, we thought it'd be fun to generate the first few diceware and perio passphrases to see what they might look like. And in general, the diceware ones are shorter. But we find the perio ones to be a little more accessible or relatable. I'm personally a big fan of the first one that came up, the reindeer ruling insanity rejoin reality. I recognize most of these words compared to things like 52 UW, Hera, NCAA did make an appearance here for any basketball fans, and Idaho, not Boise though. So this is just a visual comparison.
So we haven't, I'll talk a little bit about what's coming in the future in a bit, but we had a chance to get our word list into a study done at the University of Bonn. I don't think it's been published yet, it should be out pretty soon. So it's a researcher called Sergei Deschamps and some of his colleagues. And they were actually doing a study on public key comparison and recognition. And so they threw our word list in in addition to hexadecimal, base 32, purely numeric, and the PGP word list. So this is a bit, it's not quite what we're doing. I mean, it's a public key test, not a memorization test for passphrases, but it's still fairly interesting because what we saw from that study is that it was the fastest verification method among the ones that they tried. It was second best in terms of error detection. So the best in terms of error detection was generated sentence-like structures. The second best, it was also the second best in avoiding false positives. Interestingly, the best in avoiding false positive was numeric. And users definitely preferred it over non-language options. So that's actually a pretty good mix, given that it performed second to different things in different categories. So, of course, that's not the same as seeing how memorizable it is, but hopefully that's coming up. But still, it was a pretty cool opportunity to get our work into some academic papers, and we are looking forward to doing more of that. So, from what we have right now, we do know that there are some pain points, and so there are some things that we want to take a closer look at, and we'd love to talk to participants about. So one of the things that we will ask ourselves is, do subtitles from Friends and Grey's Anatomy belong in, various other dictionaries? We do definitely counterbalance because we check the words generated by the subtitles against the dictionary in the language that we're using. But there's still, you can really see the influence of like British colonization and American culture. Yes?
Being Norwegian, I can tell you right now that the phrase, how you doing, is something that anyone in Norway who has seen Friends, they are using that phrase. But if you did it in Norwegian, nobody would have any clue what you're talking about at all.
Good to know. So there's some tricky things there, though. So something might be more recognizable in one language and not translate very well. So there's some trickiness around there. We do see that a lot of names, even English names, end up in the corpuses of every single language. And that's a bit of a question mark for us. So for example, we ask ourselves if we should strip those names out. And should we strip proper nouns because they're not a good point of reference for a lot of people. But then on the other hand, I think this is a particularly cool passphrase, Elizabeth crowned in human glamour typhoon. And sometimes if you have a name in there, that's actually, I feel like that might have some points for memorability, especially if you know someone by that name. And I mean, some of this might be nitpicking, but we're trying to make something that makes people have a very fluid and pleasant experience. And so little cultural things are important to take into consideration. Yes?
Some names will,
all right. I didn't mean for it to take so long. Some names will translate differently. For example, pears would be in English per se.
Yeah.
It's pronounced differently and it means something different. My name also. I don't know how you factor that in.
Yeah, totally. It's super tricky.
Subtitles are interesting for that because subtitles isn't the same corpus depending on the language. Like the media we showed is all Anglo media, but when you look at the subtitles.org, you'll see tons of material from like local news or documentaries or material that may have never been in English either.
Lots of anime.
So it actually will frequently represent the local culture. You'll see more of the local city names, of the names of people in that language or place. That can have its own problems, like when you get to the point of comparing like Brazilian Portuguese versus Portuguese. But things like we said, pain points still.
So other stuff that we haven't quite dealt with is words that are hard to spell. Occasionally we manually see something that's like, oh my God, this might be a common word, but people spell it wrong all the time. Like how many people spell definitely wrong? Lots of people spell definitely wrong. So it's the kind of thing that we might want to like just remove that word because we know sort of anecdotally that it's a tricky word to spell. The other thing is words with short edit distances, homophones. That's something that we don't have a systematic way of dealing with, particularly not across languages. We do, so we're a pretty multilingual team. We're based out of Montreal, and so everything is always in English and French. And my native language is Spanish, and we've got some Russian speakers on the team and a Turkish speaker, and we've got a bit of a range, but still we're branching out a lot into languages where we don't have someone who can notice the obvious flags. And one of the flags that we do have so far is actually grammar, which is, and there's some stuff that in English isn't as obvious, but once you get into most other languages, things like this where you might have, so in the first Spanish example, there's a noun that is masculine and plural, followed by an adjective that is feminine and singular. So that actually causes a lot of cognitive dissonance. And I mean, we don't have any study to base this on, but it's fairly jarring to see. And probably that affects at least the user experience, if not the memorizability, because you would probably tend to make them agree when you're typing it out. So that's, and the same thing happens in French. That's an example where the adjective is feminine and singular, and the noun after it is plural. So that's something that we might want to look at, like just taking roots of words and making them agree. And then that actually can also help a lot in terms of edit distance. So if anyone here speaks French, French has this thing where there's a lot of forms that are spelled differently, but they're pronounced the same. And even native speakers actually confuse them a ton. So if we could actually just unify that and make sure that we're only using one form of a verb that sounds a particular way, that would probably go a long way to fixing people messing that up. So and then when we look at grammar, I mean, each language has particular things that we could probably do, and it's a gigantic rabbit hole to go down. But that's something that we're super interested in. So if there are any linguists in the room, we'd absolutely love to talk to you. Yeah, there's some other cool stuff. It's recent.
So this actually came out like a moment of panic when, like 2 weeks before we were supposed to give this talk, Joe Bonneau released a new Diceware word list that is phenomenal. We're really interested in playing around with this soon, but basically they removed a lot of the weird words from Diceware. They did something similar. They sourced familiar words through Ghent University's Center for Reading Research, removed difficult to spell words and homophones, removed vulgar and offensive words, and even did, I think this is fantastic, is identified the concreteness of words. And what they mean by that is, for example, picture a screwdriver. It's not hard. You see the handle, the little metal bit, the maybe star shape or whatever. Now picture love. It's a lot easier in the XKCD style to picture concrete objects. If you were told to sit down, here's 5 words that you can picture. Now try to picture them like that comic with a little horse and a battery and a staple all together. It's a lot easier than trying to picture what love looks like. So Bonneau actually made 3 lists. One is the initial Diceware length. One is a reduced one that only requires 4 dice instead to hopefully speed up the process of creation and includes the most common words. And then another one that's actually designed to be tuned to autocorrect and autocomplete, which could be pretty fantastic on mobile in the sense that you would only need to ever type 3 characters to get your word automatically filled in each time. So for like a visual comparison, we put them up to see how these our word lists and the short and long ones might compare. One thing to note on the short one is that if autocomplete and autocorrect turned out to work well, people weren't over-typing every time when they were trying to enter the words. That would only actually be 3 characters per word.
On the other hand, I feel like password fields don't usually allow autocomplete, so that's a kind of another set of challenges.
There's definitely some implementation challenges for autocorrect and autocomplete here. The other thing, which made rounds in like popular, tech blogs and things like that for a bit, was research on passphrase poems. And someone, this was, oh my God, I'm embarrassed to say this name, Gaz, Vinijad, and Knight, in their essay, How to Memorize a Random 60-Bit String, tried comparing sentence formulations, the XKCD method, and then poems, because they were like, the ancient Greeks are able to like memorize a 1,000-page epic poem. Maybe we could do this to memorize a few passwords. And what they found was impressive. So these were the recall rates for their different methods and the user preference. And the poetry method like vastly outperformed the 2 sentence methods and even the XKCD method. And importantly, like people really liked the poetry method versus the XKCD one. Users, again, when we set minimum standards, you'll notice that users actually preferred the ones that they got wrong. So it's one of those things where maybe the user doesn't always know best.
Yeah, it's probably one of those things where they insert the correct grammatical forms rather than the incorrect ones. There's 2 questions, maybe over there first.
Participants in recalls, are those in like thousands or people?
No, this is people. This is a pretty small, like hands-on. This is like a...
Significantly insignificant.
They're yeah.
It's a small study for sure.
The other question would be, with the user preference, was that controlled for? In other words, were those users possibly thinking they preferred those because they would be more secure as opposed to the other ones?
I think they were measuring frustration, but I don't remember exactly.
I'd be interested to know what control was used for that, just to make sure that it wasn't based off of the user assumption that they were looking for a secure password as opposed to.
Yeah.
Let's try and do, questions at the end.
So yeah, no, but we can also give you that study if you want to see it. I'm sure we have it.
Oh, actually, it's also cited at the
it's
bottom.
It's cited, yeah. So some of the future work that we have in our development pipeline is some little things that we can tweak in terms of the user interface and user experience in general. So we want to kind of provide some sort of incentive for people to do spaced repetition. So I don't know if anyone has used Authy. Authy prompts you to enter your passphrase every once in a while to make sure you didn't forget it. But that's honestly a little bit infuriating. So we figure we can maybe add some spice to it by, at minimum, showing like a cute animation when you do it, and maybe offering some rewards, like more storage space on our platform. We can also do some stuff around trimming, ignoring, and inserting white space, for example, so that if you get the spaces wrong, we correct for that. Then looking at the autocorrect and autocomplete stuff that Joseph Bonneau's been doing, that could be really interesting. So we might dip our toes into that. And then another question that we just mostly are confused by is how to deal with special characters, because you can we have a German dictionary, but if a German speaker has a German passphrase that has a bunch of umlauts and maybe an SZ in it, then like if they travel and they're accessing their account from someone else's computer that doesn't have these characters, then they might be a bit screwed. So there's a couple of different ways that we could deal with that we should take a look at. But that's definitely something that's in our future. The other thing is whether it makes sense to let users choose some things. So that can be like, usually we have just a button that says regenerate passphrase, and it just cycles through a bunch of options. But we could allow people to just regenerate individual words instead of the whole thing at once. So if you got something that you like, but the last word is something that you think you can't spell, then you can just re-roll that one. Or the other thing is allowing insertion of additional words in between the ones that were randomly generated. So for example, like an article or a preposition to make the sentence a bit more sensical to you. That could be a thing that could work. And also just allowing insertion or edits to make something plural, to add a suffix, whatever. That could be interesting as well. And we would still have the sort of guaranteed minimum amount of entropy from the 5 or more words that are generated by the system. So that could be cool. The next thing that's coming up as well is we're currently designing a field study with the folks at the University of Bonn. And so what they have a bunch of different ways of generating passphrases and some control encoding and whatnot. And so what we're going to do is we're working on a research edition of Pirio where users will be able to use their regular account, but they will kind of go through a wizard that tells them, okay, you are participating in a study. We're going to measure the following things, and you will be using your passphrase encoded in a different way using a different generator. So we're going to test for memorability, for speed of entry, for accuracy, and for user preference. So right now what we're going through is just kind of designing that study because it's fairly tricky to figure out how to control for certain things. And then in general, we're very interested in doing field studies and working with academic institutions, but...
I didn't want to interrupt. I was going to wait until you were ready to switch slides.
All right. I have switched slides.
Oh, okay. You said but. You were continuing with thought. Skylar, did you make an outrageous speaker request?
Did I?
Yeah, I think you did.
Did I ask for cats?
You asked for kittens.
Oh, yeah.
That's amazing. Sweet.
That is so going on Twitter.
That is like the best thing that has ever happened to me. And it wasn't even me, it was you.
This is why it never hurts to ask.
All right, I have learned another thing today, not just what an epicycloid is. So as I was saying, in terms of designing in designing studies, I mean, we are a secure communications tool, so it's very tricky, and we don't want to turn this into this kind of like horrible thing that people don't read, where you're like clicking through a bunch of like text. So there's a lot to be done in terms of designing transparent studies and having people actually understand what it is that they might be able to opt into. So that's a really tricky question. It's one that we'd also love to talk to folks about. And on that note, there's a lot of ways that we would love for you guys to help out. So we would love to have native speakers review our dictionaries. So I had it really helps. For example, I happened to luckily speak German, but I hadn't caught this until we were preparing for this talk, that actually when we were generating our German list, we left out nouns entirely because they're capitalized. Yeah, and our script just didn't account for that. And and luckily I was like regenerating in German and was like, there are no nouns. What the hell? And then it occurred to me why, and so I need to go regenerate that. So the other thing is like use our dictionaries. They're freely available, and just use our passphrases if you want. We have a standalone passphrase generator, passphrases.perio.com, where you can just roll in any of the languages. You can also come to us with any research that we've missed or any research that you want to do, and we would love to collaborate with more folks from the research community, and we'd love to work on field tests specifically. If folks are interested in that. So you can contact us through Twitter, and you can check out the Passphrases site. You can check out the app as well, and you can check out our code on GitHub. The app is itself open source. So I think that's all we have for you.
When we say research, I really want to stress that we don't just mean security researchers. If you're into like UX, usability, design, like we feel like this is a really crucial and often underappreciated and underutilized skill set within the security community. So even if it's like what colors you think the passphrases should be when they're presented to users to help memorability, like we want to talk about that.
Yeah, absolutely. All right, thank you.
Yeah. They come out.
So before I open for questions, I'm just going to say that, Skylar, you told me, and you revealed it yourself, you didn't know what passphrases was like 1.5 years ago.
That's true.
And Flo, you say you're not an information security researcher, you consider yourself to be just a developer.
I'm a developer for sure, yeah.
I am absolutely amazed about this talk. So I will actually, one more round of applause first. This is really good. And now for questions. Raise your hands. Oh, Jeff wants to ask a question. Well, I'm actually going to bypass Jeff first.
Too much enthusiasm.
Actually start.
There you go. It's a pretty maybe obvious question. Have you considered, and since you even named them sentences, have you considered making the phrases that are longer than a couple of words, maybe more syntactically arranged, to improve memorability?
So that was actually one of our first thoughts. In that last study we briefly went over, the poetry one, actually found that they tended to not work. And the problem with it was that on one side they got longer. When to get randomly generated sentences, that also aren't easy to look up in a dictionary type attack or butt of quotes. You end up with fairly long sentences, and users were really good at remembering like the semantic meaning of the sentence, but they weren't. In fact, we might actually still have it open. But they weren't very good at remembering the specifics. It would be like this is reversed. So we do have it here. So they would remember things like, those are some more examples of poems. But these are sentences, right? So it would be like, they'd be assigned no dressing allowed under canon law in the youth group, but the person would remember no dresses allowed. And that this is actually what was the biggest failure for the recall rate for these types of sentences, which is why we were a little more interested in the user introducing their, constructing their sentences, because then it actually arguably would add more entropy, right? Because then you can't just do a dictionary attack of like, well, we generated all these words, but did the user add an article to it? Did they change, a suffix?
Yeah. I meant a little bit of a less drastic sentence construction, but I can talk to you later. About
Yes, that's
the problem is so with our standard was 67.5 bits. These are only 60 bits.
I'm going to make sure that they will be at the party tonight, so we can discuss. Everybody gets to discuss with them.
All right.
So,
yep.
This is fantastic. You've been struggling and working out with the same problems that we've been thinking about with 1Password and trying to and master passwords. And by the way, I'm a PhD dropout in linguistics.
I actually have a bachelor's degree in linguistics, but I don't talk about that.
Hey, okay. So you know, so you had asked about linguistics. Anyway, I'll talk to you about what we've done about Unicode, and I had a whole bunch of different questions and points which have all gone out my head. So I'll just mention one. In the word list that I helped construct, we deliberately chose to avoid derivational and inflectional morphology, so that we didn't have a dressing problem with memorability. Oh, right. And the one other question is, where did you get your taboo words for non-English when you were excluding offensive words?
Mostly from actual people.
No, there are some existing word lists. This was like one of my more fun weeks at work, where I was like, my job is to find all the offensive words in all the languages possible and put them all in one giant nasty list of like 8,000 lines long. And
you should come to Norway, because the higher up north in Norway you go, the more common it is to actually use really seriously strong bad language as part of your everyday talking to anyone.
To the extent that you can't talk without it.
Yeah, pretty much. You know, like if you come up there, like from Oslo as an example, and you go far up north in Norway, they will just look at you and feel sorry for you, because you're not you're not capable of saying fuck like every second sentence as an example.
We did, one note, we did have something interesting when trying to source this list. So I don't know if anyone here is familiar with Violet Blue. All right, so her name shows up on a lot of offensive banned word lists. and someone who was trying to go through our list to evaluate it, like, got really angry at us. They're like, "What's so offensive about Violet Blue?" And we're like, "Oh, we'll take that off. There's nothing offensive to us." But yeah, there are.
You told her.
Oh yeah, she saw on Twitter. This was very public.
One other thing we did for the offensive master list is we actually took out words like nationalities or religions, because that's better than taking out negative adjectives, and we ended up with a lot of awkward passphrases with constructions like disgusting, name of country, and it's like, okay, well, this isn't very nice.
Yeah, we've been doing the same.
Yeah.
I don't ask very many questions, but because I'm a spelling dropout, you mentioned difficulties.
Mm-hmm.
What's wrong with leaving spelling difficulties in there? If you really can spell them, it pertains to you, versus forcing me to spell something like somebody else spells it. I don't know if I've described that correctly. You mentioned, you used the word difficulties. Somebody can't spell it? Possibly I can't spell it, but I probably can. But anyway, why can't you use your own spelling difficulties? I mean, why are you restricted to what you say you must use? Why couldn't a person actually use their own individual spelling difficulties, even in relation to the words? Have I made myself?
Yeah.
I mean,
Yeah. If you can misspell the thing correctly, why would you force me to have to remember something that I can't spell right anyway?
So this is where, towards the end, where we were saying it could be interesting to allow users to have some control. So if the user is able to write their whole passphrase, everything we said in the beginning, it will probably apply, because people are bad at making their passwords. But if we say, here's some random content and you can play around with it a bit, like, oh, you know what, I know I always spell definitely with this I instead, or something like that, then it could be possible that we could say, well, you're allowed to change 2 or 3 characters in any word, which if anything would...
Because at that point you can just replace all the words with password.
I got a master's degree, and I have to look up things in the dictionary all the time anyway. You're forcing me to speak your language, not the language that I want to speak. You're sharing.
Yeah. we are deliberately trying to set a fairly low bar, and I don't think that any of the words would. But yeah, but I see your point though in terms of spelling, like especially if you consider British versus American spelling, we don't want to force one spelling or another.
But you are.
But we are right now. Yes, we are definitely. But that's the kind of thing that we should consider allowing the user to modify that. Yeah. All right. Fair enough.
Yeah.
Sure. Yeah.
So related to the earlier point about Norway, have you considered the option of letting people choose to include vulgar words? Because maybe that's more memorable for them.
We've done that. We've also on the side for fun, I have a Simpsons dictionary. I have a Klingon dictionary. The Klingon one's tough because apparently there's a lot of internal disagreements about how things are spelled and formatted. But I was not ready for that.
That's another case where people should be able to pick their spelling.
There's been requests for Elvish dictionaries. There's there's a lot on the table for that.
I'm going to leave it to Arnold Reynolds to ask you the final question.
First of all, let me just reiterate that this is a really nice piece of work, and I'm very impressed. And if you guys generate a 776 word list, I'd be happy to link it from the Diceware page if you like that.
Awesome. Great.
And then not to be defensive, one little quibble is when you're comparing, I mean, a 5-word Diceware passphrase has 64.5 bits of entropy. So, yeah, it's a little less than your target, but comparing it to 6 is a little bit pushing it.
Yeah, that's definitely true. I think that was a mistake on ours because we were supposed to be comparing it with the 1296 dictionaries that just came out, which would be a 6-word to 5-word.
Anyway,
yeah, that was.
I want you to know that I spent hours working on this, but not weeks. So one of the challenge, and want to just be aware that you're going to have to redo this regularly because the culture changes. One of my Diceware words is A and P, and I don't know how many people in this room.
I actually looked that up 2 weeks ago because I was
I'm sure you do. But that they've been out of business, and I have some years that would be very familiar in the 1990s that are that would drop off the top of your tongue, and they're why do you have 1987 in there, right? I mean, so there is a upgrade process involved here. And the final thing I was going to suggest is one of the things I've been on my little to-do list that I may never get to is you really don't want to generate actual sentences because they can be weak passwords because they may actually turn up in a search list for that were generated from songs or whatever. And there, at least in English, there's a handful of words like the forms of the verb to be and a few pronouns that basically, and articles that if you remove them from your list, you eliminate 75% of possible sentences. So that's something you might also want to think about.
So 2 things. One, I should say, we were actually worried. We were like, crap. Are we being too critical of Diceware? Because we, again, I started with this a year and a half ago, and I basically read everything on the Diceware website to get to here. As far as content, one of the fun things about subtitles is that they actually get updated every year. New seasons of TV shows come out, and new shows come out entirely. So it does actually help as far as a source of language to stay somewhat relevant. In fact, I think you're even, you could, if you went through the effort, actually narrow it down. I only want to take subtitles from shows that have been released between these years. So there's some fun things you can play around with subtitles as a source.
You've done well, though. You've done well.
Thanks.
Yeah. Okay, so again, applause for Curio. Now there will be a 1-hour break until 5 o'clock, and then we have Nick Sullivan, who is the head of crypto at Cloudflare, coming to talk about Docker. So be back again in 1 hour. Thank you.
Because I will not remember your Twitter. Do either of you have a card?
Yes. One moment.
I'm out of cards. Yeah.
I may have potential places to test.
Or let me see. Actually, if I...
I'm not making myself a target by saying where I live.
I have these old cards, but I don't think they have my. I'm supposed to carry these around, but that is not our address or.
As long as there's
I think I can say that I am strongly encouraging women to participate at PasswordsCon to get into information security. I have been co-supervising a master student that did a talk here last year, and she also spoke at DEF CON with a room completely full. Did a great talk, and I really, really appreciate to see more women getting into this stuff. So if any women have anything to talk about related to passwords in any way, let me know, okay? Very easy. Okay, so this is Nick Sullivan. He's head of cryptography at Cloudflare, and last year at McCarran Airport, I was seriously freaking tired of Las Vegas. I was going home, and I was just walking there like a zombie, and suddenly there's this bearded guy coming up to me like, hey, you're Per Thorsen, right, running a password? Like, yeah, that's me, I want to go home. And it was Nick. And he said, yeah, you know, dude, I'm kind of working on something, and I might have something for you at a later point in time. And look, here he is. So Nick Sullivan, and pal is your pal. Go ahead.
All right, thank you. Thank you, everybody. Yes, raucous audience. Thanks for coming. It's 5 p.m. for this talk. And also, everyone online, thanks for watching. So I'm going to talk to you guys about a tool that we built at Cloudflare to help manage secrets, and specifically secrets relating to orchestrated containerized environments. And that sounds a little complex, but I'll get into it. It's very simple. So we have a problem, a very basic problem, which is we have a container that's running in a server that needs an API key, and our Docker container is built from source, and we don't want the API to be in source, the API key to be in source control. And the solution we came up with was, excuse me, basically encrypt the secret before putting it in the container and run a trusted agent on the host that's underneath the layer where the Docker container runs that has access to the decryption key for the secret. And when you run your Docker container, have a special entry point that talks to the host to get the secrets decrypted before it runs. And that's the essence of what PAL is. So if you need something that does that, this is your tool. So we're at PaswordsCon, right? So what does this have to do with passwords? Well, it doesn't directly have to do with passwords, but it sort of has to do with the broader concept of secrets and secret management. And typically, secrets used for authentication come in three major flavors. There are sort of sub-flavors and subtypes, but you have passwords, you have bearer tokens, which are strings or objects that represent an authentication, and you have private keys or secret keys. Now, passwords, as you probably heard 100 times over the last 2 days, these are stored by human memory. These are things that people are supposed to remember and manually enter into computers. And if you're sending them from a client to a server, it should be over an encrypted transport, or someone can copy it and replay it. By contrast, bearer tokens are high entropy strings. They're things that a human being is not going to remember. It's something that you store in your computer's memory. And typically you can get them in exchange for a human-oriented password authentication. And there's examples of this abound, right? Cookies are an example, API keys are an example, and these again need an encrypted transport. There's also an expectation of these that they have a certain lifetime, which may not be the case with passwords. The third type of authentication we can think of as private keys. So when these are kept on your client, they're oftentimes passphrase protected. So they are encrypted on disk and unlocked with a human memorable phrase that's a lot like a password. And when unlocked, you keep them in this sort of persistent memory on the system, and they allow you to do some really nice things, such as digitally sign requests, so that your authentication doesn't have to necessarily go over an encrypted transport. But this complicated nature of it's a key, sort of a random long string, makes it very difficult to be portable. Another example of this would be is two-factor authentication. So the codes that you generate from two-factor authentication, these are derived from a key that belongs to a secret key that belongs to the client. So passwords, as sort of human memorable things, they have these requirements of being strong, sort of unpredictable, and different per site. This is oftentimes very hard for human beings to handle because now this is from Dashlane's blog. People have on the order of 100 or so different logins. So remembering a different password for each one of these is a serious mental challenge. So for remembering passwords and for dealing with authentication, we've derived some of these tools that sort of enhance our capabilities to make us kind of superhuman password remembering folks, and password managers are one example. So they support things like syncing across devices, having a passphrase that kind of turns your password into the same security style as a private key would. So you have a passphrase to unlock it. And you can configure permissions as to which applications have access to these passwords at one time. And they have another feature called strong password generation, which some people use, some don't, but it allows you to turn a password into essentially what a bearer token is, like a long entropy-ridden string that makes it a lot harder to crack. But then it also makes it so that it's not something that it is human memorable. You still have to remember the passphrase to unlock the passwords. But this is one example of a tool people use. And when you're in an enterprise or an organization, there's oftentimes shared passwords. And these are sometimes passed around with sticky notes or email the administrator and these sort of things. Very, very bad practices. But another tool was built for this, and this is the set of enterprise password managers. And this is kind of like a centralized police officer with a case right there that has a list of policies that it says who is allowed to have access to these passwords. And in this example, someone wants access to the Visa account, and they bootstrap this based on regular authentication. So the user says, hey, I'm this person, here's my credentials, and the server will say, okay, well, here's a temporary use for this sort of shared password. So password managers and enterprise password managers are really human-centric. They're built with people in mind. They're built so that you have manual interaction. They're built so that individuals can manage secrets. And these tools are very useful and very helpful. So, but this is not what my talk is about. My talk is about the other side of the story, not clients as sort of computers or phones or something like this, or individuals, but it's more as servers. So servers need secrets too. And the way that people manage secrets, passwords, and these sort of credentials for servers are very different than the human-centric password-based mechanisms, because computers are not people, right? So servers need secrets. And just as an example, if you're building a web service or you have some sort of server up in the cloud that does some things for customers or for people, you may need API keys. You might want to talk to other servers doing so. You might need credentials to access dedicated databases, or you might want to be the terminating layer for HTTPS or TLS and keep the private keys. So these are things I don't recommend, but what some people do in this case is they have, well, the very first thing that you can do is if you manually manage your server, you can just log in and write the secret into the server. But if you're working at any sort of scale, this sort of manual work is automated by a configuration management system. And what people can do is put the secrets into the configuration management system. These are things like Ansible or Salt or Chef or these tools that make it simple to configure your servers. And then they take the secrets and they put them on disk or in environment variables, and then they just trust whatever applications are on the machine to access the right variables using system-level controls. So when you're talking about environment variables, you can define an environment variable ahead of running a command in Unix, and other services can find out what that is by looking to see what the command was to operate these functions. So you're really trusting a lot of system processes to keep these secrets isolated from one service to another. As I mentioned, system ACLs. So you can have services running under different accounts, and this is really hard to manage and easy to break. Privilege escalation is one of these bugs that we see all the time, and relying on this is potentially not the safest thing to do. If you're working with a bunch of developers, you may have a development environment and a production environment. And if you just keep your secrets in configuration management, then all your developers have access to it as well if they want to build a coherent development environment and be able to test these things. And that means that your configuration management is in a source control that's accessible by non-operators. And that extends your trust to everybody at your company who's potentially a developer. And this is not really this is the way that some startups do it, but this is not really a safe long-term approach. And furthermore, applications are developed by different teams. So if someone on some team runs an application on your server that is maliciously or not trying to access secrets that are only used for other services, you don't really have this strong boundary level here. Now, this is obviously sort of a straw man, but people do implement their servers and protect them in these ways. So what are some potential solutions for this? Well, more commonly, people do this thing where they encrypt the secrets in source control. And then they take their set of secrets, they make a parallel set for development to talk to development servers, and a set for production that's encrypted that can only talk to other production servers. And the secrets in the configuration management, they are encrypted with a key that's only held by one secure box. And this is sort of one node that is deploying the configuration outwards. And you reduce your trust space from source control management, which is accessible to everybody, to some one dedicated machine that you can lock down the access to. And when you add new machines into your system, they have to authenticate with this configuration management master node, and it will be able to distribute the secrets. So this is not something new. There are secret management tools, and this is something that has abounded over the last couple years in terms of open source solutions. So you may have heard of Vault or Nox from Pinterest or KeyWiz from Square. There's a bunch of other ones. Lyft built their own. But they all have sort of the similar architecture. And that is essentially you trust your machines on first use. So whenever you provision your machine, you give it an identity. And then this identity is what's used to, you sort of manually accept these machines as part of your system and trust it on the first time you see it. So you create a machine identity at provisioning time, and then you can create this identity key pair and register it. And this is a very common pattern. And as I mentioned, Vault, KeyWiz, Nox, these sort of take this to the next level. But the basic idea is trust on first use. And this identity that's provisioned to the machines is used to bootstrap a secret management tool. And so I mentioned a few configuration management tools before. They have these plugins that do this. So Salt has a GPG plugin where you give a GPG master key to the Salt master. Chef has something called encrypted debags, which is just really funny to say. And Vault, Kiwiz, and Knox are a little more complex, but they have really sort of interesting password rotation and account rotation features built in. So once you log into Vault, you kind of it can deliver all the secrets to you. Kiwiz has this nice thing where it mounts a fused file system, like that looks like a file system that holds the secrets, and whenever you access them, it does a secure tunnel back to a central secret management server. But as I mentioned, the downsides here are that you have to have a secure secret server already running. So this kind of makes a two-class system, really, where you have some small trusted machines, and then this lets you bootstrap and send secrets to all the rest of them. So for people who don't do a lot of server development, you can think of this, here's an analogy for this, which is kind of a permission system like iOS or Android has. And you can think of your machine as an application, your permission settings as this configuration management system. So if you approve and disapprove different accounts to different applications to do different things, this is like configuration management, and your secrets would be system resources. So if you get a new application, it can try to access these secrets if it is in the proper configuration management system, and that's sort of one way of thinking about it. And this is great, but we're in 2016, so a lot of these things don't often apply. So it's great if you have a single team, if you have a shared configuration management system for your entire company, or your number of servers scales to the point where you can manually approve them all. This is the third one's typically the case, but this is not how modern server deployments are going in the future. We've got there's this trend, Docker everywhere. You've heard about this a lot. Docker's not the only technology in this space, but generally containerized deployments are becoming very popular. So in the last 10 years or so, it was more typically you have a virtual machine that has a full machine image, and in Docker it's sort of a more compressed version of that. And if you look at this diagram, it sort of explains how in the old case, which is you have an entire guest OS, and this sits on a hypervisor, and you can have entire systems going 1, 2, 3, and you can use trust on first use to bootstrap the secrets for those. But in Docker, it's a little more compressed. You have not an entire operating system, but you just have a small amount of just the code you need and sort of a shared substrate of the system. And this changes things quite a bit if you consider your data center, because there have been a lot of tools built on top of it to make an entire data center and a lot of machines look more like one computer than like individual servers. So Mesos and Kubernetes, Docker Swarm, these are these orchestration frameworks that really make it so that when you deploy services onto your servers, you don't know how many servers there are, and you don't really care. You're just treating the entire set of servers as an operating system, and you use Mesos or something like this to distribute resources for it, just like an operating system would. So if you compare your applications inside a virtual machine to your applications inside of a Docker container, there are some very stark, important differences. And in the Docker world, your applications are ephemeral. They can go away. They're designed to be able to shut down and spin up all the time. So for example, in Marathon, which is in Mesos, it's sort of the equivalent of systemd. They have another thing called Kronos, which is the equivalent of cron. But for Marathon, there's a button in the UI that says scale. And you say scale, and then you say how many versions of these do you want, and then it just goes out there and deploys them all. This is not something that's really going to work well with trust on first use. You're not going to scale 90 or 2,000 copies of an application and then sort of approve them all, because they could be deployed anywhere in your infrastructure. So in the Docker world, you have one application per container. In a VM, you have this sort of world of applications inside each container. And the other important difference is is this Docker world lets you have different teams deploy things independently. You don't have to go through a centralized configuration management system. You can say, this is a shared operating system space or a shared server. You can deploy stuff here, you can deploy stuff there. Different teams can manage these independently. So you may have read this. This is just last week. Vine had this Docker registry issue. I can sort of walk this if you guys haven't read the news, but basically docker.vine.com, which was their Docker registry that had all their Docker containers, was publicly routable. And somebody found it and was able to download their live production copies of their backend. And they were using, I believe it was Python, so they could just read the entire code. So they had the entire code base of all of Vine's backend. And more than that, they had API keys, they had secrets embedded inside the containers, and these were just all fully revealed from just the fact that their Docker registry was open to the internet and not requiring authentication. So this is the worst case for deploying secrets in Docker. And there are a couple lessons we can learn from this. And these are just basic, very basic things. Is use access control for your Docker registry. Don't register containers that have secrets inside. And sensitive code in containers is dangerous. This third one is kind of hard to get around in a lot of cases. But the first two are really kind of obvious lessons that you learn. So if you think about it, we can go into the sensitive code. I have an example on that later. But when you have Docker containers, the application model for Tofu doesn't really work. You don't have, I understand these are, I've deployed my 60 servers and I know where they are and I know how they're configured. You have applications in the thousands. So Docker containers, how to secret. How do we do it? So an interesting way to think about this is to take another permission system analogy. And if you think of how iOS or Android constructs things, they have these sandboxed applications. And they all kind of live in harmony on the machine and talk to the host to get access to system resources. So this actually maps up pretty nicely with the data center operating system model, where every container is like a signed application. And if you have a container and you want to release it, you code sign it, and you do code signatures, and you do that at the mastering release time. And your applications are sandboxed, your containers are basically sandboxed. It's basically sandboxed. And if your application wants access to secrets, it talks to the host. And the host can sort of check these entitlements and deny by default, just like your application can ask for access to your camera, and it would be denied by default. You'd have to sort of manually approve. This has practical differences between sort of an iOS kind of single application holding phone to an entire data center, because it's fully multi-tenant. You have multiple teams developing different things in parallel. So sometimes your secrets are unique per app too. It's not like every application wants access to the camera secret. You can have application-specific secrets. So this leaves us in kind of an interesting question and in place is what's missing? What's the missing link to make this model work? And that's really container identity. And this is your whale passport. This is what Docker containers use to prove who they are. But essentially, you have containers and they have to have identities that you assert. And luckily, Docker has built this tool for this called Docker Notary, which is just like a code signing tool. So a Docker container is built in a bunch of layers. This is a digital signature over those layers. And you can build a PKI on that, and you can sign it at mastering time. You can do key delegation, all these sort of nice things around that. So given that you have identity for your Docker application, let's put this into a visual. I've been talking a lot in bullet points and sort of generalities, but let's look at it. So we have a host. We have a container running on the host, and say you have a secret manager. This is just something running on the host that has access to a database of all these secrets. The container will say hello. The secret manager will ask Docker Notary, is this a real legitimate signed container? And does it have access, basically, is this a legitimate container? And if so, it will give the container its identity secret. And an identity secret is like a key that says this, sort of very similar to how we described earlier with the host. When you securely provision a host, you give it an identity secret, which is a key that says, yes, this is really who I am. This is this machine. It's been provisioned. And then that is used to bootstrap secret managements. In this case, each container gets an identity secret that's tied to what the application is. Now, this is a little bit heavyweight because this secrets database, deploying this to every single one of your hosts is kind of dangerous. I mean, you want to limit access to this. This is potentially, how do you protect this? This is something that has all your secrets. So another way to organize things is to, rather than having your entire secret database live everywhere, you would have a key that can decrypt your secret living on the host. So the container would spin up, send the encrypted secret to the secret manager. It would check the policy to say, hey, is this container, which we validated the signature for and the identity of, is this allowed to use this key? If it is, then it'll decrypt the secret and sort of inject it back in the container. And this is kind of flipping this model on its head in that it becomes not a question of database management, but a question of key management. Now, you can split this up really nicely, so each team has its own key, and each team can manage its own policy, and you can have multiple containers running on the same host, and sort of everybody manages their policy separately. It's also potentially worthwhile to just have a separate server that has access to these keys, and rather than having the secret manager talk locally, it can talk to something remotely. And this is what PAL is. So this is introducing the project, which is PAL, Permissive Active Link, Access Link, which is this is a term of art, I guess, from nuclear weapons. It allows you to connect the arming data to the bomb, and it goes along the theme of some of the other open source projects, and I'll show you those further along the line. But yeah, it connects the bomb with the arming data, and that's essentially what this secret manager tool does. So the basic workflow is this. You encrypt secrets before you master the container. PAL is the entry point for your Docker container. So rather than running the application directly, you run this wrapper around the application that does secret unwrapping first. And so it takes your secret, sends it down through a Unix socket down to PAL-D, which is the component that's sitting on the host. And actually, let's look at this more visually. So PAL is your entry point. And what happens is when your container spins up, PAL will talk down to PAL-D, which will talk to Docker Notary and verify that the container is who it says it is. And then PAL-D has a bunch of plugins or different ways that it can decrypt the secret. And this is really up to what secret management or what key management tool you want to use. So for example, PGP is one option. So PAL-D can talk to PGP, to a keychain, and say, okay, well, decrypt this secret for me and send it back up. So we talked about Vault and Knox and all these things before. PAL-D is not a secret management tool. It's a container identity bootstrapping tool. And this is very important to say because we have a million secret management tools. And every single one of them relies on a secret to get bootstrapped to the point where it can deliver secrets. So secret management, it is really more of a term of going from one secret to many. And what PAL gives you is that very first secret, the identity secret of the of the container itself, or the Docker container that wants to get access to your secret management tools. Now, applications. I'm going to walk you through a few ways. So PAL is something that we've deployed at Cloudflare and we're using for a lot of our internal systems. We have a data processing pipeline that is all built on Docker and Mesos. And the reason that this came about was we had secrets, needed a way to manage them. And we did have a secure way to identify hosts and enroll them, but just not a secure way to inject the secrets into these containers. So let's talk about a few applications. Service-to-service authentication. Now, if you're running a distributed system, it's sort of popular nowadays to call it a microservice architecture, where you'll have multiple little tiny projects, little tiny applications that handle pieces of the puzzle. And whenever you take a large monolithic project and split it into tiny pieces, they need to be able to trust each other to do the right thing. And just being in the same data center is not enough, especially if people can sort of take any application they want and deploy it and spoof other applications. This is well within the threat model. But if you're taking your service and you're splitting it up into tiny services, they need to be able to trust each other. And this is what PAL can do if you have a service-to-service authentication framework. So the way it works is every service gets an account, a service account with an identity key pair, and the private key is encrypted with PAL. And on launch, the container spins up, decrypts this private key, and talks to the service authentication service and gets what's basically a bearer token, a token that allows it to talk to other services and sort of assert claims and say, for example, if you have one container that is your API and one is your database, the API thing can come up, and then it will get credentials to talk to the database. And there's a tool that we've started using and other people have experimenting with. It's a standard from the W3C called Jose. And JWT is a JSON Web Token. It's just a simple way to encapsulate a bearer token. You have claims and they're signed. That's basically what it is. So when your service spins up, it can talk to the identity service, the service authentication service, get a bearer token, and then talk with any other service. And those services will know that this is who they said they are. That's one application. This kind of has an enterprise password manager analogy. Rather than a person trying to log into get an access to the Visa account, you have this robot, this sort of automated machine, and he says, okay, here's a jot that says, can I get one that has permissions to the corporate Visa account? Here's my self-signed identity jot, and this guy says, no way, Jose, you're not on the list. That's my Jose joke for the day. Yes. Perfect groaning. I appreciate that. Anyways, okay, so this is one application. Another one that a lot of people have been using is PKI authentication. Rather than using bearer tokens to talk to each other, I mentioned there's passwords, bearer tokens, and private keys. PKI-based private key is a way that applications can authenticate themselves to each other. And if you have a service spin up, you can encrypt this identity credential in PAL, and then it can talk to a CA and get a certificate, and then it's absolutely clear that the service is who it is, who it says it is, and then you can do mutual auth TLS between different services and be able to spin things up. A third application that I had hinted at before was this secret manager integration. So if you're running Vault or one of these other tools, I mentioned they need an identity secret to spin up. So that's what PAL can give you, is you can embed this identity secret into your application, and then it can talk to your secret manager tool and get all your API keys, your passwords, and all these sort of things hooked up, which is nice. Then you don't have to use Tofu to trust every one of your containers. You're moving the trust from the container down to the host. This fourth application is something that is interesting, and this would maybe have helped the Vine case, which is you can encrypt your code with PAL. And when your container launches, then you can decrypt your code. So if you have a Docker registry and someone has access to it, then they don't get anything. All they get is this encrypted code. which makes it a lot more resilient to if you screw up your authentication or someone gets access to it. It kind of protects your intellectual property. Now, with all these applications of PAL, there are a couple sticky parts. One's revocation, which is, if your secret's in your container, you have to roll a new container to build your secret, to build a new secret. That's sort of a downside to this. And building the policy for who can decrypt what in terms of applications is difficult. But luckily, we have another open source project, and this has been open for, I guess, 2.5 years or so, that is really cool, that allows you to do this, and PAL is integrated with it. It's called Red October. So I don't know, has anybody heard of this tool? It was on our blog, a few people. But it's basically an encryption and decryption oracle. This acts as your key decryption service. And it does have cryptographically enforced policies. And by that, I mean you can encrypt a secret such that 2 out of n people need to approve it to allow it to decrypt. And this is enforced cryptographically. So this is oftentimes called the 2-man rule, the 2-person rule. And Red October allows you to do that. You can take a secret and encrypt it such that you have basically 2 people that can decrypt it. And we've recently expanded it to include what are called arbitrary Boolean predicates, which you can just think of just any combination of people need to approve, you can define. So in this case, you can have A could be like a super admin. You need A and one of a group of B, C, D to approve it. So this allows you to have much tighter controls as to, a person manually approving how to decrypt something. It has a UI, and the features are, I guess the workflow is that when you encrypt something, the owners you can encrypt it to a set of owners of the secret, and also you can give it labels. So when you want to decrypt it, the owners need to delegate their passwords to this service or delegate their credentials to this service. And they can do so for a limited number of uses, a limited number of times, and for a limited set of users to decrypt it, as well as a limited set of labels. So if you have a secret that you encrypt, you can say, I want 2 out of all of the managers in the company to have to approve this to decrypt it, and my secret's going to be called Postgres database secret or Postgres database password. And then 2 out of those people can delegate to Red October for 1 decryption within a 5-minute window, and to the PAL-D container, not the container, sorry, the PAL-D host as a user to decrypt it. So they can say, okay, I want this secret to be deployed on this host. I'm going to allow it to happen once, and I'm going to allow it to happen in the next 5 minutes, and I'm only going to allow this person to do it. And it allows you to have some pretty fine-grained controls over how these secrets can be decrypted, but it also allows you to set things up so that they're completely automated, or you can reduce the amount of user interaction. So you can say, if you want, you can delegate for, say, a week. You can say, okay, well, this can happen 100 times in the next week. And any one of the machines in my production infrastructure can decrypt it. And so then if you have Docker machines go up and down, spinning up or spinning down, you can have it happen 100 times within the next week, and you don't need any manual interaction. But you do have the full logging and auditing of every time someone goes to decrypt this. So I had sort of alluded to that in that tangent, but back to secrets is the idea is you provision hosts a per machine username and password with Red October, and then you encrypt your secret with the label belonging to your container and a set of owners, and then before you deploy, 2 out of the n owners, or whatever the Boolean predicate is, decide to delegate their password to Red October, and then the user accounts in the machines who are expected to run this container. And every decryption is logged. And if you look at this in a visual way, it looks a lot like one of the previous models, except in this case, you have owner 1 and owner 2 who delegate password, user, label, time. And at any time this is delegated, you can kind of restrict it to a subset of your infrastructure if you want. You can restrict it to one place or another. And this is the main use case that we have for PAL. Now, I mentioned PAL is a tool. We are planning to open source the tool very soon. And in the meantime, if anybody wants to come up to me after or talk to me on Twitter, I can get you early access to this tool. But before I do so, I'm going to show you a quick demo. It's pretty text heavy, but it will at least show you how PAL-D actually works. So, all right, so I have this nice PAL-D demo. So, first step is to start Red October. This is going to be fun for everybody to read, but basically you start up the service and it gives you that web UI that you want, or you can sort of manually connect to it with a command line tool or with curl. But start Red October. Let me show you step one is encrypt the secret. So we have two secrets here. One is defect at dawn. Secret 2 is one ping only. And essentially, you can encrypt it by just curling or sending the secret to Red October and giving it a list of owners. Jack Ryan, Marco Ramius. These are the accounts of the owners that we had created. And it spits out this YAML file down there that says demo, that has an environment variable and a file. And so the way that you write secrets down in Red October is you just have basically a configuration file that says secret, and then you have RO, and then a bunch of ciphertext. And if you have a file, you have a file name, colon, RO, colon, a bunch of ciphertext. So, all right, this is our secret as encrypted. It does get inflated quite a bit because you're encrypting to multiple people. So PAL-D is, as I mentioned, it's something that runs on the host, and it gets a Unix socket and a small configuration, and basically it just sits there waiting for Docker containers to try to connect to it. Let's see. So PAL-D's running and listening, which is good. Delegate authorization. This is where Marco Ramius and Jack Ryan give their passwords to Red October for 1 hour, 10 uses. And you can sort of see right here. And the label of the account of the demo machine and the label of demo. So delegate authorization. All right. So it's talked to Red October, and that's good. Run PAL. So as I mentioned, PAL is your entry point to a Docker container. And if you don't know how Docker containers work, essentially they just run one command. And then that command is usually your application. In this case, PAL is your command, and it wraps another command. So if you look right on the line right there, it says root bin pal -socket. It says the socket that it's trying to connect to. And root bin demo is our demo application. And this demo application is really just either reads a secret from file or secret from disk, and it contains this encrypted YAML of the secret and prints it out. So let me run this. So run PAL. All right. So it says it has connected to PAL-D, sent it the secrets, and PAL-D has sent it to Red October to get it decrypted, and then embedded it into the Docker container itself. And then the last step is query demo, where we just curl this Docker container, the secrets endpoint that is basically just going to print out your secrets. You don't want to build a service that just prints out your secrets. That's sort of the opposite of what you want to do here. But for a demo, it's quite nice. So environment secret, defect at dawn, file secret, one ping only. And if you see here, this is the secret file. and the secret environment. And voila, that's PAL in action. Thank you. All right, so we've got a little bit of time left to talk about, to answer questions, but we're basically at the end. So in conclusion, PAL, this is a tool for bootstrapping your container's identity. It allows you to securely have secrets, and if you're building a production infrastructure, don't leave your secrets sitting around in source control. Don't leave your secrets, your passwords, anything in a place that it's not unencrypted, and if it is encrypted, don't just leave that key lying around anywhere either. What Red October gives you is this nice abstraction where you don't have any keys sitting around, you have a decryption service, and that decryption service can be time limited, which is really nice. So PAL is complementary to Vault and all these other these sort of secret management tools. It helps bootstrap the identity that makes that secret management world possible. So where to get it? PALD, just as a shout out, Joshua Kroll is the main developer for this, and a bunch of other people at Cloudflare contributed as well as myself, and it will be soon on GitHub with a very permissive license. Right now it's Linux only, and it does have built-in Mesos Marathon integration, because that's our orchestration framework that we use. And if you want early access, you can email me, nick@cloudflare.com. That's it. Thank you very much.
Questions?
When you're speaking about the interaction between the container and PAL-D, and the PAL-D is supposed to bootstrap the identity of the container.
Yes.
But the connection that you have over the socket leaves, I think, the question of who, in fact, executes the call somewhat open. Right? So how do you identify the actual caller on the other side of that call?
Right. So when the connection from the container to the host happens over the socket, you can actually inspect the UID of the program that's making that connection. So having that UID as an inspection point allows you to measure it, and then you can use Docker Notary to validate that container. Well, then you match to see whether that is the right UID that's been sent there. This is the Mesos Marathon orchestration part. You compare it with, this is all the innards of PAL-D, but you compare the UID with what it's supposed to be, and then you validate the signature on the container on top of that. So there's more details we can talk about it after.
So everything I know about Docker I just learned right now. So I'm curious, as running services on a host, is it possible to still use this, like Red October, to manage secrets?
Yeah, absolutely. Red October itself came well ahead of using PAL. And the main use case for it was sort of long-lived sensitive secrets. Maybe not ones that are deployed on servers, but ones that are used inside of build systems or for code signing or for things like this. So if you wanted to use Red October to manage your secrets in a sort of traditional host environment, go nuts. It's great for that use case.
So I'm curious, I guess, why did you write a new tool versus using something like Console Vault or I guess Chef Vault or whatnot?
Yeah, I think the main point I was trying to emphasize in this talk is that these tools work, but they need an initial identity credential to work. And so how do you deploy that? And you can do that very well on a system where you have a bunch of hosts and you have configured them manually, and you can deploy secrets to those hosts. But when it comes to secrets coming directly from the Docker container itself, there's no way to bootstrap Vault. I mean, this is the way that we found to bootstrap Vault. There was nothing else out there that would do it for us. So that's why we built this new tool.
If I'm the chief technology officer or I'm a security auditor, how easy is it to look at a system that's been set up this way and understand what the policies are and exactly what's going on?
That's a good question. Yeah, as occurred to me when I was just explaining all the different points of configurability for Red October, it is quite complex. But if you do have an environment where you can use just a simple subset of these, it's simple to write down the policy. But yeah, I guess this, along with a bunch of all these other new tools, are new, and explaining them to an auditor is potentially difficult. But I would say that explaining how you manage secrets without something like this is potentially more troublesome.
You mentioned earlier about the trade-off between storing secrets locally that are encrypted and passing them to a central secret authority or key management solution versus just storing the secrets and having them manage all of those there. And then I feel like that wasn't addressed when we talked about specifically PAL. What are you guys recommending users do in that situation?
Right. So at first, when we built PAL, we sort of thought we could just stuff a bunch of different secrets in here, and you could just put all your secrets that you want for your container inside of PAL, and when it starts up, they'll all get decrypted. But as we went further along, it made a lot more sense to just make the amount of things that you do with PAL as small as possible. Just limit it to the identity of the container, and that's it. And I think having a large secret management system is valuable, and that's why you still want to use Vault or Knox or something or KeyWiz with something like this, but restrict PAL to just the identity of the container itself.
Okay, we need to stop there to move on to the next talk. So once again, thank you, Nick.
All right, thanks.
And out of simple curiosity, are you going to stay around for the pool party tonight, or?
I'll stay around for a bit.
Okay, yeah. So anybody who wants to ask more questions, he will be here for a bit. Okay. So we will have our last and final speaker in 10 minutes, and then we are going to, his talk will be about a little bit, I would say a little bit more about the bigger perspective, because quite a lot of the talks that we've had at PasswordsCon are usually very focused on what some people call very narrow topics. But the next speaker up now is going to be, broadening our perspective of anything digital authentication. So stay put and be back in the room in 10 minutes. Okay? Thank you. to do our final talk for Passwords this year in this city. For those who don't know yet, the next iteration of PasswordsCon is going to be at the Ruhr-Universität in Bochum in Germany in December. That's going to be December 5, 6, and 7. So it's 2.5 days about passwords, biometrics, forensics, cracking, PIN codes, lock patterns on phones, you know, whatever you want. The conference that I do in Europe is 50% academic. So we actually take in academic papers for peer review and post proceedings. And the other part will be the normal hacker style talks like we do here in Las Vegas. So the CFP for both academic papers and for hacker talks is still open for submissions. So go online on passwordscon.org and you will find more information there. So to end it off, as I said before we took a small break, I said that a lot of the talks at PasswordsCon are very specific, very narrow on small topics. Now I think, Terry, that this last talk will be a little bit more broader in scope than the majority of the talks that we have been listening to now for the past 2 days. So with that, I'm going to leave it to Terry Gold. Go ahead.
All right. Thank you. So usually I give talks that are more low level, breaking things and, you know, and if anybody's caught any of my talks before. This time a little different. I figured everybody's had a couple of days of breaking things and, you know, what I come across typically, and I'll give you a little background and a little funny story to start it off is, you know, I didn't start off being a hacker or a white hat, and I don't really consider myself one full time anyway. But I got a call one day, and I got a call from a guy named John, and I worked for a vendor. This was back in like 2010 or 2000, somewhere around there. Anyway, it doesn't matter. And he's asked me all these questions, and I'm like, yeah, you know, answering his questions, thinking it might be a customer, whatever, don't know. And we had a great conversation, and I loaded a lot of, you know, great questions deep into RFID and binary payloads and how it works, and I didn't hear from him for a couple of months. Okay, whatever, I have a lot of things going on, wasn't thinking about it. I got a phone call back 2 months later, and it's John. Hey, you know, and he's like, you know, we haven't talked for a while, and I was like, that's cool. He's like, so, you know, I kind of feel bad. I'm like, why? He's like, well, I'm kind of a jerk. I'm like, why would that be, John? He goes, my name's not John. Yeah, okay, it's Bob. And you know, what I do is, you know, I do pen testing, I do red teams, and I was just basically social engineering you for information because I'm working on a project where I'm getting paid to go ahead and break into a place. It was a physical access project. And he's like, you know, they're so heavily secure that you know, I've done all this stuff from like UPSing people into the building, like packing them in a box. He's painted delivery vans to match the brand of the people that do the delivery. He's like done everything under the sun, and he's, you know, the best he was able to get was get into like where the unloading dock area, but not really at the, you know, anything worthy. He's like, so I was trying to figure out how to do this a better way, and I just want to come clean because I talked to a lot of people, and I just got kind of the best information from you, and you could hate me, whatever. It was cool. So where that leads to is we had great conversations, and he said, Terry, you know what? Why don't you come out to BSides Rochester and present? I said, you know, I'm not a hacker. I don't know. I'll be like the dumbest person out there. Why would I do that? And he's like, you know, but even if you're the dumbest person out there, you have something to share, right? So when I give these talks, that's what I do. I share, right? And that's where I'm coming from. And so for the past 10 years, the past 7 years, I've been involved. You can see my BSidesLV shirt. I organized BSidesLV. It's a great venue, and we share. And you know, where that story comes from is I've gotten very engaged with people like my friend, and to be on red teams with them to help advise on things to do around passwords, whether it's physical security or info security, alternatives, and where to look for things. And you know, I've learned a lot. But what I've seen is that when pen tests or red teams get done, you have some people that are really, really, really good. And they go in and they find a lot of holes, whether it's an energy grid and it's exploited, and a few things happen. The customer can put their head in the sand and say, how can this be? They want to bury it. Or they're taking it all in
and the very smart people that broke it, they got to be smart, they broke it, says it's broken, you need to fix it. And you need to look at some alternatives. But just because you're a smart, white hat or whatever you want to call it, a researcher, it doesn't mean that you might really understand the depth to advise an enterprise organization, whether it's energy or defense, on how they're actually going to go spend a few $1,000,000 to go do this where it's successful and people don't get fired, right? And so for my job for the past several years is I'm a hired mercenary by these large Fortune companies that take on these initiatives to figure this out. And on the surface, it's very easy. We all know what these things look like, what there's a smart card or a token, but at the end of the day, all the crap that goes along behind it, the million ways you can do it wrong that you probably will, if you just stay at the surface level, you'll do it wrong, and heads roll. So I'm here to share my knowledge around knowing both sides, but lessons I've learned over the past 15 years of doing this to help people understand the technology around the alternatives. What are the alternatives from Passwords itself? Let's kind of break it down. So there's some fundamentals, and then there's stuff around like, obviously what would my opinion be around those alternatives. And for some reason this is not working. I have a Microsoft Surface freeze up. Great. It's a keyboard thing. You gotta love it. Okay, so while I do this, and hopefully it works, so we'll talk about those alternatives. I'll give you my opinion after working with them for a long period of time as to how they perform, how they scale. And my bar is how well are they gonna scale? Because if they don't scale inside of a large enterprise, then they might work in a small enterprise, but you can't really take what you learned from a small enterprise and scale it out. But you can do the reverse. So you can go through the best practices of a large enterprise and learn a lot of things and then apply it in a smaller sandbox. This isn't good, and I'm hoping Microsoft doesn't make me do a reboot. This is pretty terrible, and I apologize. Maybe if I just swipe it. Okay. It wants a swipe. It doesn't want any. Oh, the swipe just kind of got everything going again. Okay. All right, so I'm going to take this in 3 parts, and I'm going to take this really, I want to differentiate between identity and credentialing, because a lot of people think about a password as identity, or you got into something, so that's your identity. And identity and credentialing are 2 separate things, they're very relevant things, so we'll review that as a fundamental. And there's going to be things in here that are fundamental, so some people might get bored, but we'll get into the weeds later on if you want. And we're going to take this from a vendor neutral approach. I'm not mentioning any vendors, I don't work for a vendor, I don't drink the Kool-Aid. Most of my time is spent where vendors probably hate me, so it doesn't make sense to plug them. And really, I want to take this from the approach that when you tackle a password alternative project, that you're going to have to go through a high level of scrutiny on your plans, on how you're speccing out, what resources are involved, how much money is going to be spent. So I'm not going to spend a lot of time on ROI, TCO type of business stuff. I will spend a couple minutes on it, just give you like a viewpoint if you want to spend more time on it. But all these projects, when you're going to propose something large scale or critical that's got to work, it's got to protect, it's got to do all these things, and we'll talk about those things, it goes through a lot of scrutiny because it involves many filters, many people, many types of resources across different management infrastructures. So it becomes very challenging and people lose patience. And what I want the audience to walk away with is, I want you to be able to get through the vendor Kool-Aid, because all vendors go in and there's like 200 vendors in this alternative space, password alternative space, and they all kind of give their Kool-Aid and they really believe it. They just, and if they go work for another company, they believe something different. But the customers, they're going to own whatever decision they make. So I know that most people in this room are probably independent. You probably don't work for a vendor telling you what to think. We're independent thinkers. So I want you to walk into an organization and say, where do I start to assess this? What might be the right path for them? What might be the right solution for them? And what's the right process to kind of bring them through to think them through, okay? All right, so my whole thing is, I'm not gonna review things you already heard of, but if you look at how all these attacks are executed that we hear about in the news a lot, a lot of them have password elements to them. It's not the only element, but it's pretty much what I see as a common denominator.
You know, and so you can even look at like whether it's a Verizon breach report, and it's like most of these breaches involve some element of password or identity exploitation. And that's a reality. So when I look at what organizations are doing or what they didn't have in place, I'm kind of stunned that they haven't kind of gotten their act together with either strengthening the password, other processes in play, or other alternatives. And sometimes it can just be they did 90% of it or 95% of it, but in that last 3%, the attackers were able to find where they were vulnerable, where they didn't have it completely implemented. So that's my whole thing, to get people thinking where I'm coming from. Now, where I have to go with this is what's identity? Because if you're doing a credentialing program without a concept of identity, you're pretty much hosed, in my opinion. Okay, so I want to take you through that very briefly. And so identity really is separate from a credential. An identity can be where I would say you have different attributes that make up a person's identity, right? Traits, for instance, they're things that you can't change. I mean, arguably these days through genetic modification and stuff, yes, but generally, you know, eye color, height, and all this stuff you're born with. You would have attributes maybe that get assigned to you. Last name, an address, an employee number, a driver's license number. These are all things about you, okay? These are all things that when you go to an organization, they have to manage and associate with you. And things change, and they have to make sure that it applies to you, and they have to understand that context. And then the thing that really makes identity a lot of work is not just updating the attributes, but relationship. I mean, think about it, as my relationship with my organization changes, or my role changes, which my relationship may change, what I can access, or what I can do, or what I should do changes. And so we get into, that's really the bulk of the identity management work, is managing the relationships that I should have and the entitlements that I should have. And that has nothing to do with the password that I'm assigned yet, okay? Or the token that you give me. But what happens is, you know, roles change, relationships changes, okay? So that's this whole other thing. That takes a full, in effect, program. It's a separate program, but it's a focused program. The credential, I look at it as the proof behind all that. So once I have the identity locked down and I'm managing the relationships and the entitlements, the credential is the representation of who I am to be able to execute a challenge and a response to prove who I am. And it's up to the program, whoever's managing the program, to make sure that's either a strong or a weak challenge response, okay? And I'm not sure I'm really gonna go through a lot of this because my animation isn't working, so, well, oh, it is if I swipe, okay. So my point here is that you go into a commercial organization, an enterprise, and I would say that you walk in with existing identity attributes already. Right? So I have a Twitter account, I have a Facebook account, I have a driver's license. They're all disconnected, but they're all things that identify me. And why that's, you know, kind of interesting is because when I go to HR, they want me to prove who I am. Even though they kind of know, I show up for my first day of work, right? And they want, what do they want? They want a driver's license. They want a bank account number. They want to put you in payroll. They want to do a background check to make sure it's your bank account and your payroll, all this stuff. So you carry these third-party things that are already assigned to you into the enterprise. They piggyback off them, and then they put you in, whether it's performance management system, talent management system, payroll. Now you have separate identities within their system. And then they tell, hey, IT, he needs access, right? So they'll tell IT that, you know, to set you up to get you access to what you need according to your role. And now you're in AD, you're in disconnected applications, and this is where you have the problem where some people have, you know, 20 different identities inside of an organization. So it takes work, and then physical access is a whole different story because that's usually disconnected, right? So that's the story with identity. It's completely separate. Now, I need to go in and say, okay, well, credentialing. Let's get into the credentialing part. What credentialing is appropriate? Well, I got to look at the risk. I got to look at what people are doing. If they're just accessing a lobby, well, they're going to get an RFID card and doesn't really probably need to be a very strong one. You could argue with me, but I'm saying they're just getting in the lobby, right? But, you know, if they're getting access to a data center, or let's just say they're getting access to an HSM, the person that manages HSMs, where all your crypto keys are stored, I mean, you better make sure that that is a really strong credential. So not everybody in the whole organization needs the strongest credential. It can be mixed, right? And you have to look at that, because the stronger you go, the more complex and more expensive it is. And I want to spend according to my risk, because I can't afford to just go ahead and spend millions all over the place and overspend. But it's not just about the technology, and this is where people fail. It's about how you proof that identity. How do I, upon enrollment, know that it's the right person being enrolled? What's my process to ensure that? How strong is a challenge when somebody busts out that credential to authenticate? How strong is that challenge in terms of how well it could be manipulated, forged, or otherwise? And then the response. You know, what's the response? Is it symmetric key? Is it asymmetric? And then the validation part of it, right? So there's all sorts of validation processes and trust models that we'll get into, that how much trust do I put in that credential? So, and all this is a lot of process policy. It involves, you know, what type of crypto you're using, who's performing the background check, is there an anchor of trust, right? Is there a practice statement where they audited? So the world of just issuing a one-time password token, it sounds great on the surface, but a lot of times they're void of all this, which might be fine for the application that you're doing, but it may not. And it takes individual analysis across the spectrum of your assets to find out really which one is appropriate. And that's separate from, does vendor A do it better than vendor B? Right? That just comes down to the premise of the type of technology and the general policy that I require, right? I'm going to skip through things and I'll take more questions. Things that we'll talk about a little bit more, I'm going to get into the types of credentials in a second, but when I mentioned about the process, the policy, a lot of it comes back to this stuff, right? So how are you going to vet the person that it's really them when they enroll, but also when they come and when you issue and distribute their credential to them? Because maybe it's not, maybe they're gaming you, it's not, maybe they're getting you to distribute the credential to a rogue user, even though it's a real person that enrolled, and you need to make sure that that's pretty tight if you have high security stuff going on. So that's the adjudication piece. Background watchdog checks, sometimes that's critical, like, hey, they passed a background check and we vetted them when they first came in and got their credential, but 3 months later they got picked up for some crime, and you know, so it's always kind of, maybe some organizations have this rolling automation of a background check that goes out to federal systems and see if somebody was okay, but they're not anymore. And then you have secure issuance where, you know, when you're provisioning the keys or you're doing a key ceremony or anything like that, that the communication between the authoritative source and the key store down to the client or the device itself can't be compromised. Which is why, you know, all these upstart companies that just say, no big deal, you don't really need this infrastructure to do key management, and they just be like, yeah, all you do is kind of like this, you know, P12 file, and you know, you just offload this P12 file and you put the key in the device, and it's like, that is not very secure. And if you have a lot of people doing the issuance, I don't recommend it, right? So you need infrastructure, and you need to make sure that the points upon issuance, delivery, and activation are very secure. Perhaps, maybe you determine it doesn't, but I'm going to this end because you can always go backward. That's where I'm coming from, right? So, and then it's the application security of the product itself, which everybody's familiar with, because security products don't always mean that the product itself isn't secure, even though the functions try to deliver it. And life cycle. Life cycle is huge. When you start to get into organizations that have remote people and they're disparate, they're on different campuses, they're flying around the world, how do you handle when, you know, they lose their PIN? How do you handle when they lose their credential? You know, are they calling help desk? Can you get the device to them? What if they lost their phone? A lot of these systems are, even the mobile device approaches are, and I do a lot of advisory with end users and get hired as a mercenary and a lot of Q&A with vendors on how they do things. And I can tell you, you know, in the mobile world, a lot of them are assuming that, oh, we have help desk automation for that mobile device to get your virtual credential back. And most of the time it's based on the fact that it's the same SIM and the same number. That's all they look for. And there's no like intermediate approval or delegation. And but if you're a large scale enterprise, you're gonna face all these things. People lost their phone. Somebody took their SIM. They dropped their phone, it broke. It's in the bottom of the river. I don't know, but you're not gonna want all these help desk calls all the time. And those help desk calls start to turn into spear phishing calls. And so anyway, it's a lot of that stuff. Okay? All right, so let's go through some of the basics. This is the basic stuff, something you know. And we all know what that is. Generally, it's going to be a password or a PIN or a question-based answer, response and answer. And all these things are based on memory. And I think we all know that they have flaws. I'd like to point out that passwords I don't think they'll ever go away, and I'm not justifying their existence. It's just they come with the application, at least this day and age. They're for free, right? So if you go buy an Oracle database, guess what? You're getting password functionality for free in that database. And Oracle's just unwilling at this point in time to do anything else out of the box that scales across any other. They see it as not their responsibility. So guess what? Passwords are going to be here for a long time. They just will. And you can decide whether they're still in play. They're still in play for different audiences or applications. But the reality, in my opinion, is we've got to move beyond passwords for some of our assets and groups of users because we have different levels of risk. And that's where I'm coming from, okay? Okay, so I'm going to skip over that because you've had 2 days of that. Something you are, biometrics. Basically, it's a biometric. And they come in all forms, iris, facial, palm vein. There's all sorts of things, heart rate, heartbeats, and there's on the surface, they look like they're the holy grail because it's you. How can it be anything but you? And how can you forge something unique to you? Well, I can tell you, I work for one of the leading biometric companies, and I can tell you there's a lot of things about this technology that is flawed, that doesn't get press. So it's pretty funny when I see that there's challenges out there like Apple, or there was who was it? Challenged somebody to break the iPhone biometrics. People were spoofing, and they proved that they could spoof the finger, but there's a much easier path to this that people didn't take. And I'm sitting there, and we'll cover why biometrics in some cases I think are good, but you change the context and they're terrible. And I'll just expose you to the facts that I know, and you can decide for yourself. But in a general sense, one big problem is you have no revocation. Right? So I mean, if somehow my template, and I'll explain how they work in a minute, my template gets compromised, I can't create another finger. I can't derive another template from the same finger. It's going to be the same template that was compromised. I only have so many heartbeat signatures, probably one, I would imagine. I don't get to enroll different heartbeats. And so you have a problem with revocation. And whenever you can't revoke a credential, I don't think you really have a secure model. Because once it's compromised, you are completely screwed. And there's a lot of other problems with the technology. The short stories are great for identity, terrible for authentication. I'll get into that. We'll do kind of a technical section after this initial what's out there section. And then something you have, right? So that could be an RSA token, an oath one-time password token, SMS, smart cards, PKI. I've seen, how many people know what a scratch card is? Yeah, scratch card. You get a printed card with, it looks like a bingo layout where your application says go to B29 and you read off the numbers that are in B29 and only the issuer knows what was in that spot, and it's cheap. It fits in your wallet. It's a piece of paper. So you're not buying a $10 token. You're just printing out paper. So anyway, not to get into that. And then you have some organizations that are trying to just say, hey, your bank already knows who you are. Just use your bank or ATM card. Scary, but it's happening. Okay, along with using Facebook to log in to whatever, which is not a good idea. But okay. So I want to talk a little bit of the components about lifecycle before I get into reviewing the technologies, because the technologies itself are dependent on whether they can do some of this stuff. When you're thinking about a project for alternatives, the biggest mistake that I've seen people make, and I've done this inside of many, many large organizations for the past 15 years, is they head right to the technology and the device. Oh, I think one-time password. I love this device from Vasco. You push the button and it's U2F and it'll do this, and that's what we need. Stop. Or they think they need a smart card and they Google who makes smart cards and they get the vendor in there and the vendor just wants to sell smart cards. And they don't talk about all the things that you should know, and you wouldn't know them yet, right? They don't talk about keys and key ownership and integration and all this stuff. Just everything works, right? So the first thing is that you really have to talk about your business process. Well, first, I'll go through this. Outcomes. What do you want to achieve out of this? So it comes from stakeholders and what are you trying to secure? What are your assets? What are the outcomes? But from a technical standpoint, I really need to understand this stuff. how's this going to integrate with my back-end systems, whether it's, help desk from Remedy, how's it going to integrate, how's it going to integrate with my IDMS or AD, is it going to impose schema extensions in AD that I really don't want to go through, my IAM people don't want to go through, but I haven't even talked to them yet. So I don't want to have to go ahead and say, great, I got a great deal on this shiny new thing that I thought we needed, but it comes with a $2 million dependency that I didn't think about, that we have to do to upgrade or something to execute it. Or, I've seen this happen. They buy 50,000 of these devices, because the vendor sold it on them, and they stay on the shelf and collect dust because it wouldn't work with their back-end system. I've seen it happen, just stays there on the shelf. Not good, you don't want to be, so you want to be able to figure out the life cycle, the type of events they're going to experience, from locking the device, losing the device, how you're going to get it to them, are highly distributed, and do the workflows to be able to have that as an interface or a process support the life cycle. And do you get reporting throughout that life cycle to have an audit trail that things got issued, who issued it? A lot of these products don't, believe it or not. So if somebody issues a credential, man, I really want to know who had the ability to issue this credential, did it get activated, when did it get activated? I want to know this, right? See, it's all this stuff that seems logical but is missed when we're just thinking about a credential. And your infrastructure, the type of integration, and of course, all the security stuff that we want to talk about. And it's not just about the device. It's about dependent systems. It's about the distribution. So if you're getting the devices from a third party, like a token, somebody manufactures a token, what's their manufacturing process? How do they protect their keys? Who has access to that manufacturing? And so it's not a cloud, but if I order tokens from ABC company, I want to know that their process isn't compromised, because at the end of the day, they have my seeds that I load into my server before I get them, or whether it's other things. So you got to think about these things, because they're really something to think about. In a flow of how you might issue an advanced credential, you might go through a vetting process, okay? So it could be like a government issued ID that gets leveraged, references, a bank verification, the bank already vetted you, some type of accrediting, licensing boards, they already put you through the ringer, and then so the party will go ahead and say, okay, we trust it, we're gonna go ahead and issue you one of these, right? Now, before you use it, we might go ahead and do a live interview, do some background checks, this is all optional, and then we're going to go ahead and do binding, adjudication. You have to come in person, you have to do a bio before we hand it over, and you have to activate it in person or you do it remotely. So there's these intermediate steps of making sure that you were the person enrolled and I'm going to give it to you and allow you to do activation. But then you go through the usage part, right? You might have a remote activation, and then of course, you kind of have these other instances of, it's not just whether it can authenticate, but it comes down to whether you want to provide self-service to people. If I have 100,000 employees, man, I better provide some level of self-service, but it better be secure, or choose what parts of it that I want to have self-service and other parts get on the phone because this is a high-risk scenario. The other thing is I'll talk a little bit about what I call relying parties and IDPs. Who's heard of relying parties, that term, and our IDPs? So, in the traditional sense, we think of ABC organization issuing credentials to their employee, and that's a way it flows. And that is the traditional model when you think of giving RSA tokens to people, in your network. But at the end of the day, it could be where you have another organization that you are doing business with that has their own set of requirements for your employees to access their system, right? And they will be a relying party, and they're not going to be the issuer. So you have the issuer, you have the relying party, and a lot of times, most of the time in the models that we're talking about, the relying party and the issuer have to be the same, and it creates a lot of burden, right? But you have new models coming out where the relying party doesn't have to be the issuer, right? And either you have some really hardcore interoperability to get there, like how many people have heard of PIV? It's a government spec for smart cards. How many have heard of Common Access Card, CAC? Right? So everybody in the military, whether you're DOD, Army, Navy, they have a card with a chip in it, right? That's a CAC card. The next generation is a PIV card. And the whole premise behind the PIV card is interoperable. So if I get issued a certificate from a CA within the department, certification authority, then there's another department that can go ahead and validate that it's valid and call the OCSP, because at the federal bridge level, they have some chain of trust between them. So they're not issuing from the same CA, but they're chaining their trust, and they're certified to be able to do that. Highly complex, not something I would advise a commercial enterprise really doing. It's not there yet. There's other ways to potentially get there. Okay, so I'm going to go into each technology for a few minutes, and then I'm going to talk a little bit about project stuff. Before I talk about each technology and give you my opinion, we can make this a discussion and you have questions and whatever, is how do you sniff out the BS? And what's the BS filter for the vendor pitch around I have the latest, greatest thing, right? So there's a lot of elements, but here are some key elements. And this is what I find as an analyst. I go do requirements for large scale end users. By the way, I forgot to tell you, this is all posted online on my website, this whole deck with notes. And it's on my website. You go to D6 Research, you go to resources, and it's right there, Paswords16 2016. And I'll go back to the original slide, give you the links. It's all there. You don't have to take photos. You can if you want, but it's all there for you. And what I say is, there's a best practice model where things are open. And I like open stuff, not because it's cool, not because I think I should get everything for free, but when things are open, you put it out there for peer review. Everybody gets to kick its tail around and tell you how good or how bad it is, and that feedback comes in, and it goes through a process where everybody wants to get it fixed, and everybody's taking the bus to the same location. So if somebody else has a comment, and the community wants to fix it, it's good for everybody. When I'm in what I call an obscurity model, where they won't tell me what crypto algorithm they're using, well, I'm not going to tell you. That would potentially compromise my solution. Well, I'll tell you what, telling me your algorithm or how you manage keys should not compromise a security solution. You should be able to tell me everything but the private key, right? Or the files to reconstruct the master key, which I wouldn't ask for, right? But I would want to know a lot of things about how you have built your solution, how you manage it, your custodial responsibilities. And here's generally what I would say the good responses are, right? And here are the ones that I typically get where I say, okay, you know what? Deal's over. You've pretty much eliminated yourself because this model right here, I can tell you, can not just be broken, but once it is, it's not fixable, right? That's a problem with the obscurity model, right? The open model, you can always iterate, you can fix, everybody's getting on the same bus, get the same location, it's open. You'll probably catch that stuff before the standard becomes in use. But this stuff, once you compromise it, it's broken because they didn't do it right in the first place, and that's the problem. And so if I take a look at all the technologies I can think of, everything from access cards for physical access and barcodes to PKI certificates, and I think about how strong they are, and I did this a couple of years ago to kind of just start doodling around and, thinking through things and doing an assessment of all these technologies, of how strong they were and what their security models were. I don't know. I wasn't sure where I was going, but it dawned on me that really what happens is that all the weak ones down here, if you notice, that they really aren't big on standards. Just coincidence, right? And the ones that are really strong tend to be more in the standards bucket. And again, I think it's because that peer review. If it sucks, people are going to sniff it out. It's not going to get to scale. It'll get fixed. It gets vetted, right? By the time you figure out there are problems with SHA-1, it's already on SHA-2. You know what I'm saying? So that's very, very important. Okay, all right. So I want to go through some of these and then get a few points in on some business stuff and take questions. But proximity cards for physical access a lot of times stink. How many people have been to talks around breaking proximity cards and stuff, or you've caught one of my talks, and right? There are some proximity cards that are strong, okay, that have not yet been hacked that I know of. And I've peeked behind the covers pretty deeply, and it's a matter of time perhaps, but right now they're much stronger to the point of not associating with maybe the talks that you've seen where you've seen them get exploited, okay? I point that out to not put them all in one bucket, but here's the thing. Even those highly secure cards, which are the minority of the time that you might encounter in an enterprise, are terrible for authenticating to IT systems. Context changes everything. And the reason is because embedded within that RFID card is a vendor-programmed numerical character in binary, right? So let's just say they encoded a 9-digit number, right? It's, it's a number. It's just numerical format. That's what it is. That's all it is. Now, it might be encrypted, but here's the thing. In the system has to know what number it is after it's encrypted. So that's a number that's stored without encryption that is actually figuring out how to authenticate it, right? So that's probably the number that's going to be in an Active Directory, number one. Number two, the source of issuing that number is being used in physical access software. And the physical access software generally, and I can tell you for a fact, for me to go get into an organization and get into an access control system and start peeking around and understanding what somebody's card access number is without the encryption, not terribly hard. So I can find weaker points to get that number in unencrypted form and reapply it. And now what am I left with? I'm left with everything I don't want to do. I'm left with a number that's encoded by the vendor, a vendor default, which actually goes against a lot of audit policies for good reason. I'm left with somebody else encoded it, and they have a record of it, and I have no idea how they're managing those custodial relationships or those records. That's pretty bad. A lot of times they actually encode the number right on the back of the card. Bad practice for a different reason we'll get into. But I can't change it. My whole password policy of changing the password every 30, 60, 90 days, I have no control over that anymore because it's hard-coded into the card. And there's no process to change that. So everything I thought I was getting to go to a more secure model, I'm actually taking a step back from where I was and being able to manage passwords. I would say passwords are better than RFID cards for IT security. Yeah.
Sorry, but you're saying the passwords are better because they can be required to be changed every month?
Because you can change them. You can't change the password. What's that?
Repeat the question as well, please.
The question was, am I saying that passwords are better than RFID cards? Because RFID cards, you can't, because you can change the password. You have a password policy. And I'm saying yes, because if you have a credential, you have a password policy that you could impose changing every 30, 60, 90 days, right? Or whatever it is, but then you implement a credential that has a password, because it's a password in that credential, and I can never change it at all. And I can't make it alphanumeric, and I can't apply any of the policies that I previously had. I would say stay with your previous policy, because at the end of the day, the authentication process has no idea that you're using a card. It's just reading that sequential numeric string.
Well, it's not a password, it's a serial number.
It's a serial number. Right. Yeah, it's an encrypted serial number with a obscure format, and it's not doing any type of random number generator process to make sure that you have the device, and it's just basically, you have that matching number. It's terrible. It just takes you a step back. And this is, I wrote a paper on this. It's on my website, and I saw a lot of organizations doing this because they wanted to use the cards they already had. And since it has a chip and you can't see it, all these companies were doing it. I said, oh man, you just got to know what you're getting into. So anyway, that's the story with that one. Oh boy, biometrics. How many people here like biometrics? Some people. Yeah, like to break them. So biometrics for me is an interesting topic because I worked for a biometric company, and I'm not going to talk about them, but what I'll say about the biometrics is there's a lot of problems. And again, I have a paper on this. You can go check it out. It goes through all of kind of what I think. At the end of the day, there are two types of biometrics. One's called AFIS, which actually does a live scan and it's a real photograph of your finger, and that's used for law enforcement generally. Okay, so when you see like CSI and they have all this blue beep, those systems really work like that. It's kind of amazing. They have all the sound effects. But really, what's used for authentication is a template, which is a mathematical representation. So you'll do a scan of your finger. It'll interpret that, all the data points and the ridges, in how that software and algorithm does the interpretation, which is unique from vendor to vendor. What's unique around the vendors, by the way, is the algorithm and how they interpret those data points. And it gets into a mathematical representation, much like the gobbledygook you would see in a PKI certificate, okay? And what it does is the next time that you go ahead and apply a live finger, it recalls that reference template that was enrolled and compares them. And every time it does that, it's a mathematics thing. It's not security, it's mathematics. They're trying to figure out, does this blob match this current real-time interpretation? And inside of that, they're not always right all the time. In every biometric system, there's a false accept and a false reject rate. And you typically have control whether you want to have more false accepts and more false rejects. You get to tune it, but you can't up both. It's one of these, okay? And so if you're in an organization where you can't have any of those false accepts or false rejects ever, you can add a third factor, or maybe biometrics isn't for you, right? And I'll say that I've seen bugs in some of these biometrics products where if you put your finger in a certain part of the sensor, then it throws the algorithm off and it's like, yeah, just let them in. So it's sometimes not that good, right? The biggest problem with biometrics that I have, it's natively most applications in the IT world don't know what a biometric is. They just don't know. They know what a password is out of the box. They don't know what a biometric is. Applications are learning what a PKI certificate is, but they don't know what a biometric is. So what does it do? The biometrics vendors that you buy will go ahead and say you must deploy this middleware client. This middleware client, you basically stores a reference template to compare to the live finger. It also contains logic to do the comparison in runtime. And then it also has another component that takes your existing password that you're trying to get off of and encrypts it and stores it in a local cache in software. And then when I do a successful match, it will decrypt that cache and send that password back to the application for authentication. So all I'm doing is I'm adding a layer of abstraction, but all my back-end systems are still dependent on that password. What did I solve? I didn't solve the problem in the back end, which is a lot of my big problem. You know, if I'm going to go ahead so anyway, there's a lot of problems. You're still in a password paradigm, and it's very expensive. It doesn't do encryption. It doesn't do a lot of things that you want to do, right?
I'm curious about that nuance real quick. You say generally doesn't encrypt, and then you say can't encrypt immediately afterwards.
Okay, so there's three things around encryption.
It can't hash it, right? But
Yeah. So the password is going to get encrypted in a local cache for use upon when you have an accept, right? And it's going to pass that to the application. And typically that middleware is implementing its own process of how it deals with that process. And that's just encrypting the password. That's one part. The other part is, do they encrypt the template? Because if somebody takes my template, I get into that whole revocation model that I talked about, right? And then there is the other part where I care about authentication, but at the end of the day, I really care about protecting my data. And I may want to go ahead and do SMIME. I want to go ahead and do full disk encryption. I want to encrypt the stuff that's critical. Biometrics don't do that. Now, you can get fancy with biometrics where they add elements in there, but inherently the technology just doesn't do that because it's not key-based, it's mathematical-based. And all these vendors in the biometrics world, the conversations I have with them are typically they're mathematicians or they're marketing, because their whole business is building great algorithms, or as great as they can. And with that, they don't focus on security. They're not people that understand application security very much, but they certainly know how to market to the security market based on the fact this can only be you. But when you start to peel back the layers, that's a challenge.
So are you suggesting then that anyone using biometrics should use the biometrics not to grant access to anything but a key as part of an additional
Good
factor?
question. Good question. Or yes. So I like to say if you want to use biometrics, use it for identification, but not authentication. Because identification systems typically understand what a biometric is. It's kind of native. And you could say, for example, if I'm going to go ahead and use one credential, but that process doesn't check whether I'm the right holder of that credential, the biometric can help do that. Yes, I had the right person, they have the right credentials, so you can use both. But you may be advising an organization that's resistant to doing three-factor, right? So that's why smart cards use a PIN, all right? And the PIN, you have policy behind a PIN, that's good. I'm not going to go through this is physical access sort of cards, data stuff, and Henry wants to talk to me about the payload that's on there. We can do that later. So one-time password tokens, everybody knows what that is, right? So I'm pretty sure whether it's SMS on a mobile phone or a token, and they're pretty good. The challenge with that is that they don't do encryption. They won't do Windows login. They won't do full disk encryption. They won't do SMIME. There's a lot of things they won't do. They'll do VPN or web apps pretty good, which is a benefit, right? So if I'm doing public, private cloud stuff, and they're pretty simple to implement. I don't need a lot of infrastructure. I need a few things, and I can get going pretty quickly. You still need to think about all that lifecycle stuff that I'm finding a lot of these upstart vendors that are getting a lot of funding, they're missing. They're just getting into the space without really understanding how you deal with lifecycle events at scale. And I find that their technology in use is good, but the management of it is lacking, right? And a lot of times they don't have the visibility into this, so they're well intended, but you have to fish that out. I get into smart cards and certificates. So smart cards are pretty cool because it's public-private key. It does all the things that you might want to do. The private key is always protected in the device. You have policy, so only the person that's issued can operate that device. It can do many different things, and it's incredibly secure when you implement it correctly. The challenge is you need a lot of infrastructure. You need a lot of key management. You need a lot of things to make this work correctly. And of recent times, the challenge is not only that it's complex and resource intensive, but it's terrible for mobile and cloud. And most of my clients that did smart cards a while ago are killing off these smart card projects because the vendors haven't yet figured out how to really implement it well for mobile and cloud. And that's where their executives said, we're taking some applications there. Access to everybody all the time, too bad, right? So this is starting to be addressed, but it's going to be a little while. And one of the things I like here is U2F. So U2F is pretty cool. It's not the end all, right? So U2F is a specification, it's not a standard. And U2F fills kind of this thing where if you like asymmetric, which I do, asymmetric key, public-private key, the private key stored in a secure element, never leaves the device, and smart cards were never really built to work with web interfaces well at all. U2F was created by Google and Yubico doing some things and saying, hey, we should open this up, where it integrates at the browser level without having to go ahead and install any drivers or middleware. And it addresses that web scenario in a very simple, consumable way very nicely. One of the things that it doesn't do is it won't do like SMIME, and it won't do all these other things that you might want to do with a smart card. But to keep in mind, what you can do is you can virtualize U2F. This is what's coming next. You can virtualize U2F as an applet and shove it into a secure element where now you have the best of SMIME and U2F without drivers and all this stuff. The biggest thing about U2F that is really groundbreaking is that the way it works is how you go, you get issued a device from whoever, and you go to a service. Let's say it's ABC, let's say it's Amazon. Why not, all right? You go to Amazon, and let's just say they have a U2F server and a U2F service. I can go there, and I plug it in, and I register it, and what it does is it issues a private key directly to my secure element, right? It takes my device ID that has a public key, and it says, oh, okay, I'm going to issue a private one that's only bound for this service. And then I can go to another place that's totally disconnected from Amazon or who issued it to me and repeat the process. And so U2F can go ahead and support multiple different U2F services or relying parties without the relying party actually issuing the device. So it solves that problem that we talked about early on, which means you have immense scale, or if I run a forum and I want strong authentication, I can just do a risk score and say, hey, anybody that wants to use their U2F device, we have a U2F service, and it might just point it somewhere else, and people can use their U2F device, right? Public-private key and all that stuff. What else do I want to talk about for a minute before I go into Q&A? There's some business stuff. The last thing I want to talk about for a minute is, so what do you do at the organization level? I like to say you don't go in there and say, hey, I want to fix all your problems. It's a technical problem, because there's only so much money to go around, And the CISO's looking at it like, okay, yeah, this is important, but it could be number 22 on my list after you talk to me, right? So I like to say, okay, let's work backwards from a threat model standpoint and say, look, what's most likely and highest impact? And you kind of do this for every organization uniquely, because this is generic as an example. And right here, if you can find there's several that are likely and high impact, a CISO is going to start to say, I can kill 3-4 birds with one stone. That might be worthwhile doing. And you can start to build that technical case, and then you need to build that business case, because there's some elements where I had a client where the CISO was bonused on trying to go ahead and find additional use cases for security. And then the CIO, and this is a $10 billion organization, the CIO wanted to actually prove to the CFO and the CEO that he could be a business executive. So he was trying to figure out how to address problems that would save him money. And then so what you ended up with, the solution would help them actually reduce a lot of their office space by virtualizing things and using thin clients and unique identities, and they lowered their tax liability. So the CFO got on board, the CIO got on board, not for security, and they're pushing through this $10 million project, all because different stakeholders. It's not just a security stakeholder thing that you're selling to. You got to translate security at the value of security, which we all live in, that's secure, it's going to do what it's supposed to do, and it's going to reduce risk. But in order for a CFO to fund it, you got to get them something. And sometimes it's reducing areas even outside of security, right? And I have models around this if you want to talk. But my parting words, I have other slides, but I'm not going to get to them. But my parting words would be, when you go into this project, you have to take a technical track and talk about the vulnerabilities and assets and controls and whether these things are going to do what we're talking about. But at another level, you have to figure out who the stakeholders are and get their input. Because without finding out who the stakeholders are, you don't really know what the capability of this thing needs to be. What are the use cases? For who? Who's going to be using it? What are the barriers for acceptance? Will be user mutiny. And then from there, you translate it to compatibility and technical. Don't just take the technical track. Seek out the stakeholders that aren't in security, get their feedback, know what this thing has to look like, what it has to do, what the success criteria is. You have all those elements, you can start to build a TCO, ROI model, a technical model, and then it can be interpreted by different stakeholders to have those real discussions. Because without it, you're going to run into barriers where they just tell you no. Somebody's telling you no, it's because somebody else above said, I don't have time, this isn't a priority, and you just get shut down not to get to the bottom of it, right? So, okay, I'm out of time. I'm going to take a couple questions maybe.
Questions? Raise your hand.
Put up your identification slide, your last slide.
The last slide?
Your GitHub link or your name?
Yeah.
Oh, well,
So there's a slide with a link on it.
Contact information, basically.
Okay, so I have my contact info here.
Ooh, yeah.
And then the link I have is on the first slide. I probably should have it on this slide. So everybody kind of got that? And I'll throw it to the first slide in a minute so you can get the link to the pre-zo.
Yep.
Yeah. Then you go to research and go to resources, it'll be right there. So.
One of the things I do back in Norway, Terry, is I teach the ISAC, Certified Information Security Manager course. And every time I have students doing that, the first thing I do on day one of the course is to ask them to write down the vision, the goals, and the strategy of the company they're working for. It's always kind of fun to see how people react to that because, well, I'm working with security, why I'm supposed to know about the vision and goals and strategy of my employer. And I teach them something else. Okay, questions? Oh, Jeff, somebody else? I'll do this.
What's wrong with Jeff?
Oh, I talk too much.
We'll cut you off. Sorry. Awesome.
All right, so with multiple factor for replacing password, how do you deal with recovery? Particularly, let's say you use some new factor, U2F token, you lost your U2F token somewhere in Vegas.
Yep.
So how do you recover access?
So U2F, for me, the way I see it is kind of a problem right now. It's immature. But if you go to something like, let's take a smart card, for example. Right? So for like a OTP token, you're going to reissue a new one. You're going to reissue a new seed, and either a new token or associate that seed to the virtual application that you pushed out. But a smart card is a good example because, like U2F, it's based on a PKI model, right? Because they're both X509. And the reason why I use smart card is because it is a mature model, maybe not as scalable as we want for new uses, but it's a good model that that's where it gets back to key management. So the first thing I would do is I'm gonna go ahead and do a transport key with the manufacturer of the cards. And then when I receive the cards, I'm gonna do a key ceremony to create my own master key set so nobody else knows them, even after transport. Okay? Now I manage all my own keys. My certificates are in my own CA or a third-party CA, whatever it is. And so what I would typically do in that scenario is I would go ahead and issue you new authentication and signing certificates, but I would do escrow of your authentication certificates. And upon issuing your new smart card, I would go ahead and issue you I would issue basically key history. So anything you previously encrypted, you can decrypt in the future. And that's where PKI and key management gets very difficult because now you're getting into key management escrow and recovery and how do I go ahead and get key history out to somebody that's across the continent. You can do this in some of these modes through clients and automation, but it's got to be rock solid. If you have 10,000 users and they go through a process that doesn't work half the time, or they don't know what's happening while nothing is showing, but it's really going to be around escrow and key history is the way I see it, in a very secure and scalable model. And then some technologies aren't capable of that.
We have to end it here. Thank you again,
All
Terry.
right. Thank you.
And that's it for B-Sides Las Vegas and the Passwords track. I hope I have been able to give you some funny jokes at least. You can find everything, the videos have been streaming. We have been streaming everything. The recordings should become available in the next couple of days. We will also try to of course, on passwords16.org, we will have links to relevant speakers, papers, talks, as soon as we have them, and also build the archives for the video recordings. So enjoy the rest of the day. The pool party starts at 10, and there will be drinks, food, music, and the music isn't that loud, so it's actually possible to talk to people as well. Steve? 10:30. 10:30. Pool party starts at 10:30. Okay, see you there and enjoy.